Hi, everyone. We're going to get started pretty soon. We're just waiting for a few more people to dial in, and then we'll get rolling. Thank you. All right, so I still see the participant list increasing pretty steadily. So we'll give it maybe just one more minute and then we'll get started. Thanks for everyone's patience. All right, everyone, here we go. Welcome to VeloCON 2022. My name is Carlos Canto. I'm the community manager here for Velociraptor and here at Rapid7. I want to welcome you all to this really groundbreaking event. It's an event that's really been over a year in the making. And we just want to thank you for being here on this incredible learning adventure and this celebration of all things Velociraptor and DFIR. We have a really impressive panel of speakers that I'm really excited about. And we're not going to waste too much time. I just want to quickly go through some of the logistics for today. Here's the agenda for the full day. It's pretty much broken into 4 sessions. So we'll have 2 morning sessions, a break in between, and then lunch. And then we'll have 2 afternoon sessions with another break in between. I won't go through the whole agenda right now. Everything is on the Velociraptor website if you want to take a look. There is one audible that we're going to have to call today. We did have to swap around a couple of the presentations. One of our panelists is experiencing some challenging weather conditions right now, so he's not quite sure about his internet connection. So we kind of moved his presentation to the end. But other than that, the agenda is pretty solid as it's been for a few weeks now. A couple of resources for you guys as we go throughout the day here at VeloCON. As you probably have noticed from the Zoom webinar screen, this webinar is being recorded in the cloud. We'll make this recording available for everyone at the conclusion of the event, and for anyone that didn't or that wasn't able to participate live. We are also live streaming this on YouTube. So if for whatever reason, and we are experiencing a pretty heavy attendance today. If for whatever reason you're kicked out of the webinar, you're experiencing technical issues and you just can't get back into the Zoom, you are able to stream the event on YouTube as well. If you just search for Velocidex Enterprises or just Velocidex on YouTube, it'll be the first one that comes up. Just click on the little dinosaur logo and you should see the event streaming right there. I will kind of ask that you don't, or kind of remind you that you don't just search for Velociraptor. You're just going to get a slew of, dinosaur and Jurassic Park web pages and videos and stuff like that. So make sure if you are going to stream on YouTube, make sure you're searching for Velocidex. In addition, we are going to be taking questions throughout the day from our panelists. Some of these questions will be taken live during the presentation. Some of them will be taken at the end of each individual panelist's presentation. We do ask that if you do have a question, you guys are probably familiar with the Q&A process here in Zoom, but we would ask, if possible, that you'd use Discord instead. The reason being, once the webinar is over, all of these questions will go into the ether somewhere and won't be able to retrieve them. However, on Discord, we'll be able to archive them. We'll be able to go back to them, answer you, after the event if possible, and if needed. So please go onto Discord instead. You can search for the Velociraptor Discord server, but probably the easiest way to get there is to go onto the Velociraptor website at docs.velociraptor.app. Right on the side navigation, there should be a link for the Discord server, but if you just append the Discord to the end of the URL, you'll get there as well. There is a channel within the Discord server called VeloCON 2022. Please insert any of your questions in there. We will be monitoring that queue for those questions, and then we'll prompt the panelists to answer them in real time if they can. Okay, and with that, we're going to get started. It's just about 9:10. I'm going to hand it over to Mike Cohen, who almost all of you guys should know at this point. He is the father of Velociraptor. He has been at this for a while now. I've had the pleasure of working with Mike for just over a year now. I've really gotten to know him. He is a wealth of cybersecurity knowledge. He has over 20 years experience actually applying and developing novel incident response and digital forensic tools and techniques. He has previously worked in the Australian Department of Defence as an information security specialist, at the Australian Federal Police specializing in digital forensics, network and memory forensics. Mike joined Rapid7 to support and develop Velociraptor, which you guys all know is an advanced open source endpoint visibility tool. With that, I'm going to hand it over to you, the man, the myth, the legend, Dr. Mike Cohen.
Thanks for that. Let me just share my screen. Continue. You guys see that? Can you see that?
Yes, we can.
Yeah.
You're looking
All
good.
right,
Yep.
cool. All right, cool. Let's just get started. So I actually originally had this talk at the end, and but because of the swap, I think it works just as well at the beginning of the conference. So I just wanted to kind of have a little bit of short kind of talk about some of, like just, remembering what happened this year. And it was just like a big whirlwind of a year. There was so much development and excitement happening in the past year. So I just thought I'll just, dive into it and go back and look at some of those features or things that we've done this year that are really useful for, developing and advancing Velociraptor. So let's just have a look. Okay. So the latest release is 066, right? And that's just came out, very recently, a few weeks ago, days ago. And it's really, really cool how much community engagement that we've got and how many people have contributed bug fixes and bug reports. And it has so many features. So let's just go back and have a look at some of the past year and what kind of features there are. So it's kind of like an unordered list of what I thought was kind of useful. So I just kind of like went through the commit logs and went through all the features and went, oh, that's cool. So the first one I want to talk about is the glob plugin. And as you know, the glob plugin is used to search for files, and it used to always have problems because on Linux, it would go into /proc and then just kind of get lost in all the symlinks, and or it might actually like leak into a network file system NFS and then start to get lost in there. So having this ability to put like this recursion callback in there, so we could actually like really tighten down how we're searching for files, really helps to control where we're going. And it turns out that searching for files on Linux is kind of tricky because there are lots of little pitfalls where you can kind of end up, going into, various file systems. So this is really important. There is actually also a blog post about that, but just bear in mind as, searching for files on Linux, you have to kind of like make sure that, and that's why the Linux file finder has been adapted for this. The other cool thing that we had, a lot of people have asked us to create notebooks that they could reuse, because notebooks, as you know, are just a way of reusing, of doing post-processing and looking at the data and communicating that and collaboratively working on analyzing results from cases. And so people found that they have a lot of these kind of common cells, these common queries. And so people wanted to import or export notebooks. So we can export the notebooks, but importing them is a little bit hard to do correctly because it has to be kind of in the context of whatever you're searching. So now it's possible to just like add these cells to artifacts. So when we create a new artifact, we can actually also add a suggested post-processing flow to it. So I just wanted to show you an example. This is already out there, it's just been there for a while, but maybe a lot of people don't know about it, is that you can actually add a notebook section to the artifact definition and define it as a suggestion. And so that the user can look at the notebook and then they just can use that cell as a suggestion. So they can, right click, and when they right click the menu, they get a list of suggestions. And then whenever we're collecting that artifact, that's, those suggestions show up. And so these are like suggestions of how to do this post-processing for this particular, like in this case, the generic client info, you can look at all the different, when you're doing a hunt for this, then you can find all the domain roles. And then, in this case, you can, label the domain controllers, for example, very easily. So this is what that suggestion does, right? So we can just add it in and it just creates a cell automatically with that. And then we can just, use that. to do specialized post-processing. So it's one of those features that's been there for a while, but maybe a lot of people don't know about it, and it's not that well used. So maybe we could use it more. The other really cool thing that happened, over the last year is the binary parser has been like really put through its paces. And I think I've talked about this before, that in Velociraptor we have a binary parser that we can use to actually parse binary data using VQL. So the cool thing about it is that you can write pure VQL and you can do some pretty serious parsing. So some of the artifacts that have been used with the binary parser are like link files, which are fairly complex, and we really put the binary parser through its paces. The other really cool thing that I wanted to mention here was the Cobalt Strike configuration parser that Matt Green has written, and that is, I think, like a really super cool example of how much you can achieve with this, with this parser, because it's actually a pretty powerful parser, and this is another really cool example. So prefetch files. We used to have a Go-based parser for prefetch files, but it turns out that it's just easy to parse it with VQL. I mean, maybe it's a little bit slower, but it's not that important, because then if we have to modify it or change it, we just really change the VQL, and then we can change the way that we're parsing. So we can support, slight variations in the future. So it's much more maintainable. This is an example of what it looks like, and if you've ever seen, volatility or recall type profiles, it's a similar thing. It has a profile and you can define the binary parser. So it's one of those things that if you're not really super familiar with binary parsing, take the time, have a look at it, because it's super powerful feature that's really matured this year, and and it's really quite powerful. With the link parser, we can parse link files all in VQL, just pure VQL, and we can extract, the targets of, the link files, because, that is actually, an area of concern, link file parsing. This is the Cobalt Strike config that I mentioned before that Matt wrote. And it's really an amazing artifact, the amount of details that it can actually extract from memory. It actually carves out, it's a carver that carves out the configuration file from the Cobalt Strike configuration file from memory, which is XOR encrypted. So it then decrypts it and then extracts all the data and parses it. So which is pretty amazing how it works. It's probably one of the best examples of how to use these binary parsers. It's really cool. So I'm actually I'm pretty excited about that. That was really cool. The other thing that we found was, like if you run Velociraptor from a year ago, it would just look like a completely different application. It would just be, much slower and more frustrating, and and so it's just nice to look at the maturity of the tool. One of the things that we've added was the in-memory search index. Before that, we used to have the search index on disk, and it was always very slow, and there was limitations because you had to kind of access the disk all the time. And by moving the index into memory, that makes it instant. So we can do like a lot more cool stuff with it. We can search, for example, by MAC and IP addresses, which change all the time. So we couldn't really do it on the disk because it would have changed all the time. And now we can do that. And the other cool thing is we can estimate hunt impact quickly. When we're doing a hunt over thousands of machines, we want to make sure that we don't, that we target the right number of machines that we think we are targeting, right? So, for example, like in the hunt manager, now there is a little, informational box here to tell us how many clients we think that we might impact, right? So, if you are targeting by label, as in this case, and then you want to, you think, okay, I've got probably like, 10, 20 machines, but, maybe the label's applied on thousands of machines or something like that. So it's just like a double check to say, hey, this does make sense. Does that make sense? And as you can see here, we can also look at how recently machines are active, right? So 1 day actives, 1 week actives, and 1 month actives shows us, how many machines will be impacted that are likely to have this hunt. So if the hunt only lasts for a day, we probably only care about 1 day actives, So this feature is only really possible by having this very fast index so that we can search for it, which was really cool. So that was a really cool feature that made it kind of like nice to use as well. In terms of parsing and parsing, there's lots of extra parsing going on. One of my favorite types of artifacts, plugins that we added was the Authenticode and PE support in Velociraptor. And we actually have an Authenticode. We can parse not only just the Authenticode signature and the PE files, but we can actually also resolve catalog files, which is really interesting, because a lot of files on Windows aren't really signed with PE Authenticode. The way that they are signed is through catalogs. So we could never in the past do that because the file itself doesn't have a PE structure. It doesn't have Authenticode in the PE structure. Instead, you just have this hash, and the hash appears in a catalog, and that's how it's signed, right? So, for example, in Notepad, if you right-click Notepad, it doesn't show that it's signed, but it is really signed. So that is actually really important because it helps us to filter out all of those signed binaries that are legitimate, so that we can easily focus on those non-signed binaries. So that's a pretty cool parser. And then we have a lot of UI-based changes that make the UI much easier to use. In this, I just wanted to show some of those artifact parameters. As you know, when you write an artifact, you can have parameters and you can give them different types. And so we used to have like very simple, like, string or integer or whatever. But now we actually have a lot of specialized types for parameters. And that means that the UI can actually be made to help the user to write the correct type of artifact. So for example, when we define an artifact as a regular expression, the UI has a regular expression editor. So then we can, trap errors. We used to have problems like, someone would run a hunt and then have a problem in the regular expression, or like it would be invalid or something. And so, they would do all that work for nothing because none of the artifacts would work and come back, right? So having this regular expression editor and validator UI really helps. So here's an example of one of the artifacts, generic detection Yara glob. And I just wanted to show some of the cool features of these parameters. These are all just defined in the artifact as parameter types. And we've got the Boolean and date selectors, so we can choose that. But even here we have an upload URL, so we can actually upload an entire Yara rule set. If it's got many rules, we can upload the whole thing into the artifact when we launch it. So it's just part of the parameter. Then it just appears, in the VQL ready to use, right? So you don't really have to do anything special to handle this upload. And then down here, we have a Yara rule. So there's actually a Yara editor with syntax highlighting. So it allows, people to actually edit the Yara rules and, and that sort of thing. So it makes it easier to edit Yara rules. Another cool thing that I thought was useful to mention is the ability to have multiple OAuth 2 providers. And this is something that a lot of users ask for, especially if they're doing consulting. And sometimes when people are consulting for external customers, they want to allow the the customer to also have access to the Velociraptor server. So maybe only read-only access, or but just to be able to log in. And it's always very difficult because before, we could have always had OAuth 2 providers for Velociraptor, but let's say you're a company that's doing, consulting, and let's say you use Okta. and you use Okta, and so you log in with Okta, and that's great. But then you want to give someone else access to your Velociraptor deployment, but they don't have Okta, or if they have Okta, it's not in the same org as you. So it's very complicated. You're going to have to create like accounts and share it with them and assign it to them, and it's very complicated. So this feature where we can actually just have multiple providers, that really helps a lot. So here's an example of what the login screen looks like when you have multiple providers. Is you can basically say sign in with any of these credentials. It's all good, right? And so you can just allow them to sign in with their own provider or their own identity or whatever. And then when they sign in with their own credentials, and then they get access to. So it doesn't matter from Velociraptor's point of view who is authorizing this user, as long as one of these providers is authorizing, that's fine, right? So so if we do that, then it allows us to share Velociraptor with all the customers. So that's a really cool one. I really, that's one of those things that's not very difficult to implement, but it's so useful, from the user perspective. I love these kind of features, right? The other thing that we had is a whole bunch of effort around documentation and sharing and community building. And the whole point of Velociraptor is to build up this community where people can exchange, VQL artifacts or exchange knowledge. And so now we have knowledge base, and we have an artifact exchange. These are places where people can share their experiences. So if you go to the website, we have the artifact exchange where people anyone can submit their artifact. They can share their artifact, click this button, and then paste it into the GitHub form. Or you can search for an artifact that you could use or want to look at. And then we have a knowledge base as well. So when people ask questions, that's been incredibly useful, because a lot of people ask the same kind of questions. And so these are really small, like bite-sized pieces of information, like how do I do this? How do I do certain things? And so it doesn't have to be like huge blog posts with lots of screenshots and stuff. It can just be like a very small, like 1 or 2 paragraphs. And and this kind of thing is like super useful. So if you ever have any kind of questions, check out the knowledge base first, because it's probably in there. And if it's not in there, then just add it in there so we can all share those questions together, right? Then we have so one of the interesting things that in terms of VQL that was added this year was path handling in VQL. And path handling is really complicated because paths are just so badly defined, right? There's there's Windows paths and Linux paths, and then there's registry paths, and the rules around paths are actually very complicated and not very consistent across different operating systems. So in VQL, there was a big change that we made internally to be able to handle paths in a consistent way. So paths are no longer just strings, right? They're actually objects that are aware of what they're doing. They're aware of paths. So a path, you might notice that an OS path starts popping up in all these VQL queries. And OS path is really an object that represents a path. And it means it retains the fact that it's got little components, right? So each directory in the path is a component. And then it means that we can use that object to just kind of do path manipulation very easily. We can just add paths together and so concatenate them and split them. And so we don't really need to do things like splitting on slash, which was done like so many times, before that, because it's actually very flaky to do this kind of splitting on slash. And sometimes it's not slash, sometimes it's backslash, sometimes it's forward slash, sometimes there's 2 slashes, it becomes very complicated to really handle that correctly. So OS paths really just does away with all that and keeps everything consistent as all the way through. I just put a little bit of VQL here just to show you like some of the way that this OS path makes writing VQL so much easier. You can see that when we're doing a glob, then the glob plugin actually emits this OS path, which is an object. And then if we just want a directory, path, we just go call .dname. Boom, there's a directory. And then we can append a string to the directory with an addition, and it overloads addition and creates another path, so it already knows that, if you add a string to it, it's going to make a path, inside of the directory. So these kind of operations basically are done very transparently. So, here we are, checking the base name, which is the last part of the path, right? So we don't really need to do these splits on slashes and, these things that we did before. So if you haven't really played with OSPath and understood how that works, I really encourage you to do that, because it makes writing these artifacts so much more easier. Another big feature we had was dead disk analysis. A lot of people wanted to do dead disk analysis. And to be honest, we don't really do a lot of dead disk analysis, because just doesn't scale. Like, you're not going to really get a disk image these days for DFIR. But, some people still do it. And so that feature went in. It was quite a major feature to make it work. It was enabled by having this very accurate path manipulation type that I mentioned just before. And it turned out that although this feature was like, we don't use it that much, but it turned out that it makes it really, really easy to create these tests for artifacts. Because when you have an image, then you can essentially say to Velociraptor, hey, imagine this is a Windows machine, and you might just be an image of not a full Windows machine, but like an image of an NTFS drive. And so you might just run all the artifacts on that and have these regression tests. So we use it heavily in the testing side of artifact testing side of the code. So it turned out that it's one of those features that, like, we didn't think it would be super useful, but once we put it in, it actually turns out really useful, but not for the original purpose that people wanted it for. Finally, the coolest new things that I just wanted to mention is the process tracker. And there is a blog post about it. I'm really super excited about it, because it's one of the examples of kind of like, I guess, this kind of trend that we are seeing. And in having Velociraptor enrich and develop this information about the endpoint, just by collecting this information all the time. So the process tracker is a feature in Velociraptor where it keeps track of processes on the endpoint. And it basically just kind of like keeps track of exited processes and their relationship. So even in the future, if you ask it, hey, where did this process come from? Even if the parents of the process have exited or something like that, then the process tracker can answer that question, because it's seen it before. So it's kind of like where we are collecting extra information. When you think about it, forensics is really all about trying to reconstruct the past. Well, why do we need to reconstruct the past? Because we didn't record it properly in the first place. So if we can actually just go through and record whatever happened correctly, then we don't need to reconstruct it, because it's there, right? So if we have a record of all the processes, where did they start, where did they end, what happened, then we don't really need to kind of figure it out. We just ask it. So this is kind of the point, of the process tracker. So this is an example of the process tracker figuring out, that this notepad has actually gone, from a peers exec. There's a blog post here. You guys can take a look. But it's actually like, it really opens the door on really cool new possibilities. And then we had lots of, small changes that just make it really cool to use the tool. So we have a large number of themes to choose from now. And this is one of my favorite. It's the pink one. But you can see there's a big list of different themes here. And they're pretty cool. I'm just going to show them off as I go along. And then we can have different languages, which is actually pretty cool as well. I was very excited about that feature, because our user base are, obviously global in nature. So it's kind of nice to have it in your own language. I mean, not everything is translated, as you can see, like the artifacts themselves are, obviously in whatever language, they've been written in, but the interface in general is, a little bit translated. Which is kind of cool. The other cool thing that I thought was useful is the time zones. Now, I know initially we were like hardline, you're doing forensics, you're going to use UTC. But like using UTC and everything is really kind of annoying and it's confusing, right? And so if your case is, centered around a particular location, Sydney, Australia, or whatever, then you just want to be able to see your time zones in that time zone, in that time zone, or all the timestamps in that time zone. It doesn't really matter because at the end, all the timestamps always have the time zone in them anyway, because they're all standard RFC based timestamps. So it doesn't matter, but being able to change the interface, the whole interface, into the different time zones is really helpful because you can change and see, times in the relevant area. And this is a really new feature that's been added in 066. Having a right-click menu where we can just like copy a cell and send it to VirusTotal. So in here, for example, we're calculating a hash because we're doing a PS list. So we're calculating a hash, and we can just right-click the hash and send it to VirusTotal and see whether the binary is, legit or not, whatever, right? So it just makes it very quick to just do like a spot check, and we can do Subachef and Google and other things as well. So it's quite neat, and it's also configurable, so people can change that. And then finally, the last cool feature is the multi-org support, which is just coming in 066, and it's a huge feature, but it's actually really cool, and it makes it so much better. Because you can now create different orgs in the same Velociraptor deployment, and you can separate clients into separate orgs and switch between them, and they're completely separated. So they're just kind of like they're separated. So you can use that to separate clients into groups, and it actually makes it really easy when you have a lot of customers, because you can onboard them in a new org, do the IR. And then at the end of the job, you just destroy the org and move on, right? So you don't really need to constantly be building new servers or whatever, right? And also, it's much more efficient in terms of in terms of resource utilization. So if you have a Velociraptor server and then you only have a small customer, you can probably put them in an org on an existing server. You don't need to create a whole other instance just for that. So that's a really cool one. There is a link here if you want to read more about it, but it's actually super easy to use. All you do is you go in to the UI and switch orgs, and then it tells you on the on the top right which org you're in. So it's still kind of like experimental for 066, but it's a huge feature that would be really useful. Finally, resource controls on endpoints. That was a big one. People, one of the risks with running queries on endpoints is that we don't know necessarily, how much resources it's going to take on the endpoint. So now we've got much better control over CPU loads and so on. And it's just up there. So we have like real resource control, real CPU limits. And then we had performance stability. We had master minion architecture, which allows us to scale up to very large sizes. And I've got a screenshot here, and you can see that a user sent it to me to, you can see that's 125,000 odd, endpoints. So, and this is, I think it was like 8 minions or maybe 10. So that gives you an idea of the size of the deployment. So that's the architecture, and, there's a blog post about it. So, and it is the same Velociraptor that everyone else is using. It's just used in a slightly different configuration. So just to wrap it up, where do we need to go next year? So that was the past. It's nice to reminisce over, last year and see what we've done. Where do we want to go? So we want to go with better stability, scalability. We want to go up to much bigger sizes. And I'm going to talk later on about Client Velociraptor, which is, the next scale up. We'll talk about that. DFIR parsers, and concentrate a lot on client monitoring queries. The process tracker is really exciting in terms of the possibilities that it offers. And we can use the same idea to monitor for more information about the endpoint. And so really we do a lot of work on this. And then build alerts as I know that some people say that Velociraptor is an EDR, but it's not an EDR because it doesn't really have alerts right now, and there's not really any way to escalate. I mean, it is, but it's clunky, right? So we need to run streamline this this alert mechanism and make sure that we can handle it much more efficiently. So that's the next year, but ultimately, it's not really up to us to dream up what we're going to do next year, but it's really up to the community to help drive this future development. I mean, without the community, we couldn't really, be where we are. And it's really those bug reports, feature requests, and ideas that we're getting back from our community that help us build the tool that you want to use, right? So at the end of the day, we need to really need to get that feedback, and we appreciate everybody's, filling in, issues on the GitHub and so on. So join in to Discord, GitHub, and have a play with Velociraptor. I don't know how I'm going for time, but I'm not sure if I have.
We're just up against the first time slot here.
Okay.
Mike, we don't have any questions. We do have a comment in the Discord channel. If you want to kind of just answer that or speak to that.
Okay.
The comment is, process tracker looks like Velociraptor is wading into EDR territory.
Yeah.
What do you have to say about that?
Well, as I said, I think it's really cool, right? Because, where was it? I think it's been.
It was in the Discord channel.
Yeah. So the process tracker, I'm just going to show you the process tracker again. Yeah. So we're kind of finding out these kind of things. So Velociraptor's, philosophy is endpoint visibility, right? So I don't like to put labels on what we want to actually do, but we really want to increase visibility. And I think the point that I made before was that, we talk about forensics. And when you think about what is forensics, what's the point of forensics, right? The point is to try and figure out what happened, right? That's kind of what forensics is, right? So, forensics is really kind of like an after the fact kind of thing. So you come in and you're like, okay, what happened? But really, when you think about it, the reason that we're coming in after the fact is because we didn't record that information, in the first place. So if you're doing an IR and you don't have Velociraptor and then you deploy Velociraptor, then to look at historical stuff, you're going to need forensics, right? But once you have Velociraptor in there, well, why don't we actually figure out recording, what actually happened, and and then we've got the information in much higher quality data than we can get with just forensics, right? Because we can control the the recording part. So that's kind of what I'm thinking. The goal is not ultimately, it's not really a label thing, right? I don't like to label it. The goal is to figure out what happened, right? And whether you call it EDR or forensics or whatever. I mean, they're just different methods of answering those questions. But at the end, we really need to know those questions, like how did this process get there? What did the process do, in the past? That kind of thing. So yeah, so is it wading into EDR? Maybe, but ultimately, EDR is so much more, and it's a different focus, right? So yeah, there's going to be some overlap, I guess, but we'll see. I mean, at the end, we're just going to develop something that, that would be useful, for people, right? So yeah. Cool. Is there any more questions?
One more question. Can you expand on the capabilities of the offline collector?
Okay, so the offline collector was kind of like, I didn't include it because we didn't really do a lot of work on it in this year. Well, no, we did a little bit of work. We've got resource controls on it, and but it's been like there for a long time. And really, the offline collector is what people use when they don't have Velociraptor. So, if people come into Velociraptor from a DFIR triage background and they're using like CAPE or other sort of triage tools, and and they don't have Velociraptor installed, then the offline collector is a great on-ramp, right? But it's it's kind of limited. Like you can't do things like this. Like you can't do process tracker because it's not running all the time, right? So it can't, and it's more of a one-shot thing. So, I mean, it's okay to use for collecting a lot of files, a lot of data, but that's not really what the rapid triage philosophy is really around, right? Rapid triage is about being able to pivot and collect very targeted data, but with the offline collector you tend to collect everything, all the MFTs and all the prefetch and all the files, right? So you don't really kind of iterate through because you don't get a chance to, because it's not running all the time. So the offline collector is a good feature, and a lot of people use it, right? But I would consider it as kind of like an initial feature, like an onboarding feature when people are getting kind of familiar with it. But ultimately they'd use the real thing, in the end.
Cool. I think with that, we should move on to the next segment. But
cool,
thanks.
Mike. Thank you.
Enlightening as usual.
Thanks.
All right. So we'll just move right along. Just going to share my screen real quick. Okay, so our next presentation is by Matt Green, also a member of the Velociraptor team here at Rapid7. His presentation is Notebook and VQL data munging, your way to victory. And for those of you that don't know Matt, he is our principal engineer here at Rapid7 on Velociraptor. He is an endpoint and threat-focused practitioner, and he has been an early adopter who's been working with Velociraptor since version 0.2. And Mike and I were talking about this with Matt the other day. Mike doesn't even remember version 0.2. That's how long Matt has been with us. So he definitely comes with a tremendous amount of knowledge and experience with Velociraptor, and we're really excited to see what he has to say today. So Matt, if you don't mind, take it away.
Sounds good. Thanks, guys. I'll just share my screen, so bear with me while I figure this out. Can you see that okay, Carlos?
Looks good.
Awesome. Okay, so yeah, my talk today is about Notebook and VQL, data munging your way to victory. The agenda today, I'm going to give a bit of a background. I'm going to then focus on some examples. And again, that's going to be focused on some of the gaps that we see. And it was really awesome to have Mike lead in, because this talk is kind of an intermediate level. So the assumed knowledge, Mike has just explained everything, so that makes it really easy for me. I'm then going to cover some practical application, and that's where we start to get really complex. And for me, it's usually I do demos and stuff for the practical side, but I wanted people to be able to see the VQL. So this is a new thing for me. So I apologize in advance if the VQL doesn't show too good, but I think it looks okay. I think it looks okay. So we've only got about 30 minutes. So I'll get into it, and these slides will be available afterwards. And I'm also sharing some artifacts, and I'll share some notebooks as well, and I'll throw the links in the slides. Okay, so what is Velociraptor? Now, Mark's covered this off pretty well, so we'll skip ahead. But this slide I wanted to cover off was the architecture. The architecture I'm covering off today is a server-client model. Most of the stuff in the workflow I'm talking about is focused on essentially optimizing this workflow here. And I've seen lots of other people start to do like WebExes and things like that. And a term that I've coined a while ago is live response. And that's essentially the concept of collecting rows from the endpoint and then doing some analysis on that, and then pivoting and repeating really fast. Of course, we can collect raw artifacts, we can process them in other tools and then bounce to other tools as well. But for the most part, if I'm doing an IR, I'm really only doing that for preservation, and then if I need to answer specific questions. It's all about speed with Velociraptor. And just like that guy in the picture there, it's awesome when it works. Right, so here's some links that I'll share, and I'll bounce through this. but these are available, and I've also got some extra links down the bottom. But to start this kind of workflow, it all starts off with the collection, right? So the picture on the screen, I'm running a hunt. I'm selecting my artifacts. In this case, I'm focusing on ASEP, so auto runs and start items. But the point I wanted to cover with artifacts in general was typically we write them to be either very like targeted, or the ability to add filters and things. So you can do like IOC based use case, so your collection is very limited, or we make them to be able to collect more. So in this one, we're essentially just looking at run key globs, but it's that concept that I try to get through all of our artifacts that I think is really special with Velociraptor, and it doesn't limit the user into like predefined rules or predefined detections that a vendor gives you. You can kind of expand and write your own as well. To access Notebook in a hunt, funnily enough, you click the Notebook tab. So it's really simple to find out where we want to go. But essentially every collection item in Velociraptor has a Notebook tab. So I just flicked here, and now we're looking at the standard collection, the flow view, where you get a little bit more information. We also have it in monitoring view. There's also a separate notebook section where you can build notebooks and start plugging away. And in fact, most of the talk that I have here today was created in this view. So it's really handy for manipulating data and just presenting things. The magic happens when you click on that little kind of pen icon. And you can see on the screen, I've got the results for my auto runs hunt here. Again, you just get the VQL view, and then you can start going to town. The goal of Notebook is essentially presentation and data reduction and post-processing. So how I generally explain to people is you're going from a lot of rows down to the rows that matter, and also focusing on kind of seeing the data that's important in a way that triggers with you. So the first thing I wanted to cover is a really simple use case, and this is called the column filter capability. And the reason why I'm covering this is it's been around for a while, but I never see anyone use it except for Mike and me, and it's really awesome. You simply click on the end to get a list of columns, and you filter down by selecting. This is an amazing capability for just a quick screenshot if you need to add to a report, or if you need to export to CSV. The caveat here, though, is when you refresh data, it adds the fields again. So it's not a permanent kind of view pane. So it's great for, like I said, just taking those screenshots. The next section I'm going to cover is we're going to start to get a bit more technical. We're going to start to look at enrichment. And on the same theme of that collection I ran before, we're going to look at enriching auto runs data and kicking off that low-hanging fruit kind of detections. What I see in terms of enrichment is generally it's going to be reputation checks. It's going to be things like geolocation or other contexts. And the technique that I'll show you here, I'll use it throughout, and hopefully you'll see the theme that I'm adding, where I'm constantly enriching for performance and things like that. Some considerations with what I'm about to show is I'm actually trying to improve performance, because often when you do a large hunt, you may have a lot of data. And the other thing that I've noticed that people have been sharing is a lot of the open source enrichment is rate limited. So in this case, I'm using an internal artifact that is not rate limited. And essentially it's the same concept as another artifact that you might use, like geolocation or something along those lines. Now here is the notebook that I use for this, and it's all squashed together to fit on a page. So I apologize for that, but essentially it's in 3 parts. The first bit is materialize the collection. So in this case, I am looking at essentially pulling out the fields that are going to be useful to me, and also kind of changing the names of them to be stuff that I can remember. So I pull that out and I use the materialize command here, which people may not know. Essentially what this does is it adds all the rows to memory, so it's very fast to look it up again in the future. The second point I'm going to do is process all unique hashes. So I generate unique hashes here by, again, using that all entries parameter, and I'm pulling out all unique SHA-1 values from here. I'm then applying it to my enrichment artifact by SHA-1, and I'm looking for all the entries that are flagged as malicious in our database. Finally, I'm using 100 workers, and this is so I can throw a lot of queries quickly and have it finish in a timely manner. This is really interesting. This database has like a good list as well, so you can use it for lots of things. But for this use case, it's really, really handy. Finally, I roll it back, my hits back into my all entries and enrich the output. So you can see here, I'm just manipulating the fields that come back. I'm also hiding client ID. And that's an interesting feature in terms of, from a presentation viewpoint, you won't see the client ID, so it will be a lot cleaner to the user. And what it will do is it will then enable us to be able to use client ID later for enrichment. And here's the results. It is quite a good view here. And this is pretty fast as well. Really, really handy. I actually ran this at a customer the other day, and I had 3 hits. It's a really good first check to find the low-hanging fruit in the environment. Okay, so the next thing I'm going to talk about is labels and how to add them. Most people I see will add a label in the VQL itself, and that's good. That works really well. But when you're talking about really big data sets, that doesn't work too well. Because you don't want to reprocess, right? So what we can do, and Mike touched on this before, so it's reiterating what he mentioned, is we can add cell from cell. And what that will do is that will spawn kind of like a results notebook for us that we can then add our processing to. And I'm going to show a really cool use case of doing this with monitoring later that I think people will get a lot of benefit from understanding. The next thing I need to touch on is regex. And regex is so important to Velociraptor. Almost everything we use regex for. So that's from function parameters to artifacts to filtering. I need to bring it up and I need to kind of explain it a little bit here. First of all, it's case insensitive. I'll be covering the functions that are listed there in the middle. Regex replace, transform, and select string from regex. But it's also worth talking about some new features to 6.6, and that's any and all. I'm not going to be covering these today, but essentially they're new functions that will enable us to do things like tokenization. So if you are interested in following up some of this stuff, check out 6.6 and check out the any and all to do interesting detection use cases. It will really help, I think, with things like sigma rule conversion and stuff like that. Okay, so keeping on our ASAP kind of theme, right? I wanted to kind of show something that people often filter out when they're doing kind of analysis of auto runs type stuff, right? So you can see what I've done here is I've created a filter searching for OneDrive. I've then stacked based on the name, the path, and the details. The thing to point out is regex here is double escaped, and that's something that might confuse new users to Notebook, in that you typically escape regex in Velociraptor, but then in Notebook you need to double escape, which can be a bit confusing, unless of course you use triple apostrophe to encase. You can see at the bottom we've got about, what's that, 1,150 entries. So there's a really big tail, and that's because of lots of unique SIDs and things like that. This is actually real data that I've kind of anonymized by changing SIDs and users and things. So it's a real world use case here. But we solve this by using regex replace to normalize. And you can see what I've highlighted here is I'm using HK users with a SID regex, and I'm replacing it with user drive. Down the bottom, we've managed to normalize down to about 400 entries, but this time we've also got the details on the other side, which are the users. So again, we can normalize that. And in this case, we can use another regex replace, but I thought I would introduce the regex transform function, where effectively we can have multiple regexes and transfer and transform data. In this case, I've got the same one as before, but I'm also adding a user path transform as well. The software there is actually to change case as well for software. And you can see the malicious file pops out like a sore thumb in that case. And this is classic data stacking. It is a really easy one to run. In the real world, I might have like 10, 20, 30 of these and build out these transforms as I go in Notebook. And it's just a really easy way to manipulate data. And if you've got regular transforms that you might want to run, just keep a copy of them and roll them in and deploy them every time you do analysis. It's super easy. Okay, so the next thing I need to cover is data types. Mike touched on this a bit, but there's so many new types in Velociraptor. This is just a subset, but I wanted to cover this to show a really good troubleshooting method in Velociraptor. Now, what you can see on the screen is essentially some kind of actions with different types, right? So the first one is working. It's just adding a string and it's working fine. The second string and an int, it's returning no results, which might be unexpected. You can see array and path is working. Path and array, it's leaving out the integer. And then you've got some floating and integer adds there, which the last one could be unexpected. Now these are okay, but often when you're writing complex VQL, things might not work as you expect. And essentially you save time by using the format command and printing out the type. And this is something that I share it with lots of people and no one uses it, but it's always the last thing you try after spending a couple of hours banging your head on why something's not working and you found an edge case. So use this and you'll be extremely happy. Okay, so the next thing I'm going to show is a forensic use case, and it's extracting and combining multiple messages in event logs. This use case I've seen a fair bit where you might have a encoded binary in the event logs. The use case I have here, Cobalt Strike wasn't running, so we couldn't see what the config was in memory, and we found it in the event logs. But I wanted to extract that. People will often, copy and paste base64 out manually and have a tough time. But I want to show how we can do that in a few seconds in Velociraptor Notebook. So the first step is essentially we're going to be querying for our items of interest. And in this case, I've used Glob, searching for PowerShell. And this is the most efficient way to hit PowerShell logs if you're going to be using the EVTX Hunter artifact. The second thing I do for performance is I box time around the alert, looking for the time that I'm interested in. And the third thing is I obviously hit my ISCs. And in this case, it's all, but I am looking for a event ID of 4104 for scriptbot logs. Okay, so the results that we have are, well, 3, but 2 of them are really interesting. And I think it's worth kind of pointing out kind of how scriptbot works in PowerShell, where effectively you'll have some encoded PowerShell transverse the script interpreter. It's then decoded, and then the decoded code is put forward over the script interpreter. So what typically happens is you'll get kind of 2 logs or sometimes a lot more kind of versions of the same code. And that's essentially what we saw here. And you can decode the first lot, but my recommendation is to cheat and start at the second and skip the first line of decoding. Let Windows do it for you. That way you can at least get down to the binary part, because the way PowerShell works, it doesn't decode binaries, and you just get down to the reflective loading where it loads the binary in memory. And it's a super, super easy way to kind of fast forward. So what we can do to find our scriptbot logs is Notebook, of course. And I'm using the filter of the scriptbot ID. I was just looking at this on an individual machine, but you could also put in other fields like computer name or the event log number and so on and so forth. But you can see when I run this notebook, in the bottom left-hand corner, I've got 21 messages that are popping. So we're spot on there in terms of what we're pulling back. The next question is, how do I get the payload out and combine them? And to do that, we use the join array. And essentially I've highlighted, and we're talking about the one at the bottom, where I'm joining payload.scriptblock text and I'm using no separator, and I'm calling that payload. And then I'm also adding messages, and you'll see why very soon I'm doing that. The other thing to talk about is I'm using the first item in each of the other events, and I'm doing that because they're all the same, so it's fine just to use the first item here. But this is what happens when I run that, and it's really cool. I joined the messages so I could validate that I was actually getting all the messages that are relevant. So you can kind of see we've got 1 to 21 there. That's in the right order. So that means my payload is correct. And obviously I've cut that off. It's much, much longer. So that means we've successfully joined our PowerShell together. So the next question is, how do I decode it? And how do I get what I want out of it? So what I typically do is I'll create a dynamic function here. So the top function is called function. And what it's doing is it's just removing the base 64 and returning the PowerShell bit. And the second section in the middle is a dynamic function that will extract the base 64 log, called base 64, funnily enough. And then the VQL at the bottom, I'm doing the exact same thing as I was doing on the last screen, but I'm just running it through those functions. And you can see this is the result of the function. It definitely is Cobalt Strike. You can see that. But it's also giving us the hint of what we need to do to decode it, right? So you can see the base 64 there, but you can also see the XOR with the decimal 35. And you kind of know where this is going, right? We actually have an XOR function in Velociraptor. And you can see I've used the format command here to create a decimal representation of 35. And then I've piled the same base 64 function into the XOR as the string parameter. What I do is I take the results of that and I then kind of pipe that into Cobalt Strike. So Mike mentioned the Cobalt Strike artifact. It's pretty awesome in terms of carving. There are some nuances to using it, but that's another talk itself. But I'm also doing a little bit of presentation here. And you can see the presentation. Hopefully you can view this okay. On the left-hand side, we've got our message details and validation. The middle bit, we've got the payload. So I've got the function, the base 64, and the payload itself. And you can kind of see the MZ header there standing out. And on the right-hand side, we've got the Cobalt Strike config, which is really cool. For this actual use case, I just kind of generated data by literally using the Cobalt Strike jump command and hitting a box. So it's kind of straightforward and easy. But once you've got the data, it's really easy to decode. And even if they're using something exotic, you can just change the XOR config. You've got Velociraptor is pretty much a coding language that you can decode. Mike also brought this up as well. Right-click in 6.6. If you wanted a copy of the binary, you could copy it to clipboard and then send it to CyberChef. One caveat with this feature is there is a GET request limit to CyberChef, so you can't throw up like a megabyte or 2 megabytes of file, so you need to use the clipboard for that. Okay, next section, ETW and PowerShell monitoring. This is something I've been working on lately, and it's really cool, and it plays into the theme that Mike was talking about as well. As we know, PowerShell is commonly abused by threat actors, and most detection is limited to command line. The big gap that we have is we don't see script contents or things that are typed on the shell, unless you've got like read line or you've got other kind of artifacts. But for the most part, we don't have monitoring on command line, which is what everyone's looking at in EDR. The challenge with this stuff, though, is finding useful things in the noise. So I thought I'd walk through how I kind of create a monitoring artifact that people could kind of copy the same methodology. So in this case, I'm not going to walk through all of ETW. It's a huge topic, and I have a link on it here. But essentially, I use Web Explorer to find what I'm interested in. In this case, it's easy. PowerShell is pretty well known. I find the PowerShell GUID here. But you can also find keywords for performance filtering and things like that, and also look up event searching and stuff. So that's kind of straightforward. But what I do is I will enter my GUID just with a select star to kind of pull back everything. And then I'll generate an event that's easy to trace. So in this case, you can see I've just done right host testing event generation. Once I generate some events, I hit stop. And then I do that same trick that we talked about earlier, where I add self from cell, so I can get and start my munging process. Here you can see the only thing I'm adding to the notebook is I'm pulling out the events I'm interested in, but I'm also adding a where and looking for right host. The results from doing that really shine, right? So you can see 4104, that's the script log event ID. That's really useful. And you can see the valuable data, exactly what I typed. And then the other event log is 7937, which looks like some kind of module logging here. And you can see in the bottom of that big highlighted square, we've got the right host is started command there. So we know what we're looking for if we want to kind of collect this info. So you can see I'm going to run the exact same notebook I ran before, just adding that line at the top where I'm saying, hey, give me all of the event IDs, 4104, 7937, but filter for events with a script block and filter for those module start events. So we're being very specific in what we collect. The second thing I'm going to do is I'm going to take the results of those hits and I'm going to add a payload field that's dependent on EID. So 4104 is pretty simple. We're just grabbing the script block text. For the other event log, I'm essentially removing the command and is started bit, and I'm just going to have the module name, right? And then for the second part down here, I'm parsing context info, so it's no longer a big binary blob. And hopefully you can see the same functions I'm using here with the ones that I showed at the start, right? This is the core of writing artifacts. So if you are interested in playing around, learn these, copy and paste to get up to speed with them. But once you get regex rocking and rolling, you'll be able to write some super amazing artifacts. The results of that notebook is here. So it really looks like useful information that we might be interested in. The question is, how do we turn this now into a detection, right? How do we turn it into something that's useful that we can use for security monitoring? And the answer is what I showed before, the kind of enrichment style, that way of thinking. I've created an artifact and I literally pushed it to the artifact exchange when Mike was talking. And I use CSVs a lot. And I'm going to show you how I do that. Essentially, I've got parameters here. And you can see I've got my ignore paths at the top, a path as well as process name ignores. And then down the bottom, I use this CSV to define collection. And this is just for my demo. I've only got a few. I deploy this in field and just collect. I'm still at the POC stage, so I'm not really confident to deploy it 100%. But it's really useful and it's showing lots of promise here. So the strings I'm monitoring for is do it and the XOR of Cobalt Strike, as well as get process, get service, and write host from a commandlet loading. The next thing I'm going to do is essentially show you the VQL here. So very similar to before, I'm materializing what's needed for performance. So in this case, it's my detection logic. I'm materializing all of the detection logic and all the ignore things that are going to be hit on the first pass, right? So you can see here, we've got two kind of types, one for script block, one for commandlet, and then also the script block ignore path. We actually use that on the second pass, but nevertheless. Secondly, I'm going to apply that first pass filter detection. So this is exactly the same VQL as what I ran before testing. I'm just adding in the filters for that first path. And then if you think we've got all of those rows that are all the juicy things that are interesting, we then do the same thing and do enrichment, which is really cool. So in this case, we do for each hit. In this case, we're calling our IOC CSV, and I'm doing things like process chain enrichment. So what Mike showed you, and I'll show you that in a minute. I'm doing things like the second pass filtering here, where we start to use the CSV and do specific filters. And there was an ignore list in the filter as well. And we also start to enrich the results that come back. This is me deploying it, so it's quite easy to deploy. If you want to have a play with the artifact, I pushed up to the console. And this is the results. So at the bottom, I did a base 64 encoded command that was get process, out now, and then write host testing script block detection. You can see it's detected the payload. I actually included the command line like this, although we still would have detected if I typed it in a shell, just so I could show off the process chain output. I'll probably end up changing this to look more like Mike's one because I think it's probably a bit easy to see, but we've got all the parent-child hereditary process chains, which is super cool for a response capability when you get a detection. The next thing I'll show is the Cobalt Strike side of the shop. So looking at script logs. Here I've just done a simple PowerShell PS exec. And this is what I was talking about in terms of having two events, right? So the first event, you can see there's an IEX here. And then the second event, same thing, but without the IEX. So it's that second run over the script interpreter. So this capability is very, very exciting. And there's lots of nuance here for improvements and getting some really, really cool detections happening. As I said before, it's great at filling that console or script visibility gap. The issue is the noise, but we need to test it. We need to make sure it works. So I'll put the artifact on the exchange, and I really ask people to go out and test and provide feedback, and let's get this thing going really good. I've included that link to the blog that I was talking about from NASBench. It's a really awesome blog, and if you are interested in ETW, not just PowerShell, anything, take a read of it, learn the techniques, and then we can build some amazing monitoring artifacts for Velociraptor. I think we're coming up to time, so I think that was pretty good timing, actually. And just to wrap up, Velociraptor, it enables the collection and manipulation of data at the endpoint. Like, all I've done is kind of step through different things, different data I've collected, and that's what Velociraptor is, either in the notebook or when you're writing artifacts. And pretty much anyone can do it. VQL isn't a difficult language. You just need to take the little steps at a time and work your way through queries to get answers. There's lots of more things that I have left out. We could probably do weeks of training and still not cover everything. But as I said, start small, start with those small increments and build from there. Finally, another link for the learning. And again, I'll be sharing all this stuff. But that's kind of it, guys. Thank you.
Thanks a lot, Matt. That was really cool. I'm sure we'll all be data munging our way to victory before no time. All right, so we're going to move right along to our next presentation. And it's Wes Lambert who's on deck, and he's going to be talking about VelociStack, swiftly configuring streamlined investigation environments. All right, so for those of you who are not familiar with Wes, he's the principal engineer at Security Onion Solutions, where he helps companies to implement enterprise security monitoring solutions and better understand their computer networks. He is a huge fan of open source software projects and loves to solve problems and enhance organizational security using free and easily deployable tools, aka Velociraptor. So without any further ado, Wes, take it away.
Thank you, Carlos. Give me just a second here to share my screen. Can you hear me okay?
Here, just fine, thanks.
All right, thank you. Okay, let's see. Okay. See if you can see this right here. All right, can you see everything okay so far? See if I can move this. Good. All right, we good?
Looking good, yep.
All right. Thank you, guys. Again, my name is Wes Lambert, and I am a principal engineer at Security Onion Solutions. I appreciate you listening to me today.
One thing, Wes, it looks like you have your notes visible on the screen. I don't know if you wanted to do that or not.
Okay, let me see if I can do it. Change the new share. Stop share. Yeah, I think it didn't flip to the right screen here. Let's try it one more time, and then I'll try one other way if that doesn't work. Can you see the notes or the full screen?
Still see the notes.
Okay, let me switch back. Stop share. Share screen. Screen two. Share. How about now?
There you go.
All right, cool. Now I will restart. Okay, so I am Wes Lambert. I'm a principal engineer at Security Engine Solutions. I just wanted to talk to you today about some ways in which we can leverage Velociraptor, an already awesome forensics and monitoring and response tool, and really, create kind of a quick, streamlined environment for investigation, whether it be for educational purpose or for professional purposes. So that's really what I want to get through today. Let me click here. All right, there we go. All right, so what is VelociStack? VelociStack it's a free and open platform for streamlined host-based forensics and investigation. It really just leverages heavily Velociraptor and tying together some other components to allow you to take that data from Velociraptor and act on it a little bit more easily, or maybe take it, a different direction. And then also for people who want to use it as a case management platform or have something to track investigations, to be able to do that kind of stuff, and then to be able to enrich that data as well. So that's what we're gonna go through here as I go through the presentation. So why was it created? You might be familiar with a lot of online repos or platforms like Blue Cloud or Purple Cloud or some other projects that allow you to spin up Velociraptor in the cloud environment using something like Terraform, or something like Ansible. This I wanted to take and make a little bit simpler and just make something that I could just set up locally. I know Velociraptor is already extremely simple to set up on its own, but just take it, and tie it with a few other components and make it really simple to install locally, not have to worry about the cloud and have things more so in an integrated fashion. So it's really the purpose of why I kind of went into this project. Now, who should use VelociStack? Really anybody can use it, but the target is really for those people that want to learn, people like students, people like analysts in their everyday day job that just want to learn about Velociraptor or learn about some of these other components, or maybe just have it be used in actual IR or during actual daily investigations. So really, the target for this project really is anybody that has a desire to learn, I think, and that's really what it's about. So let's talk about a couple of those components of VelociStack. The first component, this might be a surprise to everybody, is Velociraptor. Okay, so obviously with Velociraptor, we have the host-based forensics monitoring response, all of the detection capability, all of the cross-platform goodness, the super flexibility because of VQual. We can pretty much do anything we want with Velociraptor. So it's a really unique and really heavily relied on piece of software in this particular stack. So it is going to be at really the centerpiece of this. So obviously Velociraptor, but what else? How about Prometheus and Grafana? This would be a way to perform host and performance monitoring of the stack itself. We could visualize those metrics about the stack performance. We could alert on any kind of metric data for using this in our daily environment. As an analyst or as an incident responder, we can get a little bit more information on any issues with the host or things like that. So Prometheus and Grafana allow us to do that by collecting those metrics and then presenting them in a way that it's a little bit easier to digest, right, than maybe a simple CLI output. So we can navigate over there to Prometheus or Grafana. We can go to Prometheus directly if we want to. But this is a great way to, at a high level, visualize what's going on with the host itself. Now, the stack itself is not super reliant on any particular amount of CPU or memory. Probably 4 to 6 gigs in most cases is usually enough. So not a super heavy there, but I would probably recommend a dedicated host. The Elastic Stack. So the Elastic Stack is another component of VelociStack. We use the Elastic Stack for visualizing post-processing data. We can create visualizations in Kibana if we wish. And we can post-process that data with things like ingest node pipelines, and then go off and tie in with other platforms and perform additional enrichment. And here's a quick example there of just some Velociraptor data. Velociraptor already has some artifacts, right, to tie into the Elastic Stack, the Elastic Upload. So we're just leveraging that there, and you can see that data inside of the Elastic Stack, inside of Kibana right there. Now, another one, we talked about CyberChef a couple times. CyberChef is another component of Velociraptor Stack. It's very, very good to be able to have something like CyberChef alongside your investigations, or when you're doing investigations with Velociraptor. I imagine a bunch of you, like myself, might leverage CyberChef. It's a really great way to understand data, to transform and decode that data. Obviously, you can create and share recipes. If you're not that familiar, you can share off the different recipes that you have, the different combinations of operations that you have, and then you can bake that data to perfection, right? So CyberChef, here's just a little screenshot there of what's included there with CyberChef, just an overview if you're not familiar. CyberChef is awesome, of course. We can just see a from base64 recipe here, super simple, just being applied to that initial input. So that's another component. Now, the next is going to be a really cool component that I started working with recently as I've had time, and that's Iris. So this is a very cool kind of case management platform, incident response platform. It's really geared towards acting on incidents as incident responders would. It's been built by incident responders. We can create and track cases, assets, and IOCs in there. We can also integrate with other external systems, things like VirusTotal or MISP natively from there. So we have a lot of different hooks at various levels of the data that we're getting, either from Velociraptor or moving up into cases and that sort of thing, right? So it's a really cool platform. We've got a screenshot here of it, just a nice case of something bad, right? That something bad is happening. This is just a brief kind of overview of the interface here, where you'll see that we have a dashboard at the front, and then we can get at our individual cases, then assign any notes or any assets. That's another cool thing, is that Iris has the concept of tracking assets. So if you've got an environment that you're monitoring that's you want to associate with particular hosts, or even maybe during an IR, you can do that, and there's that kind of hard linkage and something to refer back to and tie things back to a little bit more easily when you're investigating those cases. Same thing with IOCs and some other things there. Just a really great way to tie in the stuff from Velociraptor and bring that into a case management platform. Another thing, Intel Owl, it's another component. Intel Owl is a great open source platform for aggregating threat intel sources. It really reduces that complexity, right? Getting started or trying to query external services. As Matt mentioned before, there may be rate limits on particular services, online services, even still when accessed through Intel Owl, but there's a plethora, a huge amount of different ways that you can get at certain data with this, and ways to tie in with stuff. So it's really flexible and really convenient to be able to have that threat intel capability or that enrichment capability built into the stack. Here's just a brief screenshot. It's kind of hard to show all of the plugins just because it took up a little bit of screen real estate here, but you'll see the abuse IPDB. Some of you might be familiar with, where you can check if an IP was reported to be abusive, right? So that is another component of Velociraptor Stack. So we've got the data coming in, right? The threat intel and the enrichment. We've got the case management. We've got alerting and performance monitoring, and then we've got the data manipulation with CyberChef. And that's really what this summary right here kind of encapsulates. You see, we've got Velociraptor kind of at the helm here, and we've got all these things around it. We've got all of these great applications working together to make things a lot easier for analysts and for incident responders, and really for anyone. So That's really what the case, or I'm sorry, this project was about. So this is what it looks like when you go in. Not super talented with the graphic design. What I've leveraged here is just a custom artifact, the welcome YAML artifact. So Velociraptor has a default welcome artifact that you can customize, and that's what we've done here. We've actually customized it with links to each of these particular applications, right, which you'll see here, and then also some client binary downloads. As we know, it might be easier if we're signed in via the web interface already to go and download maybe a repacked client or something else to go off and pair that to the server, as opposed to having to SSH into a box or get the binary from somewhere else. So this is a great way to serve it from your authenticated Velociraptor session. Now, let me get some coffee real quick. All right, so getting started. How do we get started with VelociStack? Well, I mentioned before, I wanted it to be really simple. Now, granted, there may still be bugs, however, but I wanted it to be very simple to just clone the repo and run an installer script. So that's really all you have to do now. And after this presentation, I will set this repo to public. Right now it's still private, but you will just clone the repo right there, and you'll just run the installer script. And then basically what will happen is it's Docker Compose. As you can see, it's one of the requirements. Docker Compose running in the background. It will handle all of that, plus a couple other commands there. It'll handle setting all of that up. And then you should be able to access that through the web interface after a few minutes. But I want to talk about, before we go take a look at it, some integrations and some workflows, keeping in mind of those analysts and those responders that we might leverage from this platform. Now, before we get into those workflows, I want to talk a little bit about how a lot of this is constructed. So this is a really cool feature that allows you to really customize Velociraptor for your environment and to really be able to bootstrap a deployment however you wish. The transparent proxy is built into Velociraptor. It's basically, there are some settings in the server config YAML, and it allows Velociraptor to act as the proxy for any of the authentication or the routing or TLS. And in this instance, in VelociStack, it proxies almost all the applications, with the exception of a couple. There are some that aren't capable of being proxied under a subpath right now. But for the most part, we have leveraged that transparent proxy capability, which is awesome, to be able to use just Velociraptor to front those services. And what it looks like right here is this, right? We have a reverse proxy declaration here in the server config. And then we have a bunch of different routes here. So we'll see one for CyberChef, one for Grafana, Prometheus, and so on. And what that allows us to do, we can require auth right here if we want it to be authenticated or unauthenticated, is wrap Velociraptor around those services, right? Be able to leverage Velociraptor in its primary capacity, and then still have all these other things bundled with it or customized alongside of it, and have to reduce our our complexity and our overhead for reverse proxy or whatnot. So it's a really cool way to be able to tie all this stuff together, and it's really how most of these applications are handled on the back end. Now, I mentioned Elasticsearch. So Elastic Upload is already pre-configured. So whenever you spin up the stack, you don't necessarily have to go set up the Elastic Upload artifact. And we'll also start parsing artifacts towards ECS very soon. I've got some stuff I need to put in there, but we can also query Elasticsearch directly, right? So, if we're throwing other data in there for some reason, or for some reason or another, we want to do some post-processing and then go retrieve the data back out of Elasticsearch, we have the capability to do that as well natively, and it's already tied in. It's already connected, right? So it makes it that much easier. We mentioned CyberChef before, right? And we mentioned the context menus. So another thing that will be pre-configured in here is the pivot from Velociraptor to a local CyberChef instance. A lot of folks might not want to leverage the external instance. However, it is better than nothing in many cases. It's probably preferred to use your own local instance, and we can do that. right? We can pull that data from Velociraptor into CyberChef, and we can start baking our data, right? And then we can start pivoting, just like Ross over here from Friends, right? So this is what that looks like. You've seen it a couple times now, but to show you again, we've got this context menu here, and we've got some base64 encoded data over here. You can just simply click the CyberChef right here, and then we can pop that over there and start working on it as we wish. It's super clean, super fast, but you do have to be aware of some constraints, like Matt mentioned before. And this is what that looks like in the back end, just an example. We've got this GUI links configuration here. We're just overriding the default value right here for the URL, but also, we need to paste in the other stuff so that it effectively takes over that default configuration. Now we can add other stuff in here too for the links if we wanted to, but as far as this example, we just have CyberChef here. Now, what are some other things? Okay, so some other things we can do with this out of the box are going to be able to utilize hooks to automatically run modules in Iris. For example, if we add an IOC to a case, we want to see if any other box in our deployment, or which boxes might have this file on there. We can add an NB5 on there. We could submit analysis to Intel Owl if we wanted to, and we could also run a default set of artifacts, right? Like if we added a new asset, we wanted to go off and run certain queries on the new asset, we could certainly do that all through those modules. But I did want to share one example of how I can do this. Stephen Mikas, Bad Bloops, I think is his GitHub handle, put together this initial module that I've been testing and have been working, integrating into this environment. So thank you, Stephen, or Stefan. Apologize if I incorrectly pronounce your name. But this is a way to essentially have Iris reach out to Velociraptor whenever essentially an IOC is added or is updated, things like that. And then it will go out and it will actually perform a hunt for that. So if we added an MD5, we can go out and run a hunt. Right. And now there's more stuff we could do with the module and the artifact. However, this at least gets the ball rolling, right? From a very quick perspective, we're already starting the triage. We're already starting to look for this whenever we're entering that case into the system, right? So we can see that this module started to go out and initiate that hunt there. And we can also see from the Velociraptor side that the hunt was created by this DFIR or DFIR Iris modules user, right? So we can already start having, pulling back that data once we started creating our case and, get the ball rolling from there. So it's a really, really great way to start getting more context around things that are happening and respond, a little bit more quickly, right? Now, there are also some other Iris artifacts that we can leverage if we want to create a case in Iris from Velociraptor. These are both on the exchange. We can also look up an IOC that's been posted in Iris. So if we want to look that up and see if something that we have on disk actually matches something that we have in a case, we can do that as well. So it's another way of, going back up the other way and, trying to get some context or looking, seeing if we can get that answer, right? Another one, the artifact that actually creates this module or inserts it into Iris. This is the example here. And that's actually included in VelociStack. So Velociraptor actually configures Iris through this artifact. So it's not only just looking for data, it's actually performing management tasks, right? Much like the server configuration, right? Or, data is handled or clients are handled through artifacts. So it's another way of just managing things, right? Just using pure VQL. Now, as far as Intel Owl is concerned, we can query Intel Owl for IOCs as well natively, right? Since it's built in, we can do that. Just a local instance. We already have a way to hook into that and test things or look at things. You can, do the observable lookup, then, do the job lookup. I don't have an artifact produced for these just yet, but it is in progress. But again, it's already right there. You don't have to sign up for an account. All of it's right there for you to experiment and play with. Now, as far as the roadmap, there's some code cleanup for this is that I did rush some of this just to try to get it ready. And the Intel artifact is on the roadmap. There's some other stuff around. I've experimented with Zinc a little bit for a little bit more lightweight data store, right, for the Elastic data. And then, also considering OpenSearch, but I'd be really interested if folks are interested in this at all, or think it's stupid, or, if you have any other ideas that might make this, more amenable or easier to leverage or whatever. Really, I'm just hoping to get some feedback and, let me know what you all think. So before I stop there, let's see if I can. Nope. So yeah, I'm gonna pivot through just a quick walkthrough. So again, this is the VelociStack interface, just the regular kind of Velociraptor skinned interface. And so from here, as I mentioned, we can pivot over here to CyberChef. We can go do all our chefy things over here, right? We can go into Grafana here. If you want to take a look at those, the system metrics or performance of the host right here. Let me see. Okay, just making sure I can see here. All right, and then if I go back, we can go over to Intel Owl, right? And go through all the jobs and plugins and everything that's available for Intel Owl, right? So I had to go through and show you this while I don't have a ton of time to the web interface, or else maybe you wouldn't believe me. So, all right, but to get back to VelociStack, again, if we want to go to Kibana or Iris, we can pop over there, right? Review all our cases, and we can go in here. Let me go into advanced here, and there's that module I was talking about, right? That Iris Velo module. And then if we wanted to look in Kibana, we could do that. Right, let's do, no, last 15 minutes, let's do maybe 60. Right, and then this is just a simple Linux sysusers artifact, but yeah, I mean, you can post process this however you wish with Elastic, right? The ingest node pipelines to transform that data, and lots of other different ways to get at that, right? So that's not it. This is it. All right, and then finally the client downloads. If you wanted to download the client, you just click on those, the binary downloads right there. Then you could go off and run those. And assuming that you have, DNS resolution of that Velociraptor host, you should be good to go, and it should connect right up. But otherwise, that is all I have. And let me just switch to this real quick. All right, so yeah, just open for, if there are any other questions or feedback, obviously we can answer those in the Discord channel. But if you do have the chance, make sure to check out VelociStack and let me know what you think about it. Thank you.
Great, thanks a lot, Wes. A lot of great comments in the chat about people loving the integration that you just kind of described right there. So awesome job. All right, with that, we have come to the first break of the day. So it is right now 10:44, so we'll give you guys about 15-16 minutes, and then we'll reconvene at 11 a.m. Eastern time. All right, talk to you soon. All right, welcome back to VeloCON 2022. We're ready to get started with our second session of the day. And we're going to get started off by Christian Hammerschmidt, who will be talking to us about machine learning for DFIR with Velociraptor, from setting expectations to a case study. And just a little background on Christian. Christian is heading Apta Technologies, a startup that builds machine learning tools to understand software behavior. Prior to co-founding Apta Technologies, he obtained a PhD for research on machine learning techniques to reverse engineering software systems. So with that, take it away, Christian.
Hi. Let me share my screen. Okay, hi everyone. So as my intro said, I'm not really coming directly from the cybersecurity or incident response direction. I'm more coming from the machine learning direction. And looking into the application domain where we learn from software models, we realize that there are lots of potential applications in cybersecurity, but not a lot of people in incident response seem to be using it. And I think it has a bit to do with the endpoint protection system, where everyone wants everything to be intelligent. And there are a lot of promises out there to what these tools can do. And yet incidents happen and you guys get called. So there seems to be a little bit of skepticism and a little bit of like the lack of tooling, because if the endpoint protector is already running machine learning, what can it do when things go wrong? I have little questions. I also posted them in the Discord channel here. On the bit.ly links, and you can answer them. You can, like, at the end of the talk, look at it and see if I answered all the questions or if there are follow-up questions on the things that we're touching on. So in the endpoint protection system, in the XDR, everything's intelligent, right? That's bad news or good news? Well, it's kind of a bit of both. When everything becomes intelligent, the attackers can also become intelligent. It's always been a cat and mouse game, right? So there's a new third day, you patch it, there's a new one, and new techniques, you learn about the techniques. And now that we have intelligent systems or machine learning systems, attackers can also use them to customize malware and customize things. There's one nice paper that's open source, where they take a piece of malware, they take any type of detector, so you can plug and play any type of detection software you can buy from the market. And it does its magic, and at the end, it pops out a piece of malware that does the same thing, but is no longer detected by this black box with machine learning, right? So intelligent systems don't only help in the defense, they also help in the attack. And well, the question is then, what can machine learning actually do besides promise a lot of things? And just as a large overview, right? Machine learning can classify things into categories, like this is a cat, this is a dog. It can predict numeric values, as in this is the price for the stock, this is the next CPU usage. It can recommend things like this is a movie you should watch, or this is a file you should look at. It can group things for you. Like these are all images that look like they are cats, or these are all faces that look like they're from your family. It can find anomalous or novel things it hasn't seen before, and it can rank or sort things for you. As a rough breakdown, and going from the top of this list to the bottom of the list, it becomes more imprecise. Like putting things into categories has kind of a ground truth, right? This is an image of a cat or of a dog, even though we can now create images that kind of look like both, right? But in general, the task here is pretty clear. If you think about what should you recommend, it's already a little bit like less specified what to expect. Grouping things, I mean, even we as humans disagree on how we should group things all the time. Finding anomalous or novel things, well, that also really depends on who is making the judgment here, right? So machine learning systems that do the lower half of the tasks are often left with a lot of kind of implicit judgment for things. And that's often left to the system designer, and often is expressed implicitly in some type of mathematical way that if you don't think about it, can really bite you. So it's really easy to shoot yourself in the foot and do things you don't really expect to happen. And I mean, we've all seen a couple of these examples, right? If you trust systems too much, things can go terribly wrong. We can also misuse systems in a terrible way. Like this group here that tried to predict just from face shots if people are criminal or not. And in the end, they built a system that essentially detects whether people smile or not, because most people don't smile when they get their photo taken by the police. So what do we need to pay attention to, and how can we make sure we build systems that actually work and help you, also in incident response? And how do we then do that with Velociraptor? And in this talk, I hope I can give you kind of a high-level view. And hopefully after this talk, you believe me that data science or machine learning or artificial intelligence, depending on how strong you want to be, is a great tool that you can use even daily if you use it in the right way and if you know what to expect. And it's not that much or that difficult once you thought through these things. I've kind of assumed that everyone kind of can find their way into a like kind of standard data science stack that's typically something with Python and like these libraries, pandas, NumPy, scikit-learn, and maybe Jupyter notebooks. Yeah, lots of free resources out there to start learning. So that's typically not the problem because that's super commoditized. Every first year student can go out and start using these tools. The question is like, are they using them the right way? And coming to Velociraptor and machine learning in incident response, there are kind of two ways you can do it. The first one is you run your VQL query, you get some data, and you then plug it into a standard pipeline or give it to a data scientist or someone who knows how to use machine learning and just do the standard thing. There's a much cooler and more exciting way in Velociraptor. You can package machine learning into an artifact and just run it on the endpoint. And that's in some way a much more scalable and more efficient way, but it has some limitations in terms of what you can actually run and also what you need to do to actually get it to run. Because in the first case, you have your own local environment where you have all your standard libraries, like on your desktop, for example. So you run your VQL query, Velociraptor does its magic and gives you some data that you export, and then you download this into your environment. One danger there is, of course, if you have lots of hosts, if you do 100 and you have 500 hosts and you say, give me all Windows event files, that can be hundreds of gigabytes or more, which you might not necessarily want to download. But of course you can, and then you can continue in your standard environment and everything works just fine. There's also a nice way for those who know Jupyter to connect Velociraptor and Jupyter. There's already a really great blog post written about it. That is in some way a matter of convenience because it doesn't solve the fact that you might end up downloading too much data. And in fact, you can essentially use Velociraptor like a database in this case, but technically speaking, it's not a database. It's not optimized for lots of data access. So you'll run into slowdowns and lots of data running. Now you can also, and we've seen this mentioned before, just call REST APIs on the internet from some VQL query, where you then also run into things like how much data are you actually sending and to which third-party provider are you sending it. But the nicer way of using VQL is by packaging, how you can use machine learning is by packaging the machine learning into an artifact. So you define an artifact and you can use it in any VQL query. And the artifact runs on each endpoint, processes the data, and just gives you the results back. So instead of downloading all the data and running the data once you've downloaded it, you run the machine learning on the data and only download the results. That's much more scalable. You don't need to send data anywhere. There's one kind of disadvantage, right? If you run it on each machine separately, you cannot calculate things that need data from other machines, for example, the correlation of data between two machines. And the other thing is, Velociraptor runs kind of platform independent on each of these machines. If you start packaging interesting things into artifacts, you also end up needing a good execution environment for this. And that means you need to bring your execution environment with you. And you can do that using tools like PyInstaller or Py2Xe. or compile native binaries for Windows and download them. There are artifacts that do that, like the chainsaw artifact, for example, just link things statically, and it should run on most of your endpoints. But that's definitely something to keep in mind when you want to build things. But the question is, what makes a machine learning system actually useful for you? I have another link here where you can put your answer, and we can take a look later. I've talked to a lot of people working in incident response, and I've kind of identified some themes, what people want systems to do for them that they either don't do out of the box or don't do at all. And these are the three main themes I've seen. People want systems to be reliable and trustworthy. They want to be able to understand them, and they want them to be robust. And you can take a look at what that actually means, because it's a whole spectrum of answers. For example, when you think you want a system to be reliable, you can have a good model that's bad and unreliable for your specific purpose. Because what good really means depends on the user. An easy example is, and that's something you see a lot in kind of cybersecurity cases, we have some data points, and the bad data points where like malicious actors active or where some bad codes get executed is actually incredibly rare. So if you have a model that's fairly accurate, like for example, 99% accurate, that means 99 out of 100 predictions are correct and the other one is false, that still means if you run it over 10,000 data points, that you have a lot more wrongly identified points than you actually have correctly identified points. And that makes your technically good model kind of useless for you. It's not really you can't really rely on it. And that kind of is a theme that affects a lot of use cases. So you can have points that a machine learning system correctly identifies, for example, as malicious. It can also miss points that it just identifies wrongly as harmless. It can, of course, identify the harmless points also as harmless, but it can also say, oh, this harmless point file or log line or user login, that's actually bad and it's kind of wrongfully accused. And you need to think about what does it mean to have one of these mistakes, right? If you think about a SOC situation, you might want to minimize the number of false alerts where you wrongfully accuse things because you get alert fatigue. But maybe if you're already in an incident response situation, you might want to actually be a little more relaxed and say, well, I really don't want to miss something that I kind of incorrectly accuse as being okay. And that might also because you say, if I miss something in an incident response, that might actually be really painful after the fact. But if it's in a SOC situation, actually having an analyst look at everything and being really exhausted and not really paying attention to my system anymore, that's actually more painful. So when it comes to reliability, you really need to think about how do you define and measure if a system is reliable for you. And that is somewhat closely related to saying, I want to understand what my machine learning system is doing. Because if you have a system analyst that looks at alerts, if the analyst knows a bit what the alert is about, then he might be able to make a better informed decision about the validity of the alert. And there are kind of two ways of looking at this. You can say, I want to understand the machine learning thing itself that I use. Or you can say, I want to understand the decision it makes. And these are kind of two different trains or schools of thought. Understanding the model is, I think, much more demanding because you need to see the whole picture and it needs to kind of be human comprehensible, versus understanding each decision is much more pointed. You don't need to know what your black box does as long as you understand it, why it does it. And again, you can ask, why actually do you want to understand what your system is doing? Do you want to trust it? As for example, if you have a self-driving car, you want to really trust it. You know, say, I want to actually detect the relationships, right? Like, why is this PowerShell command as something negative, something that the system points out to me? Might also think about, I want to understand the system because I want to know if I can apply it in a different setting. For example, you have a lot of data collected from an enterprise company, and you learned what malicious actors do on these networks? Can you now use the same system at a small or medium-sized business? Or is there something in the data that actually prevents you from just transferring this? And then you can also say, I want to understand the system because I don't necessarily care about every alert, but I actually want to know, I want to learn what constitutes a bad line of PowerShell code, or what is a bad binary, what type of system calls does it do? And then you don't care about what the system outputs, but you care about like the insight it can give you. And one interesting way to illustrate this and the difficulty of this is a small game that is a lot more fun to play in person, but we can also play it kind of in the Discord chat. So there are 4 activities: raise your left and right hand, stomp or clap. One very popular machine learning system is called decision tree, and that's essentially a flowchart, right? So you look at each of these nodes, you ask yourself, is this condition true, yes or no? So is it before noon? When your time zone, it might be before noon. Are you watching this on YouTube? Yes, then you clap. No, then you raise your hand. And one might argue, if I give a machine learning system that learns such a kind of flowchart, that might be interpretable, like everyone can make sense of this, right? The problem then is they quickly become really that big, right? So imagine you had an event called ICML, it's 2017, it's in Australia, you see a kangaroo, it's sunny. What's the activity you actually need to do? And you might still argue, oh, I can interpret this, right? But it will take much longer. And I think there will also be people who just make a mistake and disagree because they just take a wrong look. So the judgment, like I want an interpretable system, is also not as straightforward because you always need to ask yourself, what do I need it for? Who needs to understand this? Is it the system, the person who builds the system? Like imagine you're a larger firm and you can hire a researcher and he builds systems for you. Is that the person who needs to understand the system? Or are you as a user the person who says, I want to understand this because I want to know if I should follow up an alert or not, just from the system itself. And there's in academia, there are whole fields that only look at these things, whether that's interpretable systems or explainable systems. And there are also many tools to analyze things after the fact. Some of them give very technical explanations, like essentially more charts and numbers to look at that have then some room to interpret what they actually mean. And again, might not be the right thing you want to give to an incident responder because you just want to know what aspect of the data point was responsible or not, like what's some numeric way of capturing that. They can also be incredibly useful for people building these systems. And there are nice failure modes that are very invisible for these machine learning systems that you really don't see until you run into them. One kind of famous one is this one. People trained image recognition software. And one thing to identify from all the others were horses. And they collected images from different sources and then trained the system and was really good and it could correctly separate horses from other things. But when they looked a bit closer, they realized that horses, all horse pictures had kind of this watermark on it. And no other image class, no other images had watermarks on them. And it turns out that the system didn't learn to look at horses. It essentially only learned to check, is there a watermark? And then there's a horse. And I'm putting pictures here because it's a bit more kind of understandable and easy to imagine. But if you have data that Velociraptor collects, for example, registry keys or Windows event logs or something like this, and you just shove it into a machine learning system and you don't pay attention, it might learn that all the bad things are related to one host. So in the end, it only learns the host name and not anything else. Or it might only learn a certain UID or something rather than paying attention to the bigger picture. And that's something that you often don't realize if you don't really look deeper. And that's also why these systems often fail without us really knowing why or how. And the last thing that people often say is, well, what if adversaries know I'm using the system? And one really nice example is with these neural networks, you have a picture of a panda, you add something to it, just overlay it, and it becomes a different thing in the eye of the machine learning system. And I can imagine there's a pixel-wise addition, but what you see here has been scaled up a lot, because if we looked at this in the original, it would just be a white image and humans wouldn't see the difference. But the machine learning system sees the difference. And that works also for, say, classifying malicious files, for example. So if you have a PE executable, you can see what are all this system or function calls this executable does. And you can use this information to classify files into good or bad. And then an adversary could calculate, oh, which system calls do I need to add to make this look different in the eyes of the classifier. There are also other demands you can make for robustness. For example, logging formats change all the time, sometimes without notifications. And system and user behavior changes over time. So things we think are normal might change. For example, people might stop using Zoom as much and maybe go to the office and maybe then use more Office directly instead of talking on Zoom sessions. And that's something that we also need to think about when we want to build systems. So now that we have kind of some requirements, and I hope there are some answers in the call, you can ask, why is machine learning for incident response actually kind of difficult? Like what aspects of it make it harder than all these really successful applications, right? Because machine learning seems to be working well for identifying faces, all the things that Instagram does, all these like filters Snapchat puts over faces. That seems all to work really great. So why is it much harder or seemingly harder to use reasonably in cybersecurity applications? And the answers are often, it's the type of data we use. So first off, there's something called class imbalance. We often have very few examples of really things being bad, and we have often a lot of examples of things being all right or okay, or at least we think it's all right, because often we are not 100% certain that things are actually normal, or if there already is a sneaky attacker in it. And then the data we use is often very unclean and it lacks standardization. And we can see that even if you look at Windows event logs, they are, I think, one of the better logging format, but the event IDs are not standardized across all logging services, for example. And then kind of related to the class imbalance, there are very few examples of things doing bad. And even if we sit down and try to analyze the case and say, let's find all the bad things, it's actually terrible to do, and we'll probably miss malicious behaviors because we never catch all of it. So if you want to make a data set to teach machines from, they're either very artificial or really kind of incomplete. And then another thing is that we often face that we in practice, for example, all these successful image applications don't face as much, is that boundaries are often very unclear. There are a lot of dual use binaries that a system administrator might use, but that also might be used by a malicious actor. Whereas a cat is a cat and a dog is a dog. And that's really clear to tell apart. But for some binaries, for example, it's not as easy to say this is clearly suspicious or this is clearly okay. And then other problems we have is we have a very wide audience because we have incident responders, and incident responders, of course, in themselves have a wide range of backgrounds and a wide range of different motivations why they want to look at data. Sometimes it's just to look at alerts in a kind of SOC theme setting. Sometimes it's to drill down and find attackers. Sometimes it's to understand what actually happened. And sometimes it's just to make sure that nothing happened. And then, of course, there are adversaries. So once you train the system, attackers will probably try to behave so they are no longer detected. Versus in normal settings, cats don't try to look different to no longer be identified as cats by machine learning systems. So there's a lot more influx, right? And the question is what can we do about it? Does it mean we can't use machine learning? And the answer is, of course we can, but we need to think about it. For example, we need to measure the usefulness of models correctly. There are lots of ways to say a model we have is useful, and not all of them are actually the right ones to use. And the same goes for what we use the model for. We can be very ambitious and say we want to classify all binary files into good or bad. But actually, that requires a lot of binary files as examples, and it requires us to have a lot of labels. And it also assumes that the files are somewhat static, that they're like no regular updates, small updates that change the files. So sometimes it's easier to minimize or make the task smaller and say, instead of classifying all binaries in good and bad, I actually want to group all binaries into files that are similar to each other in terms of their capabilities, for example, what system calls they can do. And while that doesn't really tell you what's good or what bad is, you get groups of files. And then when you look at these groups, you might actually say, oh, these files here that are all similar to this admin tool, they shouldn't be running there. And that gives you a similar capability, but the task is actually much easier to model. And we did a case study with a security company called iSecurity here in the Netherlands. And I think it's a really good case study to see what can we actually do kind of as incident responders with kind of limited manpower and also limited time, despite all these kind of limitations and kind of things that really bug us, without having to resort to using really large enterprise tools or like installing Darktrace or some other large vendor XDR system that's supposed to use a lot of machine learning. So in this situation, our partner had lots of post-breach logs from incident response cases. My task was, can you have the analysts do their work better? I can look at this and say, well, what do we know about the limitations immediately, right? We don't really know in these logs what's good or what's bad, what's malicious or what not. We also know, because there's a rollover, we don't really know if the malicious behavior is at the end or if it's everywhere, or if it's only at the beginning. What we do know is that most likely there's much fewer malicious activity than anything else. And we also know that the incident response analysts, they don't really want anything technical in terms of looking at a system and needing to understand it, right? It needs to be actionable and accessible rather than something kind of academic. So what we did is we just used an unsupervised learning technique. So a technique that doesn't require us to categorize lines into good or bad, or into malicious and benign. And instead, we focused on just finding novel behaviors. And then we gave the analysts kind of a timeline explorer to see all the log entries, but annotated by a score that tells us how surprised is the system to see this happening based on the context. And that's kind of what it looked like. So we have all the hosts here, and all these hosts have Windows event logs running. And then we have a log viewer. I redacted this stuff here, but you see here is a column that has scores. And then you have a timeline here that is like 3-ish, 2.5-ish years. And you see spikes that indicate log entries with really high values, and indicate and see some low values. The high values means something happened that we didn't really expect. Of course, that's a lot to look at. But as this is an incident response case, we had an idea at what time people started notice things going wrong. So it's easy to kind of find something to drill down around the time and we suspected that things are going wrong. So in this viewer, you can like kind of select things and zoom in. And as you zoom in, it filters out which logs are left. And if you drill all the way down to this, what we found was here in the next slide, you can see it better. There was a user that executed a file called nascan.exe in a pictures folder, which I think is not really the expected behavior of a system administrator. And to get there, we only looked at kind of novel and unexpected behaviors. We didn't need to pack in any domain knowledge or anything about executables and where they usually run or what their name usually is or who runs them. So this kind of offered the log lines in a sorted fashion, and it offered a fast entry point to investigation, in addition to knowing at what time something happened. But the data is looked at and evaluated manually. So this doesn't take the human out of the loop. It doesn't take away the kind of effort to look at logs, but it made it faster. We purposefully chose to use these EVDX log files And we use them in a way that we kind of lose some information, but we are kind of certain that it will work even if there are new applications or new logs running. And overall, this is much faster than looking at the data without guidance, but of course, you still need to look at it. And we kind of A/B tested this. So we had people look at an incident that never looked at this incident and compared how fast they could find some insights using our tool. And we observed that they had considerable time savings through these findings. We're currently still kind of evaluating to see if we can quantify how much precisely we can save. But I think this is a really kind of good and promising case on how to use machine learning in incident, kind of to support analysts and enable them to do things faster that they can already do, rather than kind of try to automate their job and give the responsibility completely to a system. We are building an artifact that you can run by Velociraptor. There's a Git repository. We haven't pushed it there yet because we're still making sure it runs on all Windows versions, because we noticed that on some it didn't really do what it did. So you can just start the repository, you'll get a notification when we push a new version there. We also have this timeline explorer, which is not part of the artifact, needs to be run separately. We definitely want users to test it, to try it. I think it's very exciting because it allows you to kind of take this artifact, run it on say 1,000 machines kind of separately in parallel, and then look at the machines that did the most unexpected things first, rather than not knowing where to look first, for example. So overall, Velociraptor is a really great platform to use these techniques. And this is kind of what I had for today. I hope that you have some answers and lots of questions from me. You can always get in touch with me via email or on Twitter. So let's see if there are some questions.
So we don't see any specific questions for you right now, Christian.
Okay.
So we can probably wrap it up here. And as you said, people can get in touch with you if they have any specific questions they want to ask. Yeah,
so we can quickly look at the answers here. So most people haven't used any machine learning or data science because they don't feel they have the skill set to try it. That's the most common thing. And then the other thing is, and I heard that often, is that actually people promise a lot and try to sell you stuff that actually doesn't work. And this is the other limitation. People want to understand what they are going to use. I think that's also a really tough demand for these systems. And most people haven't tried it yet in real life. So I'd be super happy if people actually try our artifact and like write me if they want to know what's actually happening. Yeah. All right.
All right. I don't think anybody heard that I was on mute, but there's a quick comment in the Discord channel, Christian. I don't know if you want to speak to it real quickly. But triaging IR data before manually looking at it is always a good idea. Applying AI to it in this way is a very good approach. Well done.
Yeah, thank you. I think that is actually something that has been kind of underserved by the market, because it's much easier to sell all companies kind of pre-incident tools than to sell some unlucky companies post-incident tools, right? So I think in the future, we'll see something happen in that space, but it seems to be a much more unattractive space for, say, the large amount of VC-funded firms, for example.
Got it. Cool. All right. Well, thanks a lot, Christian. Really enlightening presentation. I think we got a lot out of it. Thank you again.
Yeah, thank you.
All right. So before we get continue on, I just want to give a kind of a quick public service announcement. It looks like the Zoom domain is down, or it was down for a little bit. I got a few messages from people saying they couldn't access the webinar. I think Zoom has resolved the issues. It was all on their end, but I think they've resolved the issues, at least in the short term. That said, if you know anyone that is having trouble trying to log into the webinar, please just direct them to the YouTube stream. This YouTube stream has been up and running strong. It hasn't, skipped a beat. So, again, it's a good kind of alternative to the webinar. Obviously, the webinar is the more robust kind of way to digest the conference, but it's always good to have that alternative as well. All right, so with that, we are going to move on to our next presentation. It's by Dan Banker. It's called When Dinosaurs Ruled the Blue Team, Retrieving Triage Images with EDR. Dan Banker is the threat response team lead at Motorola Solutions. He spends his time threat hunting, writing detections, and responding to incidents. His primary areas of experience are DFIR, EDR, and network forensics. Unlike most of the rest of the world, he actually likes digging through PCAPs. When not keeping Motorola safe from hackers, he can be found bringing up the rear of the field on iRacing or playing guitar with Chicagoland Metallica tribute band Blackened. I got to say, Dan definitely wins the award for the best profile pick at VeloCON 2022. So with that, I am going to hand it over to Dan.
Good morning, afternoon, evening, everybody. Can you hear me? It's the first test.
Sounds good, yes.
Excellent. Now we should be seeing my screen.
We gotcha.
All right, 2 for 2. No demos, so I didn't have to make a sacrifice to the demo guys today. Okay, so you may be asking yourself why you're here. Well, it's better than working, right? So I'm here to help address some issues that are a little more prevalent since the COVID pandemic. I don't know about you, but my management has not even specified a target date for when they want us to go into the office. I assume we're going to be doing some kind of a hybrid work from home, work from office thing. But for DFIR practitioners, we have some additional challenges due to remote work. Also, kind of the same challenge is due to us being a global company. We have users literally all over the world, and trying to find them online can be difficult unless you like working late. I certainly don't. So it's tough to just walk to somebody's desk and say, hey, your machine's infected, I need that. So we're going to talk about getting a triage image, which would be kind of a smaller amount of data to pull across the network. I will not, I think I have to say cloud, sorry, but I'm definitely not going to be using the machine learning, AI, any of those kind of buzzwords. I will be talking about ER, triage images, memory dumps, and Windows in this presentation. So who am I? I mean, I have been playing guitar for about, I don't know, 100 years. I'm primarily into metal. You know, I do kind of look like one of the guys from Slayer. I also am into video games, specifically iRacing. I've got a pretty built out rig for racing, including the steering wheel and pedals and stuff like that. I've been doing iRacing long enough to learn that as an American, if you race somebody from Finland, you're probably going to lose. The people from Finland are just born with steering wheels in their hands or something. And there's no, it's no coincidence that a full 1/10 of current F1 drivers are from Finland. Also, the music business sucks, so I have to have a day job. That would be InfoSec, which, you know, it's not music, but it's certainly something I enjoy. I'm currently with Motorola Solutions. There are 2 Motorola's. Our Motorola does radios, 911 dispatch software, things like that, mainly supplying the police, fire, and military industries. We don't do the phones or routers or any of that side. Nobody cares about my credentials really, but I have been in the industry over a year. I do have at least 1 certificate. Also, I will die on this hill. The command line was better than the GUI. Also, I know some of you are smarter than me, so if I'm saying something stupid or something's not clear or have any questions, feel free to interrupt me with those. Carlos, if I haven't noticed a question, please chime in and let me know.
You got it.
Thank you. Okay, quick rant. I've always felt that the rock star is kind of a strange paradigm for high performing IT practitioners. I've worked with a lot of real and imaginary rock stars, and they tend to be immature, not very good with money, not very good with relationships, up to and including domestic abuse, substance abuse issues. They tend to die young. I don't understand why there are role models. Also, I know that that's not the real Sid and Nancy. If you have not seen the Sid and Nancy biopic from the 80s, it's a great early Gary Oldman performance. Okay, so let's talk about the problem I'm going to help solve for you. I don't know about you, but most of the alerts that I respond to end up being false positives. Either it's a crappy rule or there's some kind of context missing, and we need to investigate further. So sometimes we don't see everything we need in the logs. EDR helps, but EDR is based on mainly process trees. So if an event happens that's not in the same process tree as the event that caused it, it can be difficult to correlate the two. So a great example is word macros. Depending on how you write your word macro, you may not see the command shell or PowerShell spawn directly from Word or Excel or whatever. So it can be difficult to try to correlate and try to figure out exactly what happened here. So one option for getting more of the data that's important to us would be a triage image. A triage image is much smaller than a bit-for-bit copy of a disk because we're really only getting the stuff that's important to us. We're not copying the user's programs or videos or pictures or any documents, any of that stuff. We're just going to get the things that are important to us as investigators. So a quick example of that would be the registry. If you do Windows DFIR, the registry is super important. Windows event logs, Command or PowerShell logs, antivirus, Skype or other chat logs, the master file table, browser history, and prefetch. So in my test scenario here, we're looking for evidence of execution. Like, we think this malware ran on this machine, but we don't know all the events surrounding it. So we can grab things, some registry keys or hives, like user assist, shim cache, which is also called app compat cache, am cache. These are different registry locations. Prefetch is in C/Windows. There is a .pf file for every program that runs on a machine. Windows event logs, for example, 4688 is a process start. Command logs and PowerShell logs. So those are important because we can get the command line. So we would be able to see if our malware ran with specific command flags. So all of these give you kind of overlapping information, but they also provide different bits of information. Like from some, you'd get like the command line that ran, and from a different one, you'd get the hash. From a different one, you'd get timestamps, that kind of thing. So you always want to have several different sources of information for your investigation. So I mentioned DDR. I hope all of you know, have some sort of familiarity with it. For me in 2022, I consider it pretty indispensable. Whenever there's an investigation, when I don't have EDR data, I find myself hamstrung and finding more, it takes more time to get to the bottom of it. But if you're not familiar with EDR, the one facet of it is telemetry. Think of it as a flight recorder. Whenever one of your endpoints starts a process or stops a process, creates a file, makes a network connection, writes to the registry, anything like that, these are all logged and uploaded to a database. So then you can search through this database for things like show me a command prompt that spawned directly from Microsoft Word, or show me a PowerShell that had execution policy bypass in the command line. So there are a lot of different ways that you can search for through your data and generate watch lists for activity that you're interested in. The other, typically you're going to find some kind of live response capability. It boils down to a shell. You can open a shell on any of your machines, which is great if you're trying to respond quickly. If you see a process running, you can log onto that machine and then kill the process. You could run a process. You could upload or download files. It's great for, if you have config files that are associated with malware, you can download those. You can quarantine hosts too. If you're trying to prevent lateral movement, you could just log on and quarantine the host. It can't connect with anything except for usually you can connect back to, in the case of Carbon Black, you can connect to the endpoint will be able to connect to the Carbon Black server. So you could still reach it through live response. I promise I'm not trying to advertise for Carbon Black, but I have to use that kind of as my context because that's what I'm familiar with. Let's see if this works. All right, so this is showing us what process executed, the time that it executed. Here's one view of the command line. It's kind of showing the same thing down here. We can see I blocked this out, but we can see the user that executed this. We can see the operating system. We can see both the local IP and the public IP. So down here we have the process tree. We can see that our PowerShell process was launched from command. The command process has also spawned ipconfig and ping at some point. We can see that in turn our PowerShell process has spawned whoami. So this gives us a really good view of things that have happened in our host. You could also look and see for this PowerShell, you could see if it reached out to the internet. You could see if it made any file modifications or registry modifications. You can see which DLLs it has loaded. So there's tons of great info in this screen right here. I'm pretty sure I don't have to explain what Velociraptor is at VeloCON, but there it is. So I think it was in my SANS Forensics 508 class, they mentioned that you could create an executable to run on a host to collect artifacts from it. So this gave me an idea. What if I could use Carbon Black Live Response to deploy the executable? The simple answer to this is yes, you can do it. I'll give you a second to look at the meme. Okay, I hope it's funny. I'm not going to spend a lot of time on the nuts and bolts of creating your collector because Velocidex has great documentation. Can't tell you how happy that makes me feel because I work with a lot of security tools that have crappy documentation. So thank you so much, Velocidex. But basically, you need to run the Velociraptor server. So you need to generate a config, create a user, admin password, right? Start the server, and then you've got yourself a web server on localhost 8889 by default. In your config, you can run it on any port you want to. Excuse me. So now we need to go to the server artifacts page and hit this guy right here, which I think is a paper airplane. I don't know. I'm not sure what the icon means. And then do a search for Cape and select this right here, that windows.capefiles.targets, and then click add. In the click configure parameters and then check the box. So I have never found a need to deviate beyond either basic collection or the sans triage. And basically these are just lists of artifacts to grab. You can customize that, grab whatever you want to, as much or as little. I have not found a need to go beyond these. So then just click configure collector. To me, the defaults work fine. You know, the target OS is going to be Windows. It's going to create a zip. You can have it create a different kind of output file if you want to. You can password protect it. I don't, but you can. So now we've got a collector. Just for OPSEC purposes, I renamed mine servicehost.exe. I don't know about you, but I've got a lot of developers in my environment that watch their computers like hawks. If they see something taking more than 1% of the CPU, they get upset. So hopefully they would see service host among the other, 10, 20, whatever service hosts running on their machine and just deal with it, rather than, if they saw something that was called Velociraptor.exe, they might get suspicious of it and stop it, which we definitely don't want. So now that we've got our collector, we need to upload it to the remote host. So just wait for an issue where you need to grab a triage image and find that host and upload it. In Carbon Black, we're going to use the put command. Again, in terms of OPSEC, you don't want to put this thing on the user's desktop or documents or downloads, anywhere where they're going to potentially see it. You could put it in temp. You could put it in c/users/public. I don't know, somewhere where you don't think the user is going to find it. Then once it's uploaded, you're going to execute it. In Carbon Black, you would use either the exec or exec-g. Then you need to wait. In my experience, it'll take about 10 or 15 minutes to run. And then you're going to see some output files appear in the same directory as the executable. The zip and the HTML are the important ones. There's also a log file, which I've never found much use in, but get it if you want to. Then you're going to do your investigation. And then it's probably a good idea to delete the executable and the artifacts. You probably don't want the user or whichever APT is on this network to find your artifacts here. I should point out a great thing about this zip file is when you extract the items from the zip, there's a folder path. The folder path is the same as the Windows host that you grabbed everything from. So if you've done DFIR, you should be familiar with c/windows/system32/config. That's where you're going to find all your registry hives. So you would go to, not all of them, most of them, you would go to C, which is the top level folder in your output files, and then there's going to be a Windows directory under that, then system32, then config. So all of your forensic artifacts are going to be in the same location as they would have been on the Windows system. So it's easy to find whatever you need. There are some caveats. If you think that your investigation is going to be part of a court case, this is not the best way to go for a variety of reasons. First of all the evidence you're collecting is going to have modified timestamps based on when you ran Velociraptor, because Velociraptor is just copying all these files and putting them in a new location. So all your artifacts are going to have timestamps relative to when you ran Velociraptor. Excuse me. If you have been involved in court, you would know that you don't want to have to explain things like this to a jury. If you think you're going to be in court, just get the bit for bit image. The case here is more for, I think something unusual is happening on this host and I want to find out more information. The other thing you're doing is when you run Velociraptor, you're creating artifacts on the system. You're creating a bunch of files that are going to show up in the MFT. You're creating a prefetch for your Velociraptor executable. Again, you don't want to do these things because you're going to have to document all of them and explain them in court probably. One thing too, sometimes it just fails. And I haven't had this happen very often, and I haven't had it happen often enough to annoy me enough to make me want to investigate. But occasionally you'll run it, you'll see that the PID is no longer there, but your output files aren't there. I don't know why. Like I said, it's rare enough that I haven't needed to devote time to figuring out why. Another caveat, you're not always going to find all the malware artifacts on disk. It is very popular for malware to execute at least partially or even fully in memory. So you may not see, like for example, you may not see the malware ever being written to disk or the config files or the output files or whatever. So just beware of that. This isn't necessarily a silver bullet. However, you may realize that getting a memory dump is a great way to investigate malware that's live on the system. So Velocidex has our backs here with a executable called WinPmem. And basically, you're going to run this exactly the same as we did with Velociraptor. Does anybody call it VRAP? Is that cool? I'm way too old to know what's cool and what isn't, but I expect some credit if it goes viral. Anyway, so you're going to create the WinPmem executable, upload it, run and load it, download the dump. Here's where you run into problems because now we have at least an 8 GB file we need to move across the network. And having, we're talking about multiple hours of, in Carbon Black's case, you need to upload the file to their servers and then back from their servers to your machine. So it may or may not work. If anybody out there programs EDR products, what I really want is to be able to run volatility commands live on the host. If you've done memory forensics, you're probably right off the bat running malfind, PS3, pslist, netstat, maybe a couple of other functions to try to figure out what's going on. I just want to be able to do that right on the host. And I know Carbon Black can't do it. I've asked them for it. I don't know about other EDR products. Okay, so if you know anything about me, you know I like to automate things. So what if we have to grab several images? It can be tedious to go through this process for each different host you're interested in. Carbon Black does have an API. I've always felt that one of the product's real strengths is how fully featured the API is. So what we could do is create a script to fulfill all these functions, upload the binary, run it, download the output files, and then delete everything that it created. I'm currently working on this. I haven't gotten it to work yet. If I was a better programmer, I'd probably be able to solve whatever the issue is, but I haven't gotten this to work yet. But the other problem that you can solve with this is if you're a global company and you need to get a triage image from a host that's in Korea or whatever, that way you're not having to stay up until midnight to find your host online. You can just script it so that the script will look for the host being online. If it doesn't find it, try again in 10 minutes or something like that. Then if you do find it online, then keep going with the triage image. If you really want to get fancy with this, you can integrate it with your SOAR. That way you just have a triage image button and the SOAR does everything in the background. And then when you're ready, your artifacts are there for you. Now, I promise you I have not been compensated for this talk by Carbon Black. I'm just using Carbon Black because that's the tool that I'm familiar with. This process will work with any tool, EDR or not, that is able to upload, download, and execute binaries. If you can do that, you can make this work. You could probably do it even with, I don't know, RDP, AnyDesk, anything like that. Again, if you can do these three things with your tool, you can do this whole process. Now, what if you have Linux? I tried to create a Velociraptor executable for Linux. I think what I did is accidentally create a Windows executable and then try and run it on a Linux machine, which didn't work very well. And I sort of gave up and moved on to something else because we don't have that many Linux machines in our environment. However, there is a script called AutoLLR. It's in the GitHub at the bottom of the slide there. This is basically just a bash script, and the process is exactly the same. Upload it into temp or something like that, run it as root, and it's going to give you a zip file with a bunch of, it doesn't gather the artifacts necessarily, but sort of gives you text files that give the important stuff out of the artifacts. So if you have Linux, I recommend trying that. So what we've done today is create a Velociraptor executable, upload it to our remote host, run it, download the output files, and then win by finding the APTs, right? Very simple. And I know this is just a tiny little bit of what Velociraptor can do, but it works pretty well for this application. And then just food for thought. I'm pretty sure of the attribution on this quote for this Taylor Swift. Anyway, thank you so much. Appreciate you listening to me. I'm happy to answer any questions.
All right, thanks a lot, Dan. We don't have any specific questions right now. A couple of comments, maybe I'll just mention. In the Discord channel, user JDub01010101 writes, what Dan is going over is our go-to when dropped into a network. And then our user Predictable writes, the underappreciated way to use an offline collector is to have it run the same artifacts you would use in an online scenario and then import that data into the server. Unfortunately, too many people use an offline collector purely as a file collector. Don't know if you have any follow-up comments to that, Dan?
I don't, unfortunately.
No problem.
I'm glad to see other people are onto this process, though.
Yeah. All right. Well, I think with that, we can move along. Thanks a lot, Dan. Really great presentation. A lot of comments from people that really appreciate your imaging in this Prezzo. I think you definitely won the award for the best use of memes and pop culture references, for sure.
Good, good. I mean, that's more important than having usable content, is entertaining people, right?
For sure. For sure.
I was what, 10 minutes short?
No, that's all right.
Thought I was going to be shorter than that, so I tried to pad it a little bit.
No problem. Not a problem at all. All right. So with that, everyone, I think we can actually move on to the lunch break portion of the day. Depending on where you are in the world, this could be breakfast, lunch, or dinner. But we're going to take a little less than an hour and a half. We'll resume, come back and resume at 1:30 Eastern time, which is just about, like I said, an hour and 25 minutes from now. So thanks a lot, everyone. We'll see you in a bit. Dan, if you're still on, there are a couple of questions in the Q&A queue if you want to take a look.
Yep,
Nothing in the
I'm still here. I was
Okay.
just looking through them actually.
Okay, cool.
What's for lunch? I don't know if I can answer that one. Oh, I should look in the Q&A. Oh, okay. So the question is, when you collect the triage and pull back results, import into the VRAP server. That's not my workflow, because since I learned in SANS, I learned like vendor agnostic. So I love the Eric Zimmerman tools. They're absolutely fantastic for like looking through the registry, browser history, stuff like that. Highly recommended. You could import them into the SIFT, I guess, and use the tools from that. If you are really good at using the Velociraptor server, which I am not, by all means, import the results into there and use that for your investigation. I can't do a demo because it would be on corporate assets, and there's no NDA or anything, so I can't do a demo. I apologize. Frankly, the demo wouldn't be all that interesting, because it's literally just putting the executable onto the machine, running it, and then waiting around for the output files to show up. Yeah, I don't even have a good demo. And OT artifact, no, I have not heard of that. Thanks, Alberto. I want to be a Dan banker when I grow up too. I don't know when that's going to be.
Hey everyone, we're going to get started again in about 5 minutes, and just waiting for everyone to get back from lunch. All right, welcome back everyone to VeloCON 2022. Hope everyone enjoyed a nice refreshing lunch break or dinner break or even a breakfast break, wherever you may be in the world. We still have a loaded second half to get to. It'll be just, the format will be similar to the first half of the day, right? We'll have 3 presentations in this first session. We'll have a break and we'll have another 3 in the final session of the day, and then we'll wrap it up. So with that, turn it over to Wes again, who you guys have all met in the first half of the day. And he's going to be talking about using Dinosaur Lab to uncover adversary actions and orchestrate rapid response. Wes, take it away.
All right, thank you. Give me just a moment to share my screen here. Find it. Screen 1, screen 2. Okay, share. And this. Go ahead and start my video and get this ball rolling. From the beginning. So let me know, look good on your side?
Yes, looks good.
All right, thanks, sir. All right, as mentioned, my name is Wes Lambert, and I am the principal engineer at Security Onion Solutions. I wanted to talk to you guys today about Dinosaur Lab, which is another project that I've worked on. It's somewhat similar to VelociStack maybe in some of the technical integration and that sort of thing, but just wanted to give an alternate perspective of some of the additional data or context that we might have from using something like Dinosaur Lab to learn about that and to experiment with these different tools. So that's what we're going through right now. All right, so what is Dinosaur Lab? It's previously named SOAR Lab. It's been a project that I've worked on for a little while. I've not had as much time to update as I would like. I did change the name though, based on some great user feedback from some folks on Twitter. I thought it was a great name. So I figured I'd go ahead and stick with that for VeloCON. But it essentially is a Docker-based project that allows you to tie together all these different open source or free and open tools to really learn about how we can enrich data, perform response actions, and kind of orchestrate our operations or security operations. Again, it's going to be similar to the previous talk, but there will be some key differences in this. So a little bit of context, I mentioned previously, I put out an article about tying together Security Onion, the Hive, N8N, and Velociraptor a while back, maybe I think it's really a couple of years now. But it was really about, again, integrating those free and open tools for detection, the orchestration, and response, kind of showing folks how they might leverage these tools in their enterprise, tying these different things together, doing different, performing different actions, getting different context, increasing context around data. So this is really based off of that with some architectural changes based on how Security Onion has changed and, things like that. So we'll get into that and get into the components here. Now, obviously, as with the other, Velociraptor is one of the core components here in this particular setup. We've got that for the host-based forensics, the monitoring and response, obviously the cross-platform awesomeness, and the super flexibility of Vehicle, right? But aside from that, one of the other big components is Security Onion. And I'm not sure how many folks on this webinar and this conference have used Security Onion before, but it's been around for a while. It's one of the kind of, in my opinion, de facto free and open platforms for intrusion detection, log management, enterprise security monitoring. There's things like host-based monitoring from the native capabilities like and then full packet capture as well. And then on top of that, similar to a lot of other, SIEMs or log management platforms, there's that ability to ingest a bunch of different log types, have those parsed and have those, have context, right? Because a lot of times we get this information, these logs, and we throw them in this place, and we don't get a ton of context. Really, the whole idea here is to make it easier to pivot from one data source to another, to be able to get the context you want quickly, and to go from there and speed along your investigation, right? So the quicker we can get that context, the quicker, hopefully we can come to a determination on what's happening with within our environment, and how we can scope it within the environment. So again, one of the main components within Security Onion for for network-based intrusion detection is going to be Suricata. It generates those NIDS alerts. It can also generate network metadata. So if you're familiar with Zeek in the sense that it generates activity for connections, HTTP traffic, etc., Suricata can also do the same now. So there's an option to do either or in Security Onion. And then obviously it uses rules to identify suspicious network traffic. those alerts are generated and then ingested into security onion, and then we can act on them and gather more context as we need to. Here's an example right here, just of some alerts in the alerts pane within security onion. Again, this is not all about security onion, but just want to kind of get through some context here. Similarly with Zeek, it can record network metadata. I mentioned HTTP and connections. There's also DNS data, right? Things, security onion is passively listening to the network traffic, then writing this network metadata that we ingest into the main stack. Things like SMB data, SMTP traffic, right? And then even file extraction, stuff like that. Both Zeek and Suricata can support pulling files from the network down, right? And then we can act on those with additional scripts or additional tools. So they're both very capable at doing that. Additionally, there's the ability to have full packet capture with security onion, right? So regardless of the network metadata being generated, we can see a raw capture of that traffic, which is very useful, except when you're in situations where you're monitoring encrypted traffic, right? A lot of times we might have to filter that capture out, but otherwise, when getting in between those encryption layers or mechanisms, we do have that available to us for that additional context. Now, here's just an example of a stream that we followed in security onion. There's a native way to view PCAP in the web interface. And then for those files that we interact with or that are extracted from the network, there is an application called Strelka, which is an open source file-oriented detection framework. And it uses a bunch of different scanners to get to generate different metadata about files and to give you, again, more context, right? But it analyzes those files extracted from the network and then applies those scanners, and then can also apply Yara to it, since Yara is one of the scanners. And I'll get to where I'm going with this in just a moment. Additionally, there is the capability to generate your own cases within security onion. So it's a great way to track activity if you're going through an investigation and then attaching different indicators or observables for follow-up later or for investigation now, right? It's a great way to do that. But this is not a security onion only talk. Dinosaur Lab also includes N8N, aside from Velociraptor, which is a free and open low-code automation platform. It's similar if you've messed with Node-RED. It's similar to Node-RED, similar to Shuffle, except Shuffle is a little bit more security focused. But just another one of those low-code automation platforms that really has a ton of different triggers and operations available to us to be able to act on that data, or to be able to respond how we want, right, and process data. So really the summary here, and I think I've got a duplicate slide there. The summary here is there's a few different components working together within this concept or within this project to essentially have this network traffic tied together along with this host-based traffic or this host-based artifacts, right, or results from running artifacts in Velociraptor, and then being able to perform some action in between the two to help identify additional context or to perform response in a somewhat automated fashion. So, kind of getting more into the meat of it and more of what it looks like in the actual lab. Setting up the lab is pretty straightforward. I try to make it always pretty simple. So if you want to set up the lab, you just need a running instance of security onion. You can, if you already have security onion running in your environment, you can install this on top of it. And the same, if you go and download it and run setup, you can install this on top of it. And what it's going to do is set up on top of security onion. It's going to set up N8N and Velociraptor, and then some other customizations to allow us to do things a little bit more easily. But yeah, so it's pretty straightforward as far as the install process, and I'll just leave that there. But how do we actually leverage it? Like, how's it even useful from a learning standpoint, or from thinking about how we might approach these same operations in our environment? So one thing I mentioned is that gathering additional context, right? Pairing activity across across host and network based data, right? We have this data from Velociraptor from this host collection that we collected, or just the fact that this was on this host, right? And then we have a client ID associated with that, and maybe a host name or IP address. Being able to correlate that back to the network stack can be advantageous, right? I mean, it might not always be one-to-one as far as IPs, but generally something like host name, might be pretty analogous, right? So we can do that for things like connections, for things like protocol-specific events, for alerts, right? Tying back the host that Velociraptor is installed on to the network traffic, and doing some correlation from there. And here's an example just from the security engine perspective in, this is called Hunt. This is an interface in security engine where you can search the data similar to Splunk, where we're just looking at the different types of data here. And we can see that we've got some different data from Zeek. We got some different data from Velociraptor, from OSSEC, all relative to the same IP address that is associated with this particular client, right? So, and we can do that based off the client IP or the source IP, just however it's defined when it's parsing. And we can also do this off of host name, right? So that's a great way to be able to, really validate something that happened on the host, or take something from the network perspective and then go to the host, right? Pivot to Velociraptor and go do some collection there, dig further, right? We want to dig deeper. So that's a great way to do that. Here are some examples of just looking at some different artifacts across clients, maybe just what's been run, just kind of a fun little way to demonstrate that from the Hunt interface. And then here is another way I mentioned pivoting, that we can leverage that context, right? So for example, we're investigating, or we're doing some threat hunting, or we're looking at events in security engine, and then we see this client ID over here. It's hidden in this right here, but this is what I clicked. And then it brings down this context menu here, and we can click right here to go to Velociraptor, right? This is one of the customizations of this Dinosaur Lab integration. So if I click on this, then now I can be transported already over to Velociraptor. It's a fewer clicks than me going and typing in Velociraptor or doing something else. It helps with, maintaining the stream of thought in your brain. And it just helps, overall, just from a more streamlined process, right? So then we can go dig into that host and go, run artifacts. And then, we could even come back to security engine later and then review the results of those artifacts and correlate that with other activity in there, other network activity, right? So it's just another great way to leverage that integration with the two of those. Similarly, if we wanted to come from Velociraptor over to security engine, right? Maybe we're in the results from we're in a notebook, or we're in the results from a Hunt or something else, and we want to go look up what this client has been doing in security engine. We can do that as well. Now with the new context menu available in Velociraptor, we can pivot to security engine from Velociraptor. So we can go back and forth as needed, getting that additional context that we all crave as analysts, as incident responders, and then be able to go from place to place as we need to and get that additional information. Excuse me, let me get some water here. All right, so another way. I mentioned Strelka before. I mentioned the fact that it can run Yara, right? So this is kind of a cut up alert, because from security, and it's kind of cut up because it wouldn't all fit on the slide. But you can see here we've got it. It came from Strelka, that it's an alert, right? We can see the rule. You can see that this detects a batch file that has been obfuscated using variable substitution, like a bunch of it. And the rule name here and the score. Let me get some other hashes for the actual file that was analyzed. So basically what happened was this file, either somebody downloaded it, right, or it was transferred across the network somehow. And then Zeek or Suricata saw that. And then after it extracted the file, Strelka analyzed the file, ran Yara against it, and now we know that this, occurred in our network, right? We can see some IPs or something else. right? We can see some other activity associated with it, but we might not have much more additional context, right? It might not be that easy to scope, right? Exactly who has this file or where it went or whatnot, right? So here's that rule again, just kind of getting into what it looks for. It's a very simple rule. Again, just it was slightly modified for the purpose of this demonstration for Dinosaur Lab, but again, just looking for that obfuscated batch file. So what we can do from here is, if you see here, we've actually clicked on this alert and we've escalated it to a new case within Security Onion. And then from there, we can do things like add additional details, add observables, right? We've got a kind of a description of the case here where it's been escalated, and we've added this particular observable right here, which was the file hash. We go back the MD5 from right here. Now, obviously, if we wanted to modify some things in the pipeline, we could use any of these that we want, but for the purposes of the demonstration, we chose the MD5 and we've attached that as an observable, can't talk, to the case, right? So now from here, we might go off and do additional investigation, right? We want to figure out how this is, where this is in our environment, which host this might have been transferred to, who else might have downloaded it. Now, if we look here, what's actually happening once we attach this to the case is we have a last alert running in security and in the background. So if I'm adding I've added a custom rule here to where it looks at any observables that I've added to a case. And then if they meet a certain condition, then it'll go off and send them to this webhook right here. And what is running at this webhook is actually innate-in. So what happens here is that this webhook receives this call from a last alert. We're routing by the observable type. If it was a hash, we're doing a hash hunt. If there was a file name that we're searching on, we're performing a file name. In this instance, the last alert rule fired and it was a hash. So it kicked off the hash hunt here. And if we go to Velociraptor, similar to the previous demo, we now have a hash hunt generated, right? From this observable, it's going across, it's searching every single endpoint that Velociraptor is enrolled in, right? Or that's subscribing to the hunt. And then we can see here that we have this one hit, right? We have one row returned for this particular client right here. This is the intimate details of this particular flow right here. But that one client that we have connected, we saw had it, right? We've confirmed that this hash did exist on there, so that file is likely present on the box. And what we've done now is, instead of trying to go search, a bunch of places, in Security Onion or go manually elsewhere, we've leveraged, the best capabilities of these platforms to go off and automate the scheduling of this hunt, and then get that context that we're looking for, right? So Velociraptor is doing all the heavy lifting. It's in this instance, right? We're sending it, we're saying, hey, go search for this hash, and then it's running. And then at the same time, we're also going to be quarantining hosts who return results for the hash or the file name hunt, right? And this is a modified version of the Windows artifact, the quarantine artifact. And what it's looking for here is looking for any file name or hash hunts that have returned with any results. And if a client did return for that result, it will quarantine that host. And so we see this here with this particular host, right? We'll see that this basically met the criteria right here. We'll see the local hashes query here and the hunt that it created the run or the flow, right? And then the fact that it then later came back and was quarantined because of that server artifact that was running. Right now, we could customize this a bunch of different ways, right? I mean, there's a lot of different ways that you could change this. You could have Velociraptor completely handle the event handling, right? You don't necessarily need innate-in or some other intermediary, but it's just a nice way to kind of think about how you might interact with different systems and think about how you might process and manipulate that data coming from the source system like Security Onion. But yeah, I mean, all of this, like all the integration is completely also doable within VeloCON itself, which is, I think, predictable. Presented last, what was it, at the Velociraptor artifact competition, was a great example of a lot of automation and a lot of kind of management functions from the VeloCON perspective. So as far as the as far as going through the demo or anything else, that is all that I have at this time. It ended up pretty brief. I think in the future, though, for this particular project, I will probably be replacing Shuffle with N8N to be able to tie in with some other security appliances or other security software. And I want to look into some more integration with security and Velociraptor a little bit more closely, right? Think about how else we can tie together that context and orchestrate those actions, swiftly and in an efficient fashion. So unless you guys have any questions, I think I actually have one more slide. Yeah, I do. Okay, so here's the summary here. Again, just a summary of the data flow. So in the example, we created that case and attached the IOC. And then Elastalert, along with security NN, was looking at that, right, checking for those IOCs or checking for those indicators or observables, and then hands it off to N8N, which then in turn hands it off to the correct Velociraptor hunt. Again, completely automatable from the Velociraptor perspective, but hopefully this helps to kind of get you going in some particular direction with experimentation or anything, things like that. But yeah, if you have any feedback or any other questions, please feel free to let me know via Twitter or via the GitHub. All the details are right there. And I think that is all I have for you guys for today for this particular demonstration.
All right, thanks a lot, Wes. Does anyone have any questions for Wes? If so, you can just throw them in the Q&A tab of the Zoom webinar, or ask the question in our Discord channel, and Wes can get back to you with the answer. With that, we will turn it over to our next panelist. I'm just going to share my screen real quick. All right. Next topic. This is one that I've been really waiting for when we started putting together the agenda for this conference. Mike Cohen is back, and he's going to be talking to us about a cloud-native Velociraptor. So take it away, Dr. Cohen.
Let me just unmute. Thank you. All right, let me just share screen. I think this one. All right, can you guys see it? All right, can you hear me and everything?
Yes, we can hear you, and it looks good.
All right, great. Let me just kick it off. Okay, cool. So thanks everyone for joining us today, and I just wanted to talk to you guys a little bit about a sort of a project that I've been working on in my spare time, cloud native Velociraptor. And it's kind of like, it's sort of like a researchy kind of experimental project, but I hope that it's gonna be an interesting thing. So let me just jump straight in. All right, so cloud native cloud Velociraptor. So the project is about deploying Velociraptor in the cloud. And now you might ask, wait, don't we already deploy Velociraptor in the cloud? And of course we do, right? Most of the time we will deploy Velociraptor in the cloud and then have all the clients connect to it. But when I'm saying cloud native Velociraptor, I actually mean that it uses cloud technology to be like infinitely scalable, basically. And it's really all about scalability and being able to handle a lot of clients and a lot of load. And so, when I talk to a lot of, cloud engineers, Google and other like big big organizations about the Velociraptor and how we use local files, and they always look and say, hey, that's not scalable, that's crazy, why would you do that? And so that is a limitation, right? Which we deliberately took when we designed Velociraptor. So most of the high scale cloud technologies use other things in local file storage because it's more scalable, because you can increase load. So the idea here is to try and explore how would it look like in a real cloud environment, real cloud thing. But the most important thing that I wanted to take away from this talk is that it's not a replacement for Velociraptor. It's just another kind of Velociraptor. So if you like, another kind of dinosaur, maybe, I don't know. So let's go back, and it's kind of interesting to think about how it fits into the whole, history and design goal. And the thing about Velociraptor is it was designed to be really easy and very cheap to deploy, right? Because it was written for consultants, and it's really easy to deploy. You can just spin it up and deploy a new Velociraptor server in literally 5 minutes. And all you're going to pay for it is a cost of a VM in the cloud and maybe some attached storage, because it uses files and it just runs on a server, right? So it's actually quite cheap to run, and it's designed really to just deal with 10 to 15,000 endpoints, which is it's sort of a medium number of endpoints. Like probably I would say that maybe like around 50% of users would probably be super happy with this kind of scale, right? So it's not something that a lot of people go over. So it's a pretty reasonable amount, but it's not like huge, And the nice thing about it is that there's no really external dependencies, so we can easily deploy it, and that's what makes it cheap, because we don't have a lot of dependencies like load balances and all this kind of stuff. So that all adds up, right? And so mainly it's catering, the architecture is catering for ephemeral kind of deployments. Like if you're a consultant, you're doing an IR, you deploy something, you go to deploy it, and then you set up something. But now that we've actually been around for a while, and it's become very much a enterprise grade application, then there's actually much newer use cases for this, right? So people want to be able to have it there all the time, have a monitoring and response solution that it's always installed, and installed on large numbers of endpoints, like hundreds of thousands and more. And it's also important to have multi-tenancy, and that's I covered that in the last talk, where we have multi-org support, because when you have multi-tenancy, that's really great, because you can group together all the customers into one server, and then it's actually more efficient and reduces cost as well for cloud deployments. But in order to do this, you need to have something that's horizontally scalable, so that when the load increases, then you can just deploy more and more servers, and then you just get more capacity. And then when the load decreases, then you just shrink it down so that the load can be flexible, and so the cost can basically be flexible, so it can change with demand. So this is what horizontal scaling means. So you can increase the number of servers as you need them. When you're doing heavy hunting, you increase it. When you do less heavy hunting, you just decrease it, right? So this is important. That's not really possible with the current architecture, because it's just a one server thing. So let's think about history, and I like to think about like, how did we get here and where are we going, and that kind of thing. So let's think about where Velociraptor started, right? So everybody knows, I think we've covered this before, that Velociraptor started from Google GRR, which I was working on many years ago. And to be fair, I haven't really seen Google GRR for many years, so it's possible. So what I'm talking about is the way that it was probably many years ago. So it's not necessarily what it was today. But Google GRR was like the first idea of doing this kind of hunting and scale, right? And being able to collect a lot of data from a lot of machines really quickly, and scaling up. But it had some issues mostly around performance, because we didn't really understand the problem space at the time, right? Because so I mean, obviously it was, you know, hampered by using a slow language, but that wasn't really the main problem. The main problem was the design of the system was really around doing a lot of work on the server side. There was a lot of, you know, and also there was an extensive data model, because we didn't really know at the time what it was going to be used for. So, you know, like we thought, you know, there was like complicated database schema and complicated like attributes and objects and entities and blah, blah, blah. And it's just kind of very complicated stuff. And because of this extra complexity, it meant that there was a lot of, you know, work to be done collecting this data. And it was a cloud-first architecture because it was, you know, came from Google. So, you know, from the first thing, it was cloud-first, right? So it had to have scalable. It was very scalable. So it had lots of components, had a worker, a front end, a GUI, you know, and databases. It uses a database, and, you know, at the time, Bigtable in Google, and, you know, MySQL in the open source. And this is kind of like the architecture. You can already see it's quite a complex architecture with lots of message queues and databases and modeling and all this stuff. Anyway, it turned out this didn't work, right? It was just too slow, and it didn't really scale very well. So when Velociraptor came around, the idea was to try and make it faster. And by making it basically addressing a smaller size deployment. So rather than going with a cloud first approach, actually just going with like, hey, let's just get this thing done. I just want to collect, you know, a small number of endpoints. So setting our sites lower allowed us to simplify a lot of things. And of course, VQL really helped here because it meant that we could offload a lot of the server processing straight off the server into the endpoint. So we didn't have to spend a lot of CPU cycles on the server. So it scaled much better. And the most important thing, in my opinion, that we did is get rid of the data model. Because, you know, at the time, there was all these kind of forensic ontologies type, you know, type models, and it was very big into models. But it turns out that models is basically what nobody really wants, right? Because no one really cares about models. They just want to collect files and, you know, queries, right? So, this is why Velociraptor is schemaless. There's no real schema inside, and we don't really have a data model. We just collect queries. And so it's very flexible because you just collect whatever you want. And, you know, we don't really have any processing. And it's easy to deploy, very big focus on easy to deploy and file storage backend. So that was kind of cool. And so what actually ended up happening is that by looking, going small, we actually ended up going really big, because by restricting our goals, by saying, look, we don't care about cloud, we don't care about scalability, we're just going to design something small for the small consultancy, you know, 10 to 15,000, that's going to be our goal. We're just going to design something small. It turns out, and, you know, and simple. So we don't want to use a database, we'll just use files. So, you know, like, so it turns out that file storage is really, really fast in practice. It's a lot faster than databases. It's really fast. And by not having a data model, it makes everything really efficient. And so what ended up happening is that Velociraptor is very efficient. And because we have just the one binary that does everything, that's monolithic, that it basically makes deployment really simple, and it's really manageable, and it's really targeting that smaller part of the user base. But it turns out that, you know, we already can scale just with that to very high levels, even, you know, much higher than what GRR could, and that, you know, without needing to be cloud first, right? So we can already do it. So the question is, how do we go bigger than that, right? So we designed it to 10 to 15,000 endpoints. How do we go bigger, right? So I mean, I know some people are running at 20 or 30. They just increase the size of the VM, and it sort of works, but there's a lot of problems once you get to that scale, right? So what are the problems? So one of the biggest problems is TLS encryption. That's CPU intensive, so that you can't really mitigate. You can offload TLS off the server and help to some extent. IO bandwidth is saturated. You know, we're writing to the disk, even though it's a local storage SSD, it can be very, you know, can be saturated. And the GUI, because the GUI is sitting on the same server as the front ends, then we're basically all competing for the same resources, right? So when someone does a notebook query that processes a lot of data, well, that's taking CPU load from talking to clients, right? So you're collecting less. So it's all kind of like interfering with each other because it's all just the same server. So then we had a multi-front end Velociraptor architecture, which I mentioned before. And that was the first, that was an attempt to move higher scale, right? To go to higher scale. So the idea was because everything is a file, we just kept the same kind of architecture, but instead of using local storage, we're going to use distributed storage, so EFS. And then we have multiple servers in master minion architecture. And that's really good already because it removes a lot of the work from the GUI. So the GUI can do notebook processing by itself, and then the clients are still, being able to talk to the minions, and they're able to talk and then just write the data to the EFS. And so, everything kind of works. And then we use message passing. Of course, when you distribute things like that, then you start to have coherency issues. So we use message passing to synchronize everything. And the nice thing about this architecture is that we still aren't using cloud native things, right? So there's no dependency here on any cloud thing other than, I guess EFS, but EFS is just like distributed file system. So it's nothing special, but we're not using any specific things to do with cloud. It's just a general architecture. So it's actually quite easy to deploy. It's a lot easier, not as easy as a single one, but it's a lot easier. It turns out that cloud technology introduces a lot of I/O latency because it's a network-based thing. So everything is network-based. So there's a lot of latency introduced because of that. So this is kind of like the architecture, and it's kind of it's a little bit more complicated. Okay, so what we want to do now is to say, well, how can we go beyond that? How can we go higher than that? Because we still have a bottleneck here, which is just a single master and multiple minions, and we use the master to synchronize all the minions, right? But so we want to go higher than that. It's still not really cloud native. So how can we make it cloud native? So when we talk about cloud native, we want to horizontally scale all the servers so we can just keep churning them out, auto scale them. You can sort of horizontally scale the minions, but then you don't really affect any notebook performances and things like that, right? And then we want to use cloud managed storage instead of EFS. So something like S3, buckets, stuff like that. And in order to do that, to be able to horizontally scale, we need to remove all the state from the server. So we currently have lots of things running on the server, like artifacts, server event artifacts, and things like that. And then can we use a database for a backend? This is kind of like more traditional cloud native thing. So, we're moving away from files, we're going back to databases. Well, that sounds kind of familiar. Are we going back to the same architecture like GRR, right? Like this is kind of like deja vu, right? So it is kind of not for everyone because it's much more complex and much more expensive to run because you have more things, more services, right? It might be cheaper when you're operating at that scale, but if you're not, then, so we don't actually really want to just remove the current architecture, because the current architecture is really good for the segment of the market where it needs to be, right? So there's this, if you only ever need to run 10 to 20,000 endpoints, there's no point having people ripping all that out and saying, oh, now you're going to have to run, OpenSearch and, an S3 and it's going to be more complicated and harder, because that's not really what we want to do, right? So that's why it's completely separate project. It's a different project with cloud first architecture. So how do we actually reorganize the code so that we can use the two kinds of approaches, but we don't really kind of like rewrite everything from scratch, right? So previously, we had an abstraction at the storage layer. So because again, everything was a file, so we just changed things like instead of writing to disk, we wrote to EFS, right? So we had some abstraction at the storage layer, but that's kind of not very flexible because if you're just attaching at the storage layer, well, you're still doing the same thing that you were doing on local disk, like just reading files to represent, clients and various metadata. But it's not very efficient at the higher level of scale, right? If you have a database, you may as well use the database to do this searching and indexing, right? And so we need to have an abstraction at slightly higher level. And so that's what happened here. So we're reorganizing the code base to create something called Velociraptor services. So it's kind of like a microservices architecture, but it's kind of it's still kind of in a monolithic binary. So the idea was to break out all the things that, different things did into what's called services. And then each of those services has a well-defined interface so we can change them. So for example, we have something like an indexing service, which is used to search for clients, and then we have an implementation of indexing service, which uses files, which is the normal one. But now in the Cloud Velociraptor, we can change that to use the database. So we can, leverage the, database for searching, labeling, client info, these kind of things. So all of these services are basically just different parts of the application, different parts of what needs to be done. And by separating them out into services, we can compose a new kinds of applications. So if you look at the code base now on GitHub, you'll see a services directory. You see all these kind of services. And these are basically the kind of building blocks of Velociraptor. And the current version of Velociraptor, the standard version of Velociraptor, will just use the standard implementations that you see here, but those implementations are just file-based, and they work pretty well for what they need to do at the scale they need to operate at. But now we're in a position where we can just swap them out. We can swap them out for different ones and try and play around with different kinds of implementations, different things. So it's much more flexible. Because we can swap them out, and we can create a separate project on GitHub that just kind of like uses Velociraptor and then swaps the different implementations by composition. So that makes it much easier and safer to work, because we're not going to break the code base all the time, because we don't actually really use that. So there is a new GitHub project, and it's up here, Cloud Velo. We can check it out, and as it's kind of an experiment, right? So we're trying to see what are the best, cloud technologies that could be used there. So, it's kind of straightforward. S3 for storage. So we're going to store, if we're going to do uploads, we may as well just put them in a bucket. So for bulk storage, we're going to upload to S3. And we're going to use OpenSearch for structured storage, because it's like a database, right? And so we have these are the two types of storage, right? And then the servers themselves are stateless, so they don't really have any state, so we can actually, horizontally scale them. And this architecture is, so far, it's not really possible to do everything that Velociraptor can do. It's, most things you can do, but certain things you can't do. So this is kind of what it looks like. So over here, we have the UI, the admin UI. So this is like your browser, and it talks to the GUI. And then the GUI itself just uses the bucket, the S3 buckets to read the storage, and OpenSearch to actually read like the result set, the collected data. And then over here, we have the clients, and they're kind of like distributed. And then they talk to a front end or ingester. So they're just like ingester kind of services. So these services they basically terminate the TLS, do the decryption and all that stuff, and then they basically just kind of like receive the results from the client and just write them into the table. So they don't really do a lot of logic here, and so that means that we can just scale them horizontally. So when we increase the number of clients, this just kind of like increase, right? And so as long as we can sustain the OpenSearch, query rate and the S3 query rate, then we could hammer it as fast as we can we can actually transfer as much data as we can. So this is kind of like the idea here, where it's kind of horizontally scalable. And yeah, so the ingester doesn't really have state, and it just kind of it just writes the data. And then the GUI just kind of runs on the status server. We also have a foreman, which is like a batch processing job that just kind of schedules all the hunts and stuff like that. So I just wanted to show you guys a quick demo. I mean, it's not very exciting because it basically looks the same as normal Velociraptor, right? But behind the scenes, it's using this architecture. So here I have a system. So when I search for things here, that goes to Elastic and does the search, right? So we have structured storage in Elastic where we store all the metadata, and then we can look at each of those. This is a Windows machine, right? And if I look at that and I go and go into the VFS. Now, in this current architecture, because there's no really way to notify yet, so we're relying on polling. So polling is like kind of like the old style of like. So what you'll see is it's very slow, right? Like that's what makes Velociraptor really snappy, is the fact that normally we don't rely on polling because it's connected always, right? So we can task it as soon as it's as it's going, but in this case, because we don't have a way to notify it yet in this cloud, so it just kind of like polls, and then we have to wait for it to come back. So basically, this is the same thing. We can go over here and we can add, we can do hunts. So if we do a PS3 hunt, for example, PS3. So it's let's configure the parameter, add the PS3, and then start it. It basically looks the same, but unlike the normal Velociraptor, we would just start scheduling it immediately. So now we have to kind of like wait for the clients to poll, and then we have to wait for the foreman to do it, and then so there's a couple of steps, and it's a little bit slower. You see, it's done it, and then and then we can look at the results, sort of thing, right? So it's the same thing. So the UI is basically the same. So it means that we can see all the same, because the queries are still running on the endpoint, so they're still doing the same thing as they always did, but they're just being stored now. So this data is stored in the OpenSearch index, and when we download files, that's stored with. I haven't shown you how to do that. So yeah, like if we go here, and then when we download files, it just gets pushed into S3 immediately. So it gets kind of written into S3, and so we can use that to store more data. Potentially cheaper. So like if I go to the end user dat, for example, end user dat, and collect it. So again, it's kind of slow to do it, but then once it does it, it will go and sit in S3, but it just uploads to S3. So it's a little bit slower than, because we have this polling thing, but see, and then it's the same thing, right? And then you can view it. So that's reading it straight out of the bucket instead of out of local storage. So that's kind of how it works. It's still not production quality, I would say. So there are lots of limitations. It has some limitations because of the polling. It's a bit slower. Updates are slower, and it turns out that OpenSearch is just slower than storage. I mean, because it obviously makes sense, right? Because you have to send it over the network, right? Whereas, if you're attached to an SSD, you can write in, nanoseconds, right? So it is a lot slower, and we're still not sure how that scales, but it should be all right. But we might have a lot less write IO. And it is so complicated. There's lots of moving pieces. So that's why it's not really a replacement for the regular Velociraptor, but it's something that would be useful for high-end type deployments, right? So we could use that to research better improvements. better optimizations, and we only use like OpenSearch, but maybe there's going to be another database that's faster. I don't know. And we don't have server event monitoring at the moment because there's no state on the server, so we can't really run anything. But we're just going to keep it as a separate project. And it's kind of like going to be a second project, right? So it's in its own GitHub repository, separate. So yeah, so just to conclude, it's just an alternative Velociraptor that we are just kind of experimenting with. And we hope that it can scale a lot higher than the current Velociraptor. That would interest some people, you know, but not everyone. So it's not really for everyone, really. It's just kind of like for very high-end deployment sizes. But it's a good test case. And because of the refactoring that I showed you before with all the services, that really opens the door to be able to experiment with other types of architectures. You know, maybe we're going to use, you know, MySQL instead of OpenSearch, or maybe we can use some other storage type, you know, so it allows us to mix and match in the same way and build different kinds of Velociraptor. Yeah, so yeah, I don't know how I'm going for time, but if there's any questions,
yeah, you're doing great for time, Mike. We do have one question. Is the GUI polling the backend services, or are the Velociraptor agents polling?
So there's no so the agents are polling. So these clients are polling, right? The GUI just talks to, you know, to the, and there's no service, there's no, they're just talking, the GUI just looks at the OpenSearch database. So this is more of a traditional approach, right? So you have your web application sitting on top of your database, and it reads from the database. This is pretty. This is why it's not possible in this current architecture right now to kind of, you know, notify the clients, because they're not really connected directly. They're polling here, and you can't just, like, when you launch a flow here, you can't just say you know, just go ahead and, you know, and task it, right? Because it's actually, you know, it's disconnected, right? So you have to. So maybe it's possible in the future to add some kind of, you know, message queue type thing, Redis or something like that here. It's possible. So we'll look into that. But at the moment, it's not possible. So so this is kind of like, it goes back to the GRR architecture where you know, it was also doing polling, and the user experience was terrible because I think the poll rate was down to about 10 minutes. So you would have to, like, you know, refresh the directory, you would like click the thing, and then you have to wait 10 minutes, you know, to come back. So it was just unusable, right? But we hopefully will improve that.
Cool. So we got a couple other questions. The next one is there any known reason why not all clients automatically start a hunt, even though they're online, connected, and collections can be run to completion on them?
So they do. I mean, all the clients. So I mean, when you launch the hunt, they all start, right? But basically, like, let's say if you have 100,000 clients in your whole database, right? But only 10,000 clients are there, right? So what happens is currently, so when I did the hunt here, I need something to kind of schedule it for them, because I can't. The problem is with cloud technologies is that, you know, it's kind of slow, right? So every time I go to the database, it takes time, right? So I can't, if I just kick this and I let the UI do the scheduling, then it's going to have terrible usability, right? Because it might take 20 seconds, 30 seconds, 100 seconds to actually schedule all the clients, right? So that's why there is this batch process called the foreman to actually go and do that. And so it does the scheduling, but I just kind of like kick it off, you know, when in the UI. So I have to wait for it to kind of pick it up. It's one of the problems is, again, that you don't see that when you're running, you know, a Velociraptor on local SSD storage, because everything is so fast. But when you go to the cloud, everything becomes a lot slower. So there are things that need to be done a bit differently.
Got it. One more question, and this one comes from Jordan, who asks, what AWS service does the front-end ingester use?
So the ingester is here. So it's the same thing. It uses the OpenSearch and S3 buckets. And all it does is it takes the results from the collections and then just stores them into the bucket or the OpenSearch, right? So when I went over here and I collected, my file, right? Then it started a collection, right? So it basically just the same, right? It's the same as before. It started, the query starts running on the endpoint, and then it sends back the results, and that goes into the ingester, and then the ingester just kind of like, it writes it. So this is coming from S3, actually. It stores into S3, and then the results, these ones, they go into OpenSearch. So it basically just writes it. That's all it does. So yeah. Hope that answers the question.
Yeah. Questions keep coming. I didn't see anything about a message queue in the Cloud Velo architecture. Did I miss something?
Right. So there's no message queue right now. Which is why we don't have any notifications or ability to notify, right? Which is why we don't have low latency right now. So we may be able to add a message queue, in the future. But all that would do is allow us to have low latency, which is worth it, I think. But at the moment, it's just plain simple, right? So yeah, there's no message queue at the moment.
Got it. Okay, and one more question to go.
One more.
Yeah. Actually, we got a couple more if we have time. We still have a couple minutes before the next topic, but I know this is a bit of a different topic. This comes from Mike Pilkington, but can you expand a little more about how the Minion/EFS solution is working out for larger deployments?
So Minion EFS is, so the way that it works is that usually you don't really have clients on the master node. So it frees up the master node, right? That's kind of what it's supposed to do. So the clients are talking to the server all the time, right? And they are the ones that are actually imposing a lot of load in terms of I/O bandwidth. And especially on the clouds, you have this IOPS limits, which is like how fast you can write to the storage, right? So with EFS, there is an IOPS limit. And then basically that's what you're trying to do, is distribute the load between lots of servers so that they each can sustain the IOPS, the IO operations per second, right? So they can write as fast as they can into the storage, right? And then keep the master serving the UI, the GUI. So the master is really snappy because it doesn't really write all that much. It might read a couple of things from the UI, but it's not really collecting a lot of data, right? And then the clients are just kind of like, imagine if you're doing a hunt that says like, collect all the, EVTX files or whatever. And so there's like hundreds of clients, thousands of clients hitting up the minions and trying to upload these files. And so they're all written to the EFS here and sustaining these IOPS, right? So that's kind of the point of this architecture, is trying to distribute that that heavy writing kind of behavior between the minions. And then the GUI is really snappy because it doesn't really have a lot of load on it. So that's usually the masters running the GUI. And then we have these event queues here, which are the message queues that were mentioned before, that keep everything synchronized. So when you're on the GUI and you say, hey, start this collection, then it basically broadcasts to all the minions, hey, someone starts this collection, and then the client's going to be attached to one of them and just start it, right? So it happens quickly. So you don't really need to poll, so we can keep them connected all the time, right?
Awesome.
Really so it's working out anyway.
Yeah. Really great questions, everyone. Thanks for asking. We'll wrap this one up now because I want to give enough time for Luke because we're at time now.
Yep, cool.
But thanks a lot, Mike. As always,
No worries.
We'll
Thanks.
see you again later on.
Thank you.
All right, we're moving along here. Our next topic is a good one, and I know all of our presentations today are good, but this is one that I've really been looking forward to for a long time now. It's Velociraptor and Law Enforcement by Luke Fardell. So take it away. Oh, let me introduce Luke first. So Luke is the director of DFIR for control risks, specializing in ransomware investigations. He has investigated over 100 ransomware incidents globally and previously worked for the UK's National Cybersecurity Centre, as well as the Ministry of Defence. That sounds really important. So I'm going to hand it over to Luke.
Amazing. Thank you, Carlos and Mike and everyone at Rapid7 for having me. Yeah, this is a slightly different topic. A lot of the topics have been really kind of technical, which is awesome. I wanted to give you a scenario we were faced with that you might end up being faced with yourself, and just to kind of give you points that I've learned along the way, and just something to bear in mind if you end up in these situations as well. And I'll give you a bit of a background on a specific case we had, obviously anonymized, and then I'll go into the detail about how Velociraptor helped us, what it collected, and how we dealt with law enforcement with data that we did have from Velociraptor. So I'll share my screen here for you. Let's see. Hopefully you can see that now. Great. So we had an incident. We do.
Still don't see your screen.
Oh, hold on. There you go. I have to hit the share button. That would help.
We see it. All right, go ahead.
So we deal with lots of ransomware cases every year. I said 100 there, but it's probably hundreds now. And you get that phone call on a Friday night from a company that have called you up. And for this specific case, we had all the same sort of indicators that we typically get for a ransomware case. So IT admins couldn't access systems. Everybody's screaming at the help desk because they can't access their data. But there was some sort of different kind of symptoms on this one that were quite interesting. So physical access to the building was disabled, and also when the staff, the IT department, tried to get a hold of the network, they couldn't get access to any of their sysadmin accounts. So they had to physically go to the server room, and they found they couldn't get in there, and that system didn't rely on the domain credentials. So it was, for them, it was very strange. They hadn't experienced anything like this before. They had to jimmy the door open to actually get into the server room. So we did our typical thing. We started scoping the incident, and the kind of trigger for us is that basically the data was inaccessible. So we were expecting to jump on the file servers and find everything ransomware, etc. So we started talking through what they had actually done on the network to begin with, and they'd done a little bit of kind of triage analysis. They managed to get into the server room, jumped on a local admin account, started going through those event logs, and found that there was a strange domain admin account that was conducting a lot of the activity. So this was all new to them, and they raised these on the calls, and that's something we typically see anyway, but it was that physical access thing that kind of spiked our interest a bit on this one, which was super cool. So let's just click through these. So the client immediately contained the network as much as possible. They didn't want anything coming in and out of the network at all. We weren't sure what we were dealing with here. So the way they did it was we weren't allowed to deploy Velociraptor like we usually do, which is using Azure with the GitHub, MFA, etc. But we did find a solution on the call. It took a little while, but we managed to get a jump box in the network, and we deployed it on that, deployed the agents through Manage Engine, and we were linked into the endpoint within the network using Tailscale, which is fantastic if you've not used it. And they were happy with that communication in and out of the network. Everything else was blocked. We were able to run hunts, collect data on that host locally, and then the collected data that we got, we were able to pump out over the Tailscale link to our local systems to do the analysis and forensics that we wanted to do. So one of the big things I'll say, rightly or wrongly, one of the things we always do, and we've got really good at, when we jump in a box with Velociraptor, is run a triage hunt. We usually do a basic collection on everything. It uses tons of data, and that's why Mike's previous talk about the scalability thing will massively help us in the future, because we want to get a snapshot from every system on that domain as quickly as possible. Just basics like MFT, registry, and event logs. I can do 90% of my investigation with that amount of data. And when we're working through the investigation, the client, this is Friday night, they want to be fully operational by Monday morning. So they were there ready to pull the plug on the, the domain controllers, start rebuilding the Active Directory. And then they've got offsite backups. They're going to, get those uploaded. So the network that we had access to was about to be nuked. And we had a very limited window to grab what we could. It felt like a bit of a robbery, but we had to go in, get what we could. So massive triage hunt, and then grab key logs and bits and bobs from the domain controllers, anything on the perimeter, firewall logs, etc. Get it and get out, basically, was our message. So we identified that this strange account was created many months prior to the attack, and this plot started to thicken, and so we started tearing into the data, and we issued all the kind of standard hunts we do, evidence for execution, lateral movement, key indicators, and stuff like that. We also run AD audit on the domain controller and identified the account that Triage was using, and we started tracking that account and the activity that it had conducted during its access window that we had. And something else, again, that piqued interest was there was absolutely no reconnaissance within the network. It was at that point we realized we were dealing with someone who knew the network, an insider threat. I've done a lot of training in network compromises, and you always do prepare and learn about insider threats, but it's rare you actually see one. But when you see one, you'll know about it, because the way they move is just so smooth, and it immediately kind of, normally they drop in tools left, right, and center, scanning the network and the domain, but it was just like bang, bang, bang from system to system. The threat actor went on the access control systems, physical access control systems for the building, without having to find it, just hopped on it, went on the application and messed up everyone's access to the building, which was super interesting. I didn't actually know what the application was, but we found the activity through shellbag analysis, and we started calling it out over the calls to the victim. And they were like, that explains why we couldn't get in the building on this morning. And we didn't know about this at that stage. They hadn't put two and two together. They just turned up for work, couldn't get in, and kind of dismissed that. And then when they got in, the network was on fire. So when we started finding these, they were like, oh, okay, that doesn't make sense. But we started to kind of piece this puzzle together. We extracted the entity.dit and system hives and dumped all those lovely hashes. And we got the hash for the account that threat actor created, and we were able to crack the hash over a period of time, which later on became relevant to the case. We grabbed the VPN logs, etc., as we always did, and we identified the system name that connected into the domain through the VPN logs, and this all kind of started ringing bells with the client. Essentially, we were faced with an insider threat. Former employee left the company, but before they left, created an account, and then some months later used that access to get back in and thought they'd make a mess of the network, essentially. So we didn't know at the time we were dealing with an insider threat, and evidently this case went through the kind of, fire weekend, I call it, where we had to grab as much data as we could, get the network back up and running, report our findings, etc. And then some months later, as this process kind of carried on, it became obvious that it was going to end up in court. and the network as it was at the time is long gone. The data we collected is the data we have to do our investigation on, and evidently that's going to be the evidence that goes forward to court. So how did Velociraptor help us in this situation? So evidently massively. We had all the triage images from every host on the network. We also because we deployed that kind of jump box as well, we were able to just scoop all the logs, everything that Velociraptor dumped. We could just take the whole lot out. So we got all the metadata as well for all the triage images that's created with the Cape Triage image collection. So that is, what files collected from which host, when, etc. So that in itself is a lovely kind of piece of evidence. All the results from all the hunts. So I've blurred them all out here, but your typical evidence for execution. We took the results from everything, downloaded it locally, and stored it. The client information from the server side. So we're able to give a list of all the devices that we were deployed to, very nice and neatly. We actually contain as well the deployment configuration. So the MSIs we use to roll it out, all the server access logs. So that's the Linux box, the actual server side, to prove that that was intact and not interfered with at all. All the hunts we ever executed. So on the server side, you can dump all the hunts lists, and that shows you, when you run the hunts, which hosts as well ran the hunts, which is quite key. And we also grabbed lots of screenshots as we were going through. We wrote a lot of custom hunts, etc., on the fly, and we were able to just capture all those and screenshot everything. We do this anyway, and I was really grateful we did it because it came in extremely useful. So where are we right now? So speaking from a UK perspective, I'm sure it's probably similar across the globe. The procedures that we're working with right now with law enforcement are really not fit for the scale of investigations and the methods we're doing the investigations with right now. So, we're speaking to law enforcement and lawyers, and they're expecting you to turn up at a laptop and be able to full disk image the laptop, to multiple disks at the same time, chain of custody paperwork for each host that you go to, which is amazing when you've got 1 to 10 laptops, or you've got 1 to 10 staff with you doing this process. When the network's on fire and you're told you've got 4 or 5 hours to get as much data as you want, you've got to get out. And there's 2,000 hosts. That process is just impossible. So it's not scalable. The kind of cloud environments we're having to work in now, these auto scaling systems, etc., it's just not possible. There's also a very good argument about the over collection of data. You've got systems which are not directly linked to the investigation, and by full disk image in these systems, you're collecting other users' data, etc. So there's a PII argument there as well, over collecting data. As you all know, it's very time consuming doing the imaging process. The amount of data stored on our devices is increasing by the day. Obviously, network sizes are increasing in complexity and size. And then when you factor in stuff like RAID systems and then SSDs, you image an SSD, you can do it 10 minutes later and you won't get the same hash. So, you've got to explain this in court, which is pretty tricky. This was me just running a test actually on a 256 gig SSD, and the verification took longer than the actual imaging itself. So it's just trying to highlight the point really that scalability is just, that was a quick 256 SSD. We're dealing with terabytes these days. So this is just a quick run through of like the law enforcement structure and kind of how I dealt with this. So I was dealing with a metropolitan law enforcement. So they had a technical understanding to a certain degree, but it varies massively depending on who you're speaking to. So local law enforcement and some regionals might not do cyber investigations a lot. So you're going to have to really walk them through what it is. When I said I deployed Velociraptor, they said, "Where is it now? Can we have it?" And it was like, so kind of you really got to talk them through what it is you're doing, how you're collecting data, how it differs from what they're used to and what they're trained on. And then we sat down and talked about how we collected the data, and the police would talk about law enforcement, the lawyers not having a good understanding, and then the lawyers would talk about the police not having a good understanding, and it was trying to find that balance and get the language and the kind of message across that we collected it the way we collected it. We didn't realize it was going to end up in court, but we are confident the methods we did use are sound, and we can prove that. So how does Velociraptor track these, help tackle these issues? So when we did the CAPE collections, every single file is logged and hashed on upload, which when you're speaking to lawyers and the police, this started to resonate with them. They started to understand, oh, okay, right, so the data taken from there was hashed on upload, bang, so it's not been interfered with, and we can then go back and prove that single strip of data has not been impacted. And just talking them through this really helped. All the metadata for the files uploaded is stored in a separate CSV as well. So that's your typical MACB timestamp data. So that was really useful, because then we could go back to the original data and prove that it hadn't changed at all during this process. All the backend server data, so what we did, when we did it, how we did it, was invaluable during this process. So the list of hunts we did, the results, which clients ran which hunts, and data on all the users in the domain, etc., where they'd been, like we could track all this so neatly with Velociraptor, which was absolutely incredible. But we had to find a way to boil this down with the lawyers and containerize the data we had collected and put it all together in a nice kind of neat way, so that it could go to court and we could, replicate that investigation again and again and again, or anyone else could. So what we ended up doing is archiving it all into an LO1, like a custom content image with FTK. But speaking with the lawyers, we could have used any tool as long as we could we understood how the tool works, and we can verify the hashes, etc., of that contained evidence store. So I put some examples here: 7 ways, X ways, etc. You can do that with those as well. Everything we did, we kind of archived it, labeled it. It was all nicely neat per host, and then all the additional logs, we just kind of made a big, nice, neat stack essentially. All the configuration data for the deployment of Velociraptor, all our documentation about when we did it, how we did it, store all of that, times, dates, etc. Get it all stored, logged. If you keep a log, like we do when you're having calls with people and you're doing things and actioning things, store those in that evidence file as well. All the external data that we captured, and we essentially, got all this data together, archived it, hashed it, and handed it over. So the main lesson learned for me is, this goes back to the kind of principles of forensics, the data integrity and the documentation. So I put a quote down there at the bottom. We've got a kind of a legal framework here that the police use called ACPO in the UK, which basically there's kind of guidance about how to collect digital evidence in a sound manner. And the key phrase is that any third party can repeat the process and arrive at the same result. And the documentation is out of date, and I have reached out to them to try and help and input into that. But if that is the key phrase, essentially all my evidence that we gathered, I can hand that over to somebody else, and it's containerized, it's intact, every artifact in there is intact, and we can prove that they can reconstruct the whole investigation from beginning to end and come to the same conclusion. and all the kind of data around that Velociraptor collects is part of that overall massive package. Understanding Velociraptor and how it affects the system, the logs that are left on the system as well, is really crucial. And yeah, just making sure that that investigation is 100% repeatable for the courts, etc. So yeah, that was basically what I wanted to cover off. So yeah, you know, massive project. Went in there, didn't realize that it was going to have a law enforcement angle at the end. Then all the original evidence is gone, but we preserved everything we collected. We can prove how we did it, and it's all gone through the courts, etc. And yeah, just wanted to highlight that Velociraptor does massively help how it collects the data. Are there any questions?
Yeah, this is great. Thanks a lot, Luke. That was absolutely fascinating. Yeah, does anyone have any questions for Luke? Pop them into the chat, pop them into the Q&A, the Discord channel. We do have one comment in there. Mayo notes that there would be no way of doing this without a tool like Velo. And then a counter comment by Mike, not in the time pressure, for sure.
Yeah, time pressure was massive. I've been in networks and people have had to, well, I've had to stop people from just yanking cables, and I'm waiting for, you know, data to download. I'm like, please just give me 5 more minutes. And they're like, no, this has got to go. And they're like pulling cables out. So having that way that we can jump in, you know, hundreds, thousands of hosts and just grab a triage image from everything. And even if we just got that, we could walk away happy and just be like, boom, 90% of our investigation should be fine.
I just wanted to add, can you guys hear me?
Yep.
Yeah, I just wanted to add that, you know, when we're doing consulting, that what you were mentioning about essentially archiving the whole Velociraptor server, that was like a pretty standard thing. And a lot of companies required that, especially after getting consultants in to do IR, because then they would have like an audit trail of saying, hey, you know, the consultants came in, they did this, and essentially that archive of the whole Velociraptor data store with all the hunts and the logs and everything. And if they need to go back and say, what did these guys do on our network? They can say, hey, they collected all these stuff. This is all the evidence. This is what they touched. You know, so it kind of like archives the job, you know, in general, like just, it's not a law enforcement thing, but it's just an audit compliance type thing, right?
Yeah, exactly. All the data's there, and it's you know, beautifully presented. You just need to get it and hang on to it.
Yeah, so it's good to archive it at the end of consulting jobs. That's what we used to do a lot. So just wanted to acknowledge that. That's good.
Yeah, Mike, there is a question in the Q&A, probably directed to you, Mike, not directly related to the talk, but about LE forensics and Velociraptor in general. Are there any plans for Velociraptor to create something like AFF images instead of pure zips to satisfy the quote unquote forensic soundness of its collections? Or is AFF4 dead anyway?
Well, I mean, so the thing about AFF is that AFF is a zip file anyway, right? The thing about what makes AFF not a zip file is having this RDF data model with you know, provenance and hashing and all this sort of stuff. So we already do hashing, and you know, and so there is kind of like a standard, an AFF standard, but look, I mean, we could generate it if there's demand for it, and if there is client libraries to be able to do it, but I don't actually think it's necessarily, like as Luke was showing, as long as you have the hashes, it doesn't matter what format you actually store the hashes in. I mean, at the end of the day, you're going to create an AFF format file, which is just a zip file with an RDF, you know, style, you know, file in it that has hashes. So, you know, instead we're creating a zip file with CSV file that has hashes. So, you know, it doesn't really matter. It's the same thing. We still have the same data in it, right? So,
yeah. And you've got the FTK hunt as well. You can do the logical image to a local drive remotely as well, if that's a necessity.
yeah. Yeah, you can image the disk, right? Oh, the logical image, right? So you did the logical image of the data store. Is that what you're saying?
No, I didn't. But that's another option. Like if people want to kind of preserve the data.
Yeah, but I mean, at the end, it doesn't really buy you that much. It's just another archive format. Yeah, I don't know. I mean, yeah, we could discuss it, maybe raise an issue, and we'll discuss with the merits of it. But I don't really see the difference between a zip file with hashes and an FF4 file with hashes. It's the same thing.
Okay, another question from Sam Spade, who asks, what does it take to collect forensics ready data with regard to insider threat?
It's all your typical, what does it take? As in, I mean, like the triage images, the way I like to do it is grab the data. Well, in this instance, grab the data using Velociraptor and then take it out and do your investigation with whichever, well, you can do it on the host as well, but you run it in X-Ways or whatever tools you like to use, Event Log Explorer, etc. And in this instance, we could only really use Velociraptor to grab quickly at scale. The bulk of our investigation was done outside of it. But yeah, I think when you work, I've worked on hundreds of ransomwares, and there's that period of kind of the threat actor fumbling around the network for a while. You know, the shell bags are wild. You see them clicking through stuff. They're dropping like advanced IP scanner, etc. And they don't know where they are, what's going on. We've seen threat actors, you know, looking up the company name on the company's network, like who the hell are these guys, basically, and looking up their net worth as well before they deploy the ransomware. So when you jump into an insider threat case, it was just totally different. As I mentioned, the threat actor was just moving, boom, boom, boom. Like there was no kind of, where am I? It was like, I'm going here, I'm doing this, bang, bang. And the actual kind of dwell time was minuscule. They knew exactly what they were doing. So yeah, you'll know it when you see it, trust me.
Right. Nissi asks, is there somewhere I would be able to find details on any legal cases involving Velociraptor?
I don't know, is the honest answer. I don't know of any, unless you might, Mike or Carlos, but I don't know of any that have gone all the way through and ended up in prosecution yet. I might be the first.
I guess you might be. First time for everything, right?
Don't get a badge.
Yeah. All right. Well, unless there are, let me check. It might be one more question. There's one more. Apologies if this was already asked. My connection dropped. Luke, did you do any research to characterize Velociraptor in terms of impact of the live client on the target systems? For example, what changes to the original system occurred specifically due to the Velociraptor client, with principle 2 of ACPO in mind?
So we deployed it on our own host as the server in the environment. Well, the host they provided for us, but because we used that hot box, it was all kind of nicely contained on that host. And in terms of the endpoints, you know, we use Velociraptor for most of our investigations. It's extremely lightweight. All the kind of data is preserved in whatever location you choose, essentially during your configuration. So in your YAML configuration, you can specify where, you know, the kind of data is written, etc., before it gets uploaded to you. So yeah, I mean, we're very familiar with the tool, and no issues, you know, describing the impacts of it on the remote systems. It's extremely minimal. I think, Mike, you'd probably know more, but yeah, very minimal. And now you can throttle it as well, so yeah.
All right, sounds good. I think that's it in terms of questions. Luke, thanks again. This was great. Really,
Thanks for having me, and I really appreciate it. Thanks.
We all learned a lot. All right, so with that, we'll take our last break of the day. This was originally supposed to be just a half an hour break. It'll be closer to 45 minutes because we're a little bit ahead of schedule. It might be a good opportunity to, respond to some email, go for a walk around the block, stretch the legs. But we'll check back at 3:45 and we'll get started again. Welcome back to VeloCON 2022, everyone. How's everyone feeling? Energy levels still high? It's okay. We're in the home stretch. We still have a pretty jam-packed final session for you guys. And then we're done for the day. So I'm going to turn it over to our next presenter, Mike Pilkington, who will be.
Hey, Carlos.
Hey, Mike, how's it going? Mike's going to be talking to us about Mac response, the good, the bad, and the ugly. And just to introduce Mike, he is at Control Risks. He is an author and instructor at the SANS Institute for the courses FOR 508, Advanced Digital Forensics, and Incident Response, and FOR 608, Enterprise Class, Incident Response and Threat Hunting. After spending much of his career working in large corporate environments in the oil and gas industry, specifically Halliburton and Shell, Mike joined SANS in 2017 as a full-time researcher in the SANS Research Operations Center. His current role focuses on R&D projects in support of the Digital Forensics and Incident Response Program. Take it away, Mike.
All right, thank you. And let me make sure I can share my screen. Okay, here we go. All right, let me know if you see my my main slide there. Okay,
That's great.
excellent. All right, cool. Thanks, Carlos. Thank you for that introduction. And super excited to be here to talk about a topic that's been kind of a big part of what I've been working on for the past year or so, which is Mac forensic analysis. I've also been digging into Linux and Docker analysis, really looking at a few different things. I'll just do a quick correction there on my intro. I'm actually at SANS Institute, and to give you a little bit of my background, I've been working in IT, various roles within IT for 25 or so years. I started out with an oil and gas company called Halliburton, and then moved to Shell, but I've done different things from systems administration, network administration, network, security, and for the past dozen or so years, really been focused on forensics and incident response, and it's just a fascinating area. So really, always excited to find new topics to dig into, and there's no shortage of those. And so, like I said, Mac operating system is actually a pretty new one for me. I actually had a Mac since like 2013, so almost 10 years, but I was the most basic Mac user for the longest time. I really just I had the fortune of getting a Mac Air, and it was one of my little travel laptops as I was, working and doing various work for SANS and my day job. And it was just kind of a nice backup laptop, to be honest with you. But I've kind of started digging in more because the class that we've just started teaching at SANS this year, Forensics 608, is really delving into enterprise forensics, looking at more than just kind of your Windows systems. That's primarily what we look at in Forensics 508. But Forensics 608, we're looking at multiple different platforms and also looking at larger scale intrusions. So I don't want to spend too much time on that. I just want to give you a heads up that it really gave me an opportunity to kind of dig into this platform, and it's been fun to kind of learn something new. I'll be honest, I'm still not the hugest fan of some of the UI. There's some things that really annoy me, like you just can't get to certain parts of the file system with Finder, the file browser, which still just bugs me, and a few other things like that. But I have to admit the technology is very cool. The operating system is really beautiful to use. The hardware is incredible as well. So yeah, that's where I'm coming from it. But so I'm not going to say I'm the biggest expert in Mac forensics. I put myself at a pretty high level on Windows. I'm getting better on Mac, and I'm having kind of fun digging in. So the way I wanted to do this was kind of structure this from almost a newbie's perspective in a certain sense, like how is the Mac operating system set up? How can we do some analysis on these systems? It is not the most straightforward platform, and that is certainly by design. Apple has really locked them down fairly significantly. That does not mean they're impenetrable, and maybe we'll talk about a few examples of that as we go. But they do make things difficult for malware and for attackers. Some cases even for the users. And certainly for security in some senses. So when we talk about doing incident response with our forensic tooling, we need to look at some ways to get over those hurdles. So about the first half of the talk is going to be kind of designed around looking at those hurdles and how we can get around them, specifically with Velociraptor. And then the second half will be talking about kind of things that we can do to do the analysis once we've gotten the visibility that we need. Okay, so yeah, just a quick overview of the agenda here, looking at some of those security challenges. So it comes to dead box analysis. What's going to happen if you do want to pull the system offline and image the host? What are the capabilities to do that? So we'll talk about that. There's a couple of different encryption levels we have to be thinking about. Then more pertinent to Velociraptor analysis is live analysis, and what are some of the things that Apple has done to kind of lock down the operating system that really makes it hard for our tooling as well. So we'll talk about system integrity protection and transparency, consent, and control. And then I want to walk you through deployment scenarios. So ideally, you're going to use that last step there, which is enterprise mobile device management. I'll have just a quick slide on some points there. But if you're taking this in baby steps, you want to do an initial deployment or just kind of start testing, I'll show you a few of the things that you need to do manually to set up a Velociraptor on a host, and a couple of the hurdles you want to get over there. So that's the first part. And then the second part is, looking at a few artifacts that are particularly useful. And by artifacts, I do mean Velociraptor artifacts. A couple of things that are kind of newish in Velociraptor, and so that's pretty exciting. And maybe one or two areas where we can still look for making some additional visibility, some artifacts. And I really wished I'd had more time. I wanted to spend more time, but I did start collaborating a little bit with Mike and also with Matt and Wes. So we have thrown around a few ideas of some additional things to do, and there's certainly no shortage of additional artifacts and collections we can do with this tool. Okay, so let's talk about kind of the first level of difficulty when it comes to doing MAC analysis and actually getting access to the data. That is a significant a challenge in some cases. The first level of difficulty here is the encryption. And so there's two versions of encryption, and often both are employed. So there's hardware level encryption that is on modern Mac operating systems, Mac systems. And the first one being the T2 based hardware chip that is really soldered onto the motherboard. It's now built into the M1 and M2. So this is really something that you've got to be kind of aware of. Now, that T2 chip you can think of a little bit like a TPM, although it actually has even more capabilities. It's built in and functions to help secure things like the Touch ID and fingerprint sensor and some other features. But largely it's keeping keys, from our perspective, keeping keys for hardware encrypting the SSD or the drive, really whatever technology or drive is on the system. Now, that's one level. And so really what that means is that removing the hard drive and trying to image the drive separate from that device is probably not possible. I'm not aware of any way to do it separate from that device. And so now, as I mentioned, removing the drives, so I'll kind of do a little highlighting here, but removing the drives from Mac systems is a challenge in itself. So a lot of times we're not even worried about that, and you can do it directly against the device. But that is certainly an extra challenge here, is that you need that hardware encryption that's built on the board with the T2 chip to decrypt it. So that's the first level of encryption. And then typically what's also enabled is going to be essentially a volume-based encryption. And that's going to be based off of the user's passwords. There is a file vault that takes care of the user's drive as well as the startup volume. And so it's essentially going to, essentially going to encrypt everything really of interest to us. And so we need the key to be able to get to that. Now, the key can be in the form of the password of the user, or it can be in recovery keys. So there's two different types of recovery keys. There's what's called there's actually what's called the institutional key, which really gives you the ability to use across multiple systems if you're deploying that kind of with an MDM solution. And essentially one key can unlock all the hosts. You can imagine that that is a pretty darn sensitive key, so it might not be the best idea to necessarily do that, but that is an option. And the other one's called more of a personal key or individual key, and that is on a system-by-system basis. Now, MDM solutions, modern mobile device management solutions, generally all have the capability to escrow these keys and keep them for an enterprise, and so that's highly recommended that you do that, and that can simplify your ability to decrypt that drive if you need a full disk image from a dead system. Now, as I mentioned at the bottom, generally we're really focused more on live response anyway. So both of these encryption technologies may not come into play that much, but in certain circumstances they might. And we'll talk about another technology in a minute called SIPs, System Integrity Protection, which makes things a little harder to do the live analysis. So that's one case where maybe it does make sense to fall back to full disk imaging, even though it's slower for incident response, but it still gives you access to all of the data. All right, so that's kind of data at rest, encrypting that disk both at the hardware level and kind of user level in a sense with almost user-based encryption, but really covering that whole volume. Next is system integrity protection. Now, this is data in motion. This is protecting the operating system as it is performing its duties, it's up and running. And so this gets into the area where Apple is really trying to lock down this host and make it more difficult for malware, for malicious activity to occur. And it's certainly worked. It does make things more difficult. This system integrity protection in particular is implemented through a technology called mandatory access control, which really gives you the ability to do permissioning beyond just your standard user group, other, read, write, execute. There's other labels, other levels of security that can be applied, and it really kind of can lock down files and lock down processes from doing certain things, even if those processes are running as root. So this provides a lot of protection, even if the attacker has gotten root access. Now, for us, as analysts who may have root access, it also prevents us from doing some certain things that we would like to do potentially. Now it does lock down, a number of files to be able to modify, and it basically there's certain locations within the file system that it really locks down. For example, the /system directory at the root of the operating system, root of the file system, is pretty locked down. Parts of /user, parts of /bin and sbin. But for the most part, they're locked down from editing, not necessarily from viewing and reading. And that's good for us because actually it means that, like with Velociraptor, for example, I've only found a few cases, almost edge cases, where I couldn't do a particular analysis, couldn't read a particular file when it had what we'll call full disk access in a moment, but even with system integrity protection enabled. Now, all that said is there might be times where you do want to disable it, and it can be disabled. You have to go and reboot the system into recovery mode. And in that case, you can disable system integrity protection and get access to all of those files, including the ability here to do a live full disk image, with tools like, FTK Imager or FResponse or some other tool that would give you, that full access, which you cannot do. You can't access that full disk drive device if SIP is enabled. Okay. So keep that in mind, but nevertheless, that is some restrictions, and you will run into it probably with doing a lot of analysis. However, I'm seeing most of the time it's not really going to slow us up from doing that analysis. That said, you may want to disable it for one reason or another for live analysis, for the full disk analysis, so you can potentially do that temporarily, or maybe this is a scenario where you want to actually just take the system down and do a disk acquisition offline to be able to look at it, because SIP is only impacting the live running system. Once it's a dead disk, we can see everything. Something to keep in mind too, where this may be more likely that you would want to be able to get to that level. These are kernel level protections, and being that they're kernel level protections, they're going to prevent our typical tooling from accessing certain files. But the problem is that there have been more exploits against Apple recently that I can remember, especially from a kernel level. There was a pretty big one, a 0-day announced just 3 days ago, and there was another big one released last month that had some active exploits in the wild against it. So you can imagine if the attacker has the ability to run as kernel, it's going to be able to access any of these locations at once. It could even actually set up policies that could prevent us from seeing the malicious data that's kind of secured by system integrity protection. Okay, so something to be in mind, to bear in mind that even though our standard visibility is pretty good, even with SIP enabled, there might be times where we really need to go that deeper level and make sure we're seeing everything. Okay, here's the next one, and this is definitely one that's going to impact you pretty quickly without taking it into account and making sure that Velociraptor, for our intents and purposes, has the ability to see pretty much all of the files except for the few that are even locked down by SIP. Okay. Now, what do I mean by that? Well, transparency, consent, and control is another feature of Apple that they've implemented for several years and kind of continued to implement it more and more significantly over the years to really lock down applications' ability to use and access private data. So for our purposes, that really boils down basically to the files. Which files can we access, and are we being prevented from seeing those files? But it also, of course, affects devices for Zoom or other apps. If you're using Macs, you're really familiar with having to give access to the camera or to the mic to applications like Zoom to be able to use them. But for applications that are accessing data on the disk, you have to give that same access. So whether it's Office apps or even the terminal itself, like seeding into the user's documents directory, you get a little pop-up saying, do you want the terminal to access your documents? And you have to say yes if you want that. So that is going to secure all applications, right? Security applications included, and certainly Velociraptor as well. Now, what this means is that without taking some steps, we would be able to see important locations like users, documents, downloads, desktop, iDrive cloud removal volumes, network volumes. All of these places are secured by this feature called transparency, consent, and control, where the user is prompted to provide approval to access these sensitive locations. So we'll walk through in a moment how to set this up. Unfortunately, this can be implemented and kind of provided access to our security tooling through policy, through MDM solutions. And it can also be done manually. So I'll walk you through the manual steps as well. But it does need to be done because by default, there's no access to those areas. And I mean, if no other area, you can imagine something like downloads being a pretty important part. If we're doing an IR case, maybe the attackers accidentally downloaded a malicious, executable or script or something, and we need to kind of validate that, verify where it went. So I want to bring up a note here, and then actually one other note. Let me go to the other note for a moment too. So in this link, that's the reference at the bottom is it's a link to a different location, but I want to bring up one document, and because I've seen this a couple of different places, even in Apple. So this is straight from Apple, indicating what locations are secured by transparency, consent, and control. Okay, so they mentioned here documents, downloads, iCloud, iDrive, network volumes. Somewhere else I've seen removable drives as well. And here they're talking about basically how the user can give access to those locations. In some cases, the user is going to be prompted by the application. So if it's individual files and folders within, say, the desktop or downloads, the user is going to get a nice little prompt to say, hey, can you, do you want to allow terminal or do you want to allow Word to access those locations? The user can say yes or no. But in some cases, for more, full featured access, in other words, if you just want to wholesale say, give all access to these locations to a file, there's no prompt to to request that of the user. That has to be manually set, either through policy or by the user specifically going into the security and privacy applet and specifying that they want to allow that application to have what they call full disk access, which is a little bit of a misnomer because it's not full disk. There's some things they can't do, of course, based off their own permissions, and then SIP as well. But by full disk access in this context, it means all of these things: desktop, downloads, documents, etc. There's one other reason, though, I brought this up, and like I said, I've seen this a couple of different places, but I've recently done some testing. I'm just not seeing this, but it is an interesting point. And it says that items in the user's trash are protected from any apps that are given that full disk access. The user won't be prompted for app access. And if the user wants apps to access the files, they must be removed from the trash to another location. And that's kind of interesting too from IR, right? Because maybe the user did download something malicious. They didn't realize it at first, and then they got a little scared, like, oh, I shouldn't have done that. I'm just going to delete it. They put it in their trash folder, and now we can't necessarily see that or can't directly recover it. But despite seeing this here, and actually, like I said, well, at least one other place I noticed this, with Velociraptor, I've done a couple tests and have no problem actually extracting the file out of the user's trash directory, as long as we've taken the step to give full kind of disk access. They call it full storage access here, but it's really full disk access if you see it in the UI. As long as I've given that, I can get to the user's trash directory without a problem. Okay, there's one other point here. Now this one's this reference below, I won't take the time to go through it, but definitely check that out. And by the way, I forgot to put it up there, but I do have this presentation available for download. If you go to DFIR.2/VeloCON 2022, you can download this presentation, and I'll have a link to it at the end as well. But this one's a really good one from Phil Stokes at SentinelOne. And one of the things he points out is a little bit of a caveat that a lot of administrators and users may not realize, is that even if you don't give an application this kind of access to certain locations or even a full disk access, turns out applications, including malicious apps, can still write to those locations and they can read what they've written. They just can't read other files without being granted that access. Okay, so why is that important? Well, possibly if our tooling doesn't have that visibility in those locations, the attacker could be kind of writing to those spots and basically being able to write their own data, but we don't see it, right? Because we don't have that visibility. So multiple reasons that our tooling should have this quote unquote full disk access. Okay, so full disk access, quite easy to deploy with MDM. Again, it is kind of a misnomer because they don't really give you full disk access, but it gives you access to all of these kind of privacy locations. What if you need to do manual installation? Well, let's pop through that here with a few pointers, because in some cases you might need to do it manually, and there are definitely a few gotchas, a few pitfalls that you could fall into if you're doing it manually. All right, so what would be the process? Well, first you want to install Velociraptor's root. So just like always, kind of build this config, and we do the installation here, service installation or service install. And what that's going to end up doing is copying over the binary to user local sbin, and it's going to put a persistence method called a launch daemon and library launch daemons. So it'll start automatically going forward. It's also monitored that if it crashes, it will restart. Now that's getting us Velociraptor up and running at that point, but we still don't have full disk access. And so if you're doing this manually, here's an important caveat to doing it. You're going to have to coach the user into providing full disk access to the Velociraptor binary. If you use the default location, then it'll be in user local bin. Apple does not provide a CLI option to do this because that would defeat the purpose. It would allow for automation. It would allow for users to not have that transparency and that visibility that this application is accessing these sensitive locations. So you can understand why Apple did that, but it is, from our perspective, definitely a pain. So we will show you, I'll show you a moment, a slide that's got some resources on how to do this through MDM solutions, but if it's manually, you're going to have a user set this up. Third step could potentially be disable SIP, and like I mentioned, there might be some cases where you want to take that in consideration and do it. Okay. All right, so let's talk about a couple of hiccups first. If you're doing this manually and downloading through standard method of going on the browser, going to GitHub, Apple's like Mac have this concept of mark of the web that indicates that a file was downloaded from the internet, and it tags it with and puts it into essentially a quarantine, or not into a quarantine, but it's given a what's called an extended attribute that says this was in the quarantine, it came from the internet. Now, a couple different things we could do. If one is you could just avoid downloading it from the internet directly with a browser. You could do something like curl or git instead. Or you could put it into a central file server and make sure that the quarantine extended attribute's removed and share it that way. If it does land on your system though, and you're getting this message that can't check your software, and there's really nothing you can do but say, okay, I guess I can't run it. Well, in that case, actually, what you can do is you can go into security and privacy, just in system preferences, on the general tab here, and then just say allow anyway. That's that's one method. Another option is at the command line, you can strip that quarantine extended attribute by running xadder -d com.apple.quarantine and path to your Velociraptor binary. After you do that, you still may be prompted the fact that Velociraptor can't be checked for malicious software. Do you still want to open it? And of course, you would say yes in this case. Now, part of the reason we're getting this is because Velociraptor doesn't currently have an Apple signature, like a notary, a signed Apple signature. But of course, all the code from Velociraptor is signed. It's get those signatures when you download it from GitHub. It's just not using the Apple signature process. I was chatting with Mike yesterday or the day before, and he said he's been actually talking a little bit with Rapid7 about how they do it. So maybe we'll be able to get it officially signed through the Apple developer process. But in any case, you can still validate the code yourself, but you can just get this message from Apple that it's not signed with their signature process. Okay, so that's one potential hiccup. What's maybe another one? Well, here's another one, is that the default location to install Velociraptor is user local sbin. And user local sbin is not there by default. It is a common place to put, static binaries into the user local, but it's not there by default. So if you do a root installation, which you would to get this here, then root's going to create this directory, but it's going to create it so that only root has access to it. Now, the problem there is if you need to go and coach that user through, hey, I want to give full disk access here to Velociraptor, it's not going to be able to find Velociraptor because the regular user doesn't have rights to read it. So just a simple little kind of glitch there, but I just want to point it out because you might run into it. And so to fix a couple of different possibilities. One is you can just make sure you give read access to that user local sbin as part of your process. Then at that point, from full disk access, the user can click on and browse to sbin and find Velociraptor and add it. And then we'll be able to check the box. And from here, you've got Velociraptor having full disk access, at least in the TCC sense of the term, to be able to get to documents, downloads, desktop, etc. Okay. So one other possibility here is you could just change the installation path to a different location, somewhere that the user already has access. This is just the default, but that can be configured in the config file. Now, an important thing to think about is if you're not sure if it was set up rightly, maybe you've kind of written down some instructions provided to others, and you just want to see, did they do it correctly or not? How could you tell? Well, definitely one way to be able to tell is to go to a user's documents or desktop, try to, with virtual file system, try to enumerate those files. And if it just spins and does nothing, well, that's a pretty good indication it's not working. that probably doesn't have full disk access. Maybe the better approach too is to just run TCC, the transparency, consent, and control. This is an artifact I think that Wes put together, and it allows for querying this database. The SQLite database, if you have been given TCC access, you can query it. It's not protected by SIP, fortunately. So as long as you've been given access to full disk access and are running as root, you can query this and you should see results. If you're not seeing results, then definitely we don't have the visibility we need. So you got to kind of go through, make sure that that's set up for full disk access. Here's an example of what it should look like when it is configured properly. And in this case, we're seeing, first off, you're just being able to parse, all of that data in that SQLite database. And specifically, we're seeing that, yes, Velociraptor is included. The policy is for all files here. That's important. So, so we're good to go at this point. All right, I'm not going to go deep at all into the MDM option. That's really going to vary from organization to organization what they're using. But the key point is that Apple does provide the ability to kind of adjust all of those privacy locations. This is some of them here through privacy preferences control privacy. That's hard to say. Privacy preferences policy control. And so any MDM has the ability to kind of modify that and specify, exactly what applications have the ability to do things like access all files, right? All user files in particular. And so that's really the setting you'd want to do. There's other there's a number of guides out there. What I linked to here is the Apple documentation specifically, but that's just something, you'll work with your organization. I know in my organization, we have a number of different things that are kind of configured by default. So if you have much of a Mac fleet at all, I'm sure you've already, got a team that's pushing policies out like this, and it wouldn't be a problem to get it set up. Okay, so so that's some background and a lot of background about the hurdles of just getting to the analysis phase, and that's a lot of what I wanted to cover. Now I'm going to hit a few things here probably pretty quickly, just based on time. But that's that's a big part of doing the MACs. They do lock it down pretty well. And I'd say that's a good thing, but it's also a frustrating thing from a from a security analytics or an analyst view, right? So if we have to deploy a tool in quick form, then that can be a bit of a challenge. But those were some ideas about how to potentially handle that. Okay, so let's look at a few areas of the Mac that can be give you some quick wins and just see some of the capability that's built into Velociraptor specifically. And then the last one is one that's kind of like something for the community we can all work on, maybe figure out a good way to get logging. I'll just give you a heads up that that's logging. But first and foremost, one of the main things you're going to encounter a lot when you're doing Mac forensics is property list, plist files. Okay, so the plist files are little bitty Windows registries in the sense that they're little configurations files. You can also think of them like back in the day with Windows, it was .ini files, but they're generally used on a per application basis or on user basis to track things like most frequently used applications or files, all kinds of things. Like pretty much if you're a Windows person, you think about what the registry can store. This is kind of like the registry broken apart into tons of little files that are stored in various locations across the file system. So it's important we can parse these out. There are two formats. There's the older XML version, and then there's the newer binary version. And we can handle both of those within Velociraptor. So the macOS system plist artifact, you just point it at the plist and can go and kind of pull out that particular data here in sort of a JSON structure. In this case, we're looking at the system version information and seeing kind of what the build is for this version of macOS 12.4 here. On the right, you're just seeing what those format of those files look like if you were to kind of look at them, in a text view, or in the case of XML. You can even see, I think just barely got it in here, but it actually says it's a property list in there. And then the binary property list start with BP list as the kind of the magic magic signature or file signature there. Okay, what about the Apple file system? So Apple migrated to their current file systems, big update from HFS Plus they had for like 20 years. They updated in the 2016, 2017 timeframe. I think that fully went into production in 2017, and it started with iOS first, and then it went to Mac OS later in the year. It has a lot of functionality like for direct support of both encryption and solid state drives. So you can, knowing what some of their focus has been, that makes total sense. It has 64-bit, timestamps, 9-second resolution, all 4 timestamps, MACB. There is no journal that's tied to it. So that's a little bit of a bummer because we do often look at journaling as a way to kind of get a hint about what's happened on the file system. But we'll get to another artifact in a bit called file system events that gives us that same visibility. So it's really not a big deal for us from a forensic standpoint for the most part. It has native support for snapshots, and that can come into play both with Time Machine, which is not on by default, but a lot of users and organizations turn it on. In that case, you'll get a kind of a short-term local set of snapshots for Time Machine. And then file cloning feature, which is a pretty smart feature, which allows the operating system to, instead of actually copying data for copied files, just basically create a new inode for the file, for the copied file, and point to the original data on the disk, so that it's not having to, literally copy and use the space and take up the time. They use differentials and snapshots to handle that in case, one of those files changes. It can just update the blocks that have updated. So there's snapshot functionality built in. Now, I'll point out here a really useful, I'm a huge fan of file system timelines. I think you can learn a lot about what's happening on a system in a time frame of interest, just based off of pure file system timestamps. So we can do that with Velociraptor. Generic forensic timeline is kind of multi-OS support. I did make a custom one though, because what I noticed is it didn't have the B time. I want to grab the B time and put that in there. So it's just a simple update to add that column. Maybe we'll end up updating that forensic timeline artifact just to get that by default, but that's definitely handy. Okay, another artifact that's built in there is to query users on the system. And there's a couple different ways to do that, actually. One is for this location in private var DB, DS local nodes default users, and it ends up having a whole lot ofplists in that location because there are a whole lot of built-in user accounts, and each user account is going to have a plist. It's going to have a little bit of configuration about that user. And most of these you'll see start with an underscore, and those are kind of backup, or not backup, but system, built-in system accounts or added system accounts for various services. The ones that are shown here that are more or less your standard user accounts, there's root and user in this particular case. Down here at the bottom that was parsed was root and sans DFIR. And so you get a little bit of information here again. Notice it's got the user shell. That's kind of cool. So for sans DFIR, it's been as ZSH. And another thing that's not shown here, but it's kind of interesting, is you actually have the password hint that can be parsed out of this as well. Now, one thing to bear in mind, if your organization is using some type of directory service for logging into your Mac systems, then these are not going to show those accounts. These are for local accounts. So to kind of validate, cross-reference, check what other accounts might be there, you just do a directory listing against /users, see if there's any differences, and that would totally make sense if you're using something like AD to authenticate the users. All right, persistence, hugely important. Kind of every case that we're going to work with, it's any advanced persistent threat, right, is going to have some persistence mechanism. Just like other operating systems, there's a ton of locations where this can take place. I'll just go ahead and skip and show you this. The link there, I got to show it to you because it's pretty cool. Just like the good old REM keys, if you're familiar with that in the Windows world, a gentleman here has done a similar blog series called Beyond the Good Old Launch Agents. So Beyond the Good Old Launch Agents, this is the first 10, and then we go back here, they're up to about 30 just about. So lots of different places, lots of different locations that we could end up having attackers kind of put backdoor startup locations. The launch agents themselves, that's how this article or the series was named. That's your most likely scenario, right? That's like equivalent to maybe a Ren key, or probably in practice, it's more like your services for Windows. It's going to be things that can automatically start. Honestly, it's kind of even more like maybe scheduled tasks, because there's a lot of flexibility in how these launch agents can be created. But there are really scheduled tasks in the case of like cron jobs. On the previous page, there was periodic, which is kind of related to this. This is launch items, which is almost like a run key. That's something that's easy also for users to set up themselves. Shell, anytime we're talking about Linux in particular, or Unix-based backends, of course, FreeBSD is the backend to Mac. We got to think about shell startup scripts, and there's lots of startup scripts where the attacker could either create new ones or just modify existing ones. Okay, so keep that in mind. Launch D is definitely going to be the most common one, but any of these could potentially come into play, and we want to be on the lookout for them. Now, fortunately, with Velociraptor, we've got some good visibility of this. There's a macOS detection auto runs. It has about 8 of the most common, if I recall off the top of my head, auto start locations, including definitely the launch agents, launch daemons, pretty sure cron, those login items, and there's another 4 or 5. One of the things we wanted to be doing here is just obviously look for unusual names. So if you can have a way to kind of use a gold build, a system that you suspect is nice and clean, you can always do some differential analysis. Now that might not be quite as easy within Velociraptor directly, or maybe you've got a cool trick to do that, but you can always pull this information out, get into CSV, do some different things to kind of diff it, look for outliers, right? Kind of stacking in that sense. Another really powerful technique is going back to timeline analysis and just look and see what has changed. Most of these are going to be configured either by creating new files, like new plist that would go in, for example, the in the launch daemons, as we're seeing here. These are plist files. In fact, this one's for VMware launch D tools plist. That's also how Velociraptor maintains its persistence as well. But looking for new ones, looking for ones that have been modified recently. So here's just an example of taking the notebook and going in and doing an order by M time and just filter, sort by most recently modified, see what's at the top. So that can be pretty helpful there. Of course, if there's anything unusual sticking out, we will start to validate contents. That goes back again towards if you've got a good clean reference image that you can look at, kind of look what the differences are. All right, 2 last topics. So I'm going to go a couple minutes over, but I'm almost at the end. This one's really cool. I talked to Mike a month or so ago about this, and he took a look at the papers, like, yeah, we need this. And by the next morning, like, I think I talked to him my evening, by the next morning he had it. So would have taken me a month to do it. But he created a parser for this. I'll show you in a moment. But what the heck is FS events? Again, I kind of put Windows in there a lot as far as trying to draw parallels, because I'm just so familiar with it. But if you know Windows, it's like the USN Journal. And it's really there for the same purpose, which is to provide hints to the operating system, and not even to the operating system, actually more for applications that are using the operating system that are wanting to track certain changes to files. A great example in both Windows and Mac is the ability to index files. In the Mac world, that's Spotlight. And so Mac wants to be able to look for files that have changed so that it can index the text and make it easy for users to be able to search for that file based off the text in the file. And so, the FS events is what turns into that capability, that process and feature that is watching for changes to files and provides an ability for other applications to subscribe to that kind of log, that API, and get a list of files that have changed, say, within the last hour or last day or something like that. So FS events does work in the background. It is run by FS daemon, FS events daemon, FSD. The data is stored in a bunch of little gzipped log files. Each one can contain up to 5,000 events in the root of the file system in .fs events D, the hidden directory there. This can go for several days or several months, potentially. Just depends how busy that system is. I have some systems that are not that busy, and it goes back months for sure, not even years, honestly. So it can go back pretty far in certain cases. The downside is it's not always enabled. It definitely, I've got some systems where it's just not enabled. I'm not exactly sure why. This is a great research article from Nicole Ibrahim. She does talk about ways to force it to be disabled. In fact, attackers can do that as well. But on my systems, I didn't force them to be disabled. And so I have, one or two systems where it's just not enabled. So you'll have to, and the way I can tell is this directory just doesn't exist. Okay, quick look at a use case. This is, again, very similar to USN Journal. We can look for interesting activity for files and folders. Now, just some ideas out there, how you might use this data. You can monitor and kind of pivot off of folders of interest and see what files have been added, deleted, changed within those directories. So attacker working directory, users downloads and their trash directories, what files have kind of come in and out of those locations. The beauty about this is it's ongoing logs, so you can see those changes over time. Temp directories, and that's actually what we're seeing here. In this example from our Forensic 608 case, there was an attacker had created a .data hidden directory within private temp and put some, some exfil in here essentially. So you can do that by pivoting, kind of, filtering off of folders of interest. Of course, files of interest too, if you do know like specific malware or different scripts that are being used, other kind of indicators and potentially malicious programs, executables, those are all useful things to search for. Archive files, as well as just flat out looking for what's been deleted lately. That might be interesting too. So here's a notebook filter where you can look for the flag FSE _delete. The codes that are, the text code's a little bit different than we're seeing here. This is, in this case, it was just called removed for things that were deleted. This is an example of being parsed from a dead box image using Yogesh Khatri's Mac app tool. Okay, here's that new artifact. It is now in version 6.6. Thank you, Mike, for knocking this out, and it works very nicely. So a big caveat, though, to be aware of, and this isn't related specifically to Velociraptor by any means, it's just how FS events work, is even though we do provide a hint of when things change, you don't actually have a timestamp when these individual files were updated. That is not included in the log. But we can kind of get a hint, we can kind of ballpark it by looking at, well, when is the last time that the file, the log file that tracks this file of interest, when was that last modified? And so that's what this M time is tracking here. The last time that the log file, which contains the event saying this particular file changed, or this particular file or directory, I guess I should say, this ownership changed, or this particular file was renamed, that information is tracked in this particular log file, and that log file was last changed at this date and timestamp. So ultimately, you'll end up seeing a whole bunch of events that come from a single file that have the same last modification time, like these last two is a good example of that. You don't know exactly when this event happens, but it's a pretty good time frame generally. So if I go back one, I'll just say these timestamps absolutely were when our attacker was busy on this system. Turned out the attacker was quite busy on Valentine's Day in 2020. Okay, I know I'm totally going over, so apologies for that. Just the last point here, Apple logging, and this is really just to put a pin in it in a certain sense. Apple logging has changed their logging format a couple of different times. Originally, it was more just standard syslog clear text. Then they moved for a short while to Apple system logs, which is a binary format, a little more efficient, I suppose. But then they relatively quickly have transitioned to Apple Unified Log, and it is truly meant to be unified, covering really all of their platforms. And man, when I say logging, I'm talking about some logging here. This thing can go big. In our example 608 Mac image, which was only a 40 gigabyte image, the whole thing, it produced 38 million events and 12 gigs when you parse out in CSV. Now, how does that happen on a on a 40 gig image? It's because the binary format is very succinct and very efficient, but there's tons of flags, and when you pull those flags out to make meaningful logs, like in a CSV, they become quite large. But regardless of, the size of that CSV, the point is 38 million events, that's a ton. All right, so how can you look at that on a live system? The log file, the command line, or the console app. And then, so the last point, and this is really just kind of for future thought here, like what we might be able to do. We don't have a good artifact for it right now. I had some chats online with Matt Green and Wes, and we were thinking about some different ideas. Both of them actually pointed me to an excellent new tool that just came out a couple of weeks ago from Mandiant called macOS Unified Logs. Yogesh also has a parser in his Mac app tool for this. So you can pull the logs offline and parse them with these tools. Okay, so that's one option. And we could do that with Velociraptor. It's a pretty large data set. If you run this log collect command, maybe through, kind of directly on the system, spacing out here for a second, but the kind of the live collection through Velociraptor, you could run that. It would generate a directory. You could kind of zip that up, bring it back, and kind of parse it. But it's a pretty large data set. What are some other options? Potentially just doing some queries on the live system. So here's a couple of examples of using that log command to do filters, for example, keyword searches in this predicate syntax, saying event message, for example, contains Velociraptor. Or this is one that Matt suggested, you can get a little bit more detailed even by having an or statement in here and kind of do maybe some ors and ands. This is an example from a reference link I had back on slide 14 for TCC, where you're troubleshooting TCC specifically and looking maybe for some keywords and even begins with. So what other possibilities? Stretch goal here, maybe we could somehow stream this back. So Jamf, very popular MDM tool, has this capability. They're using the logging API, from what I can tell, to stream that data back. And they've got this article here on how to kind of use this predicate syntax to pull logs of interest back through Jamf and then onto your SIM, for instance. All right, so I went over, sorry about that, but I had a lot I wanted to cover, and hopefully it was useful to you. I know, some of that's basic if you've been doing this with Macs, but a lot of us, are just kind of getting our feet wet, honestly, with Macs. And so I think there's a lot of room for us to keep exploring, keep doing different things. I'm definitely interested in keeping the conversation going and kind of contributing some ideas and maybe even some artifacts if I can get my VQL together. So anyway, thanks to everybody. This is such an amazing tool. I just love Velociraptor. And always happy to kind of try to contribute in my little way. Again, there's my link to the article. It's got some to the presentation. It's got some links that you might want to take advantage of. So I'll turn it back over to you guys.
Thanks a lot, Mike. Does anybody have any questions for Mike, either in the Q&A or in the Discord channel? Pop them in there. I want to thank Mike for a great presentation. As a Mac user myself, I found this presentation to be very pertinent and engaging. So thank you very much for that.
All right, thank you.
All right. Change our screen here. All right. So folks, we've got one more presentation to go, and I am nominating Wes Lambert as the MVP of VeloCON 2022. This is his third presentation of the day. It's he's spanned pretty much the whole day today, and was willing to step up and fill in if folks weren't able to make it. So thanks a lot, Wes. I'll just turn it back over to you for the last presentation of the day. Take it away.
Yes, sir. Thank you. And thank you, Mike. That was awesome. I really enjoyed all the stuff about macOS and all the new stuff that we're getting in there, and so really looking forward to that. But let me go ahead and get my screen share here and start my video. Okay, well, my video won't go, but that's okay. Let's do screen 2, share. And let's see, slideshow from beginning. All right. So once again, my name is Wes Lambert. I am the principal engineer at Security Onion Solutions, and this is the third talk from me today. hopefully by now, if you've been here the whole time, I've not bored you too much. But just want to talk a little bit about how we might approach purple teaming with these things called artifacts, right? Kind of a play on the traditional Velociraptor artifact. So let's get started. So again, the overview for this talk is going to be just talking about purple teaming in general, talking about how we might simulate attacker activity using different tools, how we might do that with artifacts, and then kind of getting into the detection and maybe determining our detection efficacy once we have started doing that, right? So without further ado, what is purple teaming, right? I don't know if you know this guy. I grew up with this guy right here, this purple teamer. But in a general sense, I'll claim that I am not the purple team expert, but just to give kind of an overview or just a general statement, I'm going to summarize it as executing a set of predefined actions or tests to emulate or simulate adversary activity, right? And I know there's a lot of kind of commotion, and there are definitely some nuances between attack simulation and adversary emulation, right? I won't get into all that today, but at the first level, it's really executing that set of predefined tests, right? And then after that, we want to be monitoring and determining our detection efficacy, right? Like, did we detect this? Our detection's working, and then adapting as we need to, right? Revising our detections, or going from there and making the necessary changes. So it's that's how we're going to describe purple teaming today, at least. And maybe it's not the most nuanced description, but we'll go ahead with that. So why would an organization, or why would team member security professionals want to engage in purple teaming? We have red teams, we have blue teams, each with their own kind of specialty, right? Their own ways that they affect organizational security and protect organizations, right? So the main thing is really going to be to test those attack chains that maybe the red team, or maybe that the blue team has modeled or threat modeled against the target organization, right? Really, aside from that, is training the blue teamers as far as learning those more red techniques, right? Learning the ways that attackers might attempt to to do things within the network, bad things, and then just ensure that TTPs maybe that have not been tested before are tested, right? Testing the interoperability between security teams, really just fostering overall that collaborative culture between the red team, the blue team, and having them work together to make the organization safer in general, right? And even if it's just a team of one, maybe, or a team of two, having that knowledge and being able to kind of go forward with a way to test those detections and ensure that the detections we have in place are working as we expect. And a great resource for this is Scythe has a great resource called the Purple Team Exercise Framework, or PTEF. It's a great way to kind of go and follow the framework and get an idea of how you might approach this in your organization at a more specific or a more detailed level. Initially, it starts with that cyber threat intel, and then preparing with detections and things like that, and then executing those exercises, and then taking those lessons learned and going from there. And that's at a high level, right? So digging into that a little bit more. These first two I'm going to ignore a little bit, but these other ones I'm going to touch on primarily. But these are the steps that are really outlined in the PTEF V1 summary, right? Like, basically, what are we trying to do when we're purple teaming? Like, what is it? What are we going forth and actually doing? So what we're going to focus on here is the red team, or really ourselves, emulating the TTP, the blue team, ourselves, right? And DFIR analysts, right? Following the process to detect and or respond to the TTP. And then just reviewing to see if those TTPs were identified, documenting the results, going, seeing what worked, what didn't, and then repeating the tests or the TTP, right? And just, continually going and revising from there while testing newer TTPs against the organization's security posture, right? So we'll iterate on that a little bit. Now, I did say, right, purple teaming on your own. So I put out a brief Twitter poll about this because I knew there would be some people that want to get really specific and, you know, are purists, I'm sure. And, you know, again, I am not a purple teaming guru, but I basically asked if one person can facilitate purple teaming, right? If we identify that as purple teaming, or if it's just adversary emulation or attack simulation and determining detection efficacy. I guess they're all the same, but I did get a majority response of absolutely. So therefore, I did continue with this talk. I did not cancel and walk away in tears. So continuing with that, we're going to talk about simulating that attacker activity. Okay. Now, one popular way to simulate attacker activity is going to be using atomic red team, also known as ART. Now, what ART is, you know, basically, this is their quote. It's a library of simple focused tests, and they're all mapped to the MITRE ATT&CK matrix, right? They typically run 5 minutes or less. Most of them come with cleanup commands, so it's very convenient if you're running something in an automated fashion where you don't need, you know, you don't want to have to go behind and do a bunch of manual stuff. And the way that this is leveraged in a somewhat automated fashion is through the use of VeloCON, which is a PowerShell-based framework for developing and executing these tests. Right. So this is how we take the tests that are defined by the community and defined, you know, by various members, right? And then we take those and execute those on a host. How we actually apply these tests to a machine. Here's an example of an atomic test. This is the number one, modifying the registry of the current user profile using CMD, right? Or I'm sorry, command, right? So this is just a regAdd command, right? You can see the various things down here. So just running this essentially, and having that added to the current user profile. So this is something that can be automated, right? Like a machine can do this, VeloCON can do this. We don't necessarily need a human at a keyboard. We don't necessarily need multiple people to go and do this. One person can do this. So let's talk about how we might leverage atomic red team and create an artifact, right? Something that actually uses these tests and applies that logic. So the goal with our artifact is going to be similar to before, right? Execute the predefined tests to simulate attacker activity. And we really want to focus on being able to automate the test execution or to schedule this, right? I mean, we may not be able to do this, all at once. We may not be able to just sit there the whole time and, babysit tests, things like that. And we want to make it easy. We want to be able to do everything from a central location. We don't want to have to be logging into boxes, going to one place or another, trying to look up different things and do different commands, right? We want it to be easy because we're one person, right? Or maybe we have just a couple person security team. So this is a way that, or this is our goal essentially for our artifact. Now, the requirements, a little bit further, is really being able to select the test we want to execute, right? Maybe we don't want to execute every single test every single time. We mentioned before that we might want to focus on those particular TTPs, maybe, certain type at a time, certain categories of tests at a time. We usually don't want to run everything at once, right? There's a purpose to this. It's to kind of iterate through our detections, iterate through our current posture and see how we can improve that in a process-oriented fashion. So aside from being able to select those tests that we want to execute, we need an engine to execute these tests, right? So we've kind of got an engine in VeloCON, right? So we can do that from a PowerShell command. It'll go off and run the test and then come back with the results. But how do we take that and invoke VeloCON, right? And then we need an environment where these tests are executed. Now, I recommend that you don't do this. I wouldn't test in your live production environment, but Obviously, something modeled after your production environment where detections are able to be replicated, right? The same or similar state. And as I mentioned before, we want the ability to schedule these tests. We want to have control over the execution and whatnot. So enter, with great power comes great responsibility, the Windows Attack Simulation Atomic Red Team artifact. Now, this artifact is pretty cool. It allows you to take these atomic red team tests and invoke the invoke atomic command to execute these tests. And we can schedule this if we want. Obviously, we can select which clients that we have modeled, which things that we want to apply this against. But I want to be very clear in that when you execute these, it's typically not a good idea to run all the art tests at one time, unless you're just having fun, or you just want to blow things up. I would try to stay focused really on what you're looking to test, right? And another thing is I would really make sure that you have permission to test before you begin. Again, I would make sure to have a dedicated system at least to test this against, instead of running this on a production or live host. So how do we get this artifact? This artifact is actually automatically generated by a Python script. I did not enter 1,000 atomic red team tests into the artifact manually, because that would be very time consuming to update, right? If updates came out, you have to go manually hand jam that in. It's just not really efficient. So there are a couple artifacts that are already automatically generated by a script. I think the Cape files targets one is generated. Might be able to answer that better, but this is just an overview of the script that is actually used to generate the atomic red team artifact. So you can just see here that it'll iterate through all of the atomics that are pulled down from the atomic red team repo, and then it will generate tests for each one of those. And then here's the gist right here. We can go grab that if you want to experiment with it and go run that yourself. But essentially what you would do is just pull down the script. And then I have an example here where you just run it with a /, just straight up art2 artifact.py. And then what happens is in the resultant directory, or in the same directory, you'll see the atomics that get pulled down. Don't really clean those up, but this is just to get the artifact built from the most recent source, essentially. And then you can see that the artifact is built, right? The custom art.yaml. So it's pulled down. We pull in all of the latest atomic red team tests, and then we update the artifact with that. And then what happens is you'll see that in the artifact, there are lots of different tests, right? So there's these particular techniques, right? These technique IDs, and then specific test numbers. There are actually multiple tests for some of these, right? So this will actually go through and tell you the number of each test for each one here. And then what you'll see over here on the right is just a table. So this is used in some artifacts also when you have when you're trying to match things against each other, right? You're trying to use it like a column in a CSV. You can use this table to essentially match what you actually want to run. So if I select this test over here, this command will actually run in the artifact. So while you're not running multiple tests at a time in line from a single command, it gives you a lot of flexibility in what you want to be able to run and specify within that collection. Now, we talked about the artifact that we built, right? We can spin it up from that Python script and get the latest and greatest atomic red team artifact. But what about detection, right? How do we detect this stuff, these tests that we're executing? How do we detect this activity? So one way is through the use of EQL. And you might seem like that's kind of weird that I'm talking about EQL and Elastic. I might think the same first time I saw it, but EQL has a fairly structured rule language. It's also got a great way to annotate what the rules mean what they're looking for, and it's really designed, EQL, or was designed for security use cases, right? So there's a large repository of rules already available. There's a consistent data model. Sometimes with, although it's, there's Sigma, right? I know a lot of folks think of Sigma as far as universal, universal rule language. Still though, like some of the data model, because of the various backends, is not quite clear in every case. So, we're focusing on equal at the moment, EQL. Here's an example EQL-based detection rule, something that you might use with the Elastic Stack or something like that. Just looking for image load via Windows Update, right? And you can see the different details here: risk score, rule ID, whatever, some tags. And you can also see the query here, right? The actual EQL query. So that's pretty cool. I mean, but what does that mean? I mean, why do I care, right? The cool thing is that Mike did this a while back, and I spoke with him a bit on this. I think this could go a bit further, or still could be improved. With some newer folks getting eyes on this, I think it could really flourish. But the equal to VQL project was really something where we take those equal rules, the EQL, and then we convert that over to VQL. And so what it's called basically is converting the EQL rules into a detection matrix, right? And then from there, we're able to convert that into our natural VQL queries and go from there. So it sounds cool, it's probably kind of complicated, right? So we'll get an idea right here of how that happens. So in this repository, there's a Windows Sysmon detection and a Windows Sysmon event detection artifact that basically, if you run this script right here, it's going to essentially convert these EQL based on the log provider, the ETX log provider, take these rules and convert that into an artifact, right? And the same thing with event detection, the main difference being that the first one is going to be just a straight up, just run it, right? The event detection is going to be a client event artifact. So that's two different ways right now that you can generate that and start experimenting with that. And this is kind of what it looks like from the the conversion, right? Now this is on Sysmon data, keep them in mind. So like you'd have Sysmon installed and whatnot. But you can see now the difference and the transformation here from the EQL natively to the VQL, right? And so we can see how this is implemented in Velociraptor and how this is converted. And this is what it looks like essentially. So the resultant artifact is, when loaded up inside of Velociraptor, this is the event detection one. So this is going to be watching for, clients are going to be watching Sysmon logs basically, and then generate these events and bubble them up to the server whenever anything is noticed. Now, we'll see it's really just a bunch of different, a bunch of different queries, right? A bunch of different queries, and I could scroll down through that artifact and you can see all the different sorts of queries, but essentially every single rule, right, that was in the EQL repo, at least the one that we were sourcing against for the Sysmon data, into here. All right, now aside from that, let's talk about actually putting this into practice and maybe determining our detection efficacy, seeing how this actually works in our environment. As you can see, we've got kind of a notion of the atomic red team tests being deployed out to some workstations, and then Velociraptor processing that, right, and alerting us to anything that's strange. Well, the first thing that we'll want to do is, at least for this data set, is we'll want to make sure that Sysmon is installed. And a great way to do that is actually using the Windows sysinternal Sysmon install artifact. It's built into Velociraptor. You may need to customize it for your environment, especially maybe the Sysmon config, right? You might have a certain config that you want to use. I would definitely recommend that. But that's the first thing that you want to get in order, is to make sure that Sysmon is installed and running, right? So that we're actually generating the data whenever we run the tests. And the next thing that you want to do is actually enable the client monitoring artifact for the event detection, right? We want to have that enabled so that whenever we're doing our tests, we're actually watching for this activity and we can see the things that we're looking for, right? We'll get those rows returned as results. And then we'll want to run the atomic red team tests, right? We'll want to configure a collection, and this is really cut off here. I mean, you could scroll down like for days and select whichever test that you want to execute here. And there are also a couple different options here that you can leverage. The first one being install art. This is going to be typically selected whenever you want to install the actual execution framework. It's usually on the first run. You don't necessarily have to do that after the fact unless you reset the box, or something else like AV maybe removes it, right? So another option that you might want to be aware of is remove exec log. So what this does is actually removes the previous execution log from the atomic red team attempts. That way we're not, we're cleaning up after ourselves from the execution perspective and from the results perspective. And we get a clean slate and a clean result set whenever we run it again. And that execution log file by default is in the C Windows temp art exec directory. And this cleanup option right here, again, this is to clean up. This is the invoke atomic native way to clean up the execution artifacts. So usually you'll want to make sure to have that selected unless you have a compelling reason not to. And again, this run all, I don't necessarily recommend it unless you're just playing around, playing with it and trying to generate some detections. But those are really the bulk, aside from the tests, that you'll want to be aware of, the bulk of options. Now, when we run this test, we get a couple things back. It's pretty cool being able to see, actually what tests executed and some different details about those tests. So whenever we run it, the actual artifact, we'll get things like the execution time. We'll get a technique column right here, which is pretty cool. If you actually click on that, it will provide you with an external link to the technique, right? And we'll also get the test number and test name, and then of course the host name, username, and test GUID, right? So these are all different things that we can do to validate that the test actually executed, right, successfully without failing, and then have that kind of information to give to somebody else or to review later on what we actually ran against this box. And then after we've done that, we can review the actual detection results. And this is an example from the event detection. Again, this running on the client. So we're detecting anything within that sysmon log using all of those those VQL queries converted from the EQL queries from those rules. And then we can go off and compare that, right? So we can see what worked and what did not, right? And then we can adjust that as necessary, maybe running the correct test or making sure that the correct detection mechanisms are in place. We have different rules that we want to have implemented. We have the way that the environment the way that we want it. Now, I do want to talk about some detection alternatives, right? So while EQL to VQL, these types of detections are great, there are alternatives that you can also run, again, in a one-shot or convert them to a client event monitoring fashion. And one of those is going to be Chainsaw. So it's a great way to use Sigma against those Windows event logs, right? Things like sysmon logs to do similar things and to validate your tests, right? Or to validate your detections, right? So like if you wanted to run this as a client event artifact as your detections, you could absolutely do that. So it's just another way to do that. The same thing with Hayabusa. Did I cut off? Oh yeah. So Eric Capano and Whitney Champion, they did a great job with this one. This is a really excellent, essentially a Windows event log analyzer similar to Chainsaw. It works very similarly, very fast. So another great example. And then even more, another great example is Zircolite, just another way to get at it, depending on what your preference is. Again, all of these could be implemented as one-shot detections or as client event monitoring artifacts, however you wish to implement those, although you may have to alter the artifact a little bit, right, to get those to work like you want. So what is on the roadmap for the Atomic Red Team artifact and or maybe similar things. I would like to update the out-of-box detections for the equal to VQL stuff. I would like to expand on some of that work that Mike did. He did an amazing job with that. So I would like to add to that a little bit and see what else we could do there. I also would like to provide some support for Linux and Mac OS. It's as Mike Pilkington pointed out, Windows is not the only OS in the enterprise anymore, right? So I definitely want to have an effective way to test this against Linux and Mac OS hosts. Right now, it is only supported for Windows hosts, so it's just something to be aware of. And just in general, I would like to refine the behavior and the dependability of the tests. Again, as stated in the artifact header, these may not work all of the time, all the tests. So it's just something that you'll have to, test on your own and see what works for you. And, I would love any feedback or any questions that you guys have. But aside from that, I think that's all I have for you guys today. Thank you for sticking with me so long and throughout various presentations if you've been here all day. Yeah, and thank you, Mike and Carlos and everybody else that's put on such a great conference.
Yeah, thank you, Wes. Another wonderful presentation. That did you 3 for 3 today. So thank you very much. Anybody have any questions? We have a few minutes left. I want to make sure if anyone has any questions, either for Wes or for Mike Cohen in general. Give you maybe another minute just to throw those in there and then we'll wrap it up. Wes, someone is asking if they can have access to your presentations. Are you going to post them online somewhere?
Yes. I'll probably tweet it out. I haven't figured out where yet, but probably tweet it out either today or tomorrow.
Okay, great.
Yep.
Okay, so we have a question in the Discord channel. What needs to be installed on the endpoint to be able to run ART?
Nothing really. I mean, just, you can run it straight up. So, I mentioned before the sysmon stuff, right? If you're looking for those detections, but otherwise, I think it might be like a .NET framework or something. Maybe not. There might be a specific .NET framework, but you're probably compatible. But I mean, aside from that, you just run it and it downloads it and it runs, or it should work.
Excellent. But do you need to push the invoke art?
Oh, right. Yeah. So the artifact does that, right? It downloads it.
Cool. All right, keep the questions coming. This is your last opportunity to pick the brains of really anyone that is still left from the panel. I think Mike Pilkington is still on. If anyone has any last minute questions for him. Okay, so there is a question about we did have a scheduled talk called ransomware investigation using Velociraptor. Unfortunately, that speaker was not able to make it today. He is having some really bad weather. He's experiencing some really bad weather where he is, and apparently just not a stable internet connection to be able to talk to us today. We'll see if we can get that presentation and possibly post it on the Velociraptor homepage, or maybe even post it if we have like a digital version of his presentation. Maybe we can post it on YouTube as well. But we'll definitely look into that. Yeah, me too, Jamie. I was really looking forward to that one. We have a question from Mayo for you, I believe, Wes. Where do you draw all those project ideas from?
I don't know. Some of it's just watching Twitter, I guess, and some of them are just things that I've wanted to do with other tools, or things that I've wanted to accomplish in general in my in my career during like security operations and things like that. Just things that I would want to be able to do, and just being able to leverage how flexible Velociraptor is to do those things.
Cool. I see some typing in the Discord channel, so let it marinate for a bit. All right, so I think we can probably wrap it up there. I don't see any more questions. Okay, so ladies and gentlemen, we have come to the end of the inaugural VeloCON Velociraptor conference. So I hope you all got a lot out of this day. I know I certainly did. I really learned a lot. I will throw it over to Mike Cohen for maybe some closing comments. Anything you want to say, Mike?
Yeah, sorry, I was on mute. Oh, so thanks everyone for turning up. It's been really fun. I've had a great time, and I think that we've had an amazing lineup today. Every talk was, just pure gold. I mean, there was so much to think about, and so much to learn. So I've learned so much, and I'm really glad that the videos will be available on YouTube, and we'll try and get those slide decks up, for those presenters that want to share them, and so we'll put them up on the website, and I hope to do this again next year. Yeah, I mean, it's going to be a yearly thing, right? And yeah, so I think it's just going to become bigger and bigger, because I think when people see like the quality of the talks today, I think it's going to be awesome next year as well. It's been really, really great. So thanks so much for everyone that presented again.
Yeah, and I just want to echo what Mike said. Really just an unbelievable day, just a very enlightening and enriching day. I have a slew of people I want to thank that really helped us put this event together. Really, it's not just something that one person can do, 2 or 3 people can do. Really took a village to put this together. First and foremost, I want to thank Mike Cohen, Dr. Mike Cohen, and Matt Green for helping put together the program and lining up all the speakers and making all the right connections. To your point, Mike, I think we really couldn't have found a better panel of speakers today that really hit each and every note that we were looking to hit today. So thank you for lining that up. I want to thank Rapid7 and the various teams at Rapid7, the marketing teams, the managed services teams, the product teams, really everyone at Rapid7 who kind of supported the infrastructure for this event and helped promote this event, both internally and externally. Of course, I want to thank our panel of unbelievable speakers. I want to make sure that we recognize everybody that spoke today. Just off the top here, obviously Mike Cohen, Matt Green, Wes Lambert of Security Onion Solutions, Christian Hammerschmidt of Apta Technologies, Dan Banker of Motorola Solutions, Luke Fardell of Control Risks, Mike Pilkington of SANS Institute. Thank you again. Each and every one of these topics and every one of these presentations was just spot on. You guys hit home runs, each and every one of you. And most importantly, I want to thank you, the community, the Velociraptor community. Without you guys, Velociraptor would not exist. This event certainly would not exist. This event was for and by the community, and that's what really makes it so powerful. I think if there's one thing that all of these presentations did today, it's really demonstrated, really illustrated the power of the Velociraptor community and what we can achieve when we all come together with a shared goal, a shared vision. And I think today was a real testament to that. So thank you, each and every one of you. Thank you all for attending. One of the questions I've gotten, in the past couple of hours, how long is it going to take for the YouTube archive to be available on YouTube? That's a good question. I know that YouTube usually takes a little bit of time to post-process their videos.
I think the live link is actually still there, right? So you can watch it at any time.
If you have the live link up and running, I think you can go back and rewind it. I think, once this event ends, then I think there is kind of like a little buffer period between when YouTube kind of post-processes the file. I'm guessing, I don't know for sure, but I think at a minimum, I think it's probably going to be a few hours before the full archive is available. But in any event, we'll definitely have it available. We'll definitely tweet it out. We'll post it on the Velociraptor website. So that's going to do it. Once again, on behalf of Mike Cohen, on behalf of Mike Green, on behalf of everyone here at Rapid7 and Velociraptor, thank you for attending VeloCON 2022. We'll see you next year for VeloCON 2023.
Thanks, guys.